Good morning. There we go. Okay.
Steven says, good morning, Vern.
Good morning. Yes, it's Vern, Uncle Buck. Some people call me for reasons unknown. If people keep coming into the waiting room, do they come in themselves now?
No, you'll have to keep admitting them.
Okay.
Yeah, you betcha. So yeah, maybe the first 5 minutes or so, just check
All
back
right.
every minute or two.
Okay. This is the only real tricky part here of this. All right. Well, welcome to Friday version of your training with the Canadian Institute of Home Inspectors. I'm starting off today. We're going to be doing the HVAC module, which is a very extensive module. I'm sure you've read it at least 4 times, like everybody else has. But I want to start off this morning just in regards to what basically what your obligations are as a home inspector to meet the current code that CSA has laid out for you regarding this portion of the building inspection. So I'll just make it fairly quick. You already probably know the general reports that are, your documentation has to be in order, and the results of the reports, results of the inspection shall be reported with any of the deficiencies, defects, damage, stuff like that. This particularly pertains to the heating and ventilation of a home, because it's a very critical part of the building and the safety of the people that live in it. So you have to be able to spend a little time doing some of the stuff. As a person who's been in hundreds and hundreds of homes, doing repairs or service or renovations and stuff like that, there are a lot of things that kind of hide in the shadows on you, and it is important to be able to try to cover and see as much as you can regarding that. And as we go along, I'll give you a few tips on maybe how to be able to find some of this stuff. So in heating and cooling ventilation, it basically just says the inspection shall include improper function and safety issues. All right, you know where this is in your code. You can read it, and that is very important to do that, because I have run into so many people that have bought homes and then have had problems within months of their purchase with some of the equipment that they have. We're not going to be able to foresee problems in the future, but we sure definitely can see what the indications are of problems or situations that are occurring at that point, or may occur in a reasonable length of time. Again, mechanical ventilation systems. We'll be talking about HRVs towards the end of the session today. Fireplace and chimneys. That's another thing we'll be touching on. So those are the things that you want to be able to address. Carbon monoxide detection. We're going to talk about that. Smoke and heat detectors. I think you may have already covered a lot of that stuff, and that most people know pretty well what they need to know about smoke and heat detectors already. By the way, absence of detectors or detectors that don't have batteries in them is very common. I was a volunteer firefighter for 12 years, and I can't tell you how many occurrences I went to that didn't have working smoke detectors in them. Either the batteries were pulled out or they were taken down. So anyway, those are something that you want to look at. Another interesting note regarding smoke detectors, you can get a product. It's an aerosol spray can. I think Edwards make it or somebody. It's not too hard to find, and you can use that if you want to test a smoke detector. You just give it a little spray, it'll automatically go off. You'll have to wait, 30 seconds before it'll clear itself. I don't know if it works on carbon monoxide detectors. I've never tried it on that, but I know it works well on the heat detectors, or I'm sorry, the smoke detectors. So we're going to start now into the module. I'm just going to move a couple things up here. I want to get how do I get myself out of here? There we go. Perfect.
Any folks in the waiting room, Vern?
Nothing I've seen drop down. Should I check?
Sure, yeah, if you hit the participants at the bottom.
I got 14 and nobody in the waiting room.
Perfect, on we go.
Okay. So heat transfer, there's a big portion of that in that beginning of the module. I think you've covered that in building science, so we're not going to worry about it. Basically, you're just dealing with radiation, convection, and conduction, right? We don't have to go into that. Just like if it keeps you warm, it's good. Appliance fuels, we're going to be dealing with the type of fuels that are generally used and are generally found for home heating systems, and they're propane, oil, natural gas, and electric. That's the four major sources of fuel for any type of heating system. Propane appliances and natural gas appliances are basically exactly the same. The only differences are there's some conversions that are made to propane to a furnace, so it can be fired by propane, and we won't get into a lot of that today because it's rather in depth. To be honest with you, all you're doing is changing orifice sizes and a little bit of regulators to compensate for different pressures and burning ratios that the fuel has. Propane is a very volatile substance. It's much worse than the natural gas, and that's something you'll want to know, because propane is heavier than air, so it has a tendency to pool. They call pool, which is like it'll collect down in the lower floor levels, and it's more flammable than natural gas, and propane can explode quite easily if there's a small leak somewhere. It doesn't take a lot. The vapor propane, the tanks that you'll run into in somebody's home is generally you'll find a tank similar to this. They'll come in various sizes. They could be anywhere between 8 to 10 feet long to 15 feet long, depending on the size of tank that the supplier puts in. This tank here is what they call a PEG, or it's a 420-pound cylinder. A lot of these are just used if you have only a single appliance, for example, a fireplace that you might have on propane that might be put in, and that goes right up beside the house. These have minimal distance regulations as to how far they can be put in, how close they can be put to a house or a garage. Those are things you'll want to check with the local propane authority. Most of the time when they're in place, and if they're being delivered and they're being supplied by a propane delivery company like Superior Propane or whoever you may have in Alberta, if it doesn't meet requirements, they won't fill it. Another thing you might run into, or you will run into when you're dealing with propane, is you'll find what they call a second stage regulator, and that'll be actually at the house along the wall. That would be sort of similar to where the gas meter would be for a natural gas system. And what that does is it takes the gas that comes from the tank itself. Usually it comes up. There's a regulator at the tank, which is under here. That's called your first stage regulator, and then there'll be a pipe that'll probably, it will go underground. It'll go underground to upside the house, come up through at the house, usually in a close to a mechanical room where it would, feed into the house. And then there'll be a second stage regulator outside of that. The only thing you want to keep an eye on when you're dealing with these is that these regulators must be high enough to be clear of any type of snow that you get in the wintertime. And you don't want to have them in an area where there could be any mechanical or physical damage to them. Also, there is some regulations as to how far they can be from any type of a mechanical intake device or an air inlet into your house. For example, the HRV air in, because don't forget these regulators, what they do is they knock the pressure of the gases down to an acceptable limit, which is what the operating limits are for the furnaces and the appliances that run with propane. So there's a diaphragm in here, and if for some reason there's a surge or anything, it will vent air out, and that's what this little point is here. These point down. By the way, this unit would be at the top, this would be at the bottom, and that would just, what it would do is bleed off a little bit of excess pressure propane. So there's a little bit of leakage there at times. If you do smell propane when you're doing an inspection in this area, definitely take a note of it, because that is a cause for concern, as I said before. So that's our basic fuel thing. We don't have to talk about natural gas meters because most of you are pretty familiar with them already. We will go right into the types of furnaces that we that you'll encounter on the most part, and we call these central heating units. They're fan forced air. They have a blower. They distribute the air through a ductwork system, and it says that the only desirable products of combustion are carbon dioxide, vapor, and heat. That's what comes out of a perfectly burning furnaces. CO2, water vapor, and whatever heat is being lost in the process. Carbon monoxide, is a different gas altogether than carbon dioxide, and it's odorless, tasteless, and it is actually flammable. But what it does when you breathe it in, it bonds the molecules bond with your hemoglobin in your blood. So the hemoglobin is what absorbs oxygen and distributes it through your body, while the carbon monoxide bonds with it, so the oxygen will not bond with your thing, and you basically suffocate to death. And it is. I'm going to say one quick story, because I was subjected to carbon monoxide by accident while we were doing a job it was in the cooler months. It wasn't in the winter. It wasn't in the dead of winter, but it was in around December. And we were putting in a big slab heat in a great big commercial trucking garage, and they had hoarded the place in, and they were using an oil-fired heater, like what they call a Herman Nelson heater, to keep the area warm, right? And what happened was they had a generator running it, and the generator was sitting right beside the Herman Nelson heater. So the exhaust from the gas generator was actually being sucked into the air portion of the heater and blowing into the unit. And after about, we were in there for about an hour, and I started noticing that I was kind of tripping and, not really feeling too well. And I went outside to get more tie wraps. When I did, I noticed right away, wow, this air feels good. And then when I looked back in, you could actually see a little bit of a haze. And I had to get all the guys out. We were sick. We couldn't finish the work that day, but it sneaks up on you. You don't even know what's happening. Anyway, that was my quick talk, and I won't tell too many more stories if I can help it. This is a wood burning furnace here. we're not going to deal with wood a lot because that is a whole different thing. And we'll, that's for another that's another topic altogether. So our most common design for furnaces are what they call the upflow, which means it's a standard furnace. You'll see this in 90% of your homes that have forced air heating will be an upflow furnace. The warm air or the supply air comes out the top, and that's distributed. And this is your return air. So return air comes in, and it's generally tied in to the side of the furnace. These furnaces now are not big units. They may only be 4 feet high, the tops, right? But they're very efficient. So that's the basic inside look at it. The return air is very important. There's one of the things to note. This is is the fact that if a furnace doesn't have sufficient return air, it will not work properly. In other words, it has to have air to blow through the system and back out the warm air ducts. If your return air is undersized, what happens is your furnace heats up too much, like inside. It's not getting the proper airflow moving through, and it'll start to high limit. It'll start to cycle. It'll start to cut off on safeties. But so if you ever run into a furnace that you turn on and you set it up to 5 degrees or so above your room temperature, so it'll run for a period, but you notice it cuts off before the thermostat actually before it reaches the thermostat temperature. It's an indication that it's overheated and it's shut off on a high limit control. All right, we'll talk a little bit more about that. So return air is very important. That's why you got to keep filters clean and stuff like that. You don't want to restrict the airflow any more than it is already. Low boy furnaces are generally they're pretty well. These furnaces here would be in an installation that would have been that's anywhere between 30 and 15 years old, because low boy furnaces are not used that much anymore. They're not even made this way. But a low boy furnace, instead of the return air coming in through the side, comes in on the back side of the furnace. The warm air is on the front where the burner compartment is, which is this. The back side, if you looked at the back of this furnace, it would also have a door. You take that door off, and that's where you would access your blower and your electrical motor. And these furnaces here all have blowers that are driven, or that are turned by an electric pulley, electric motor that uses a pulley and a V-belt, right? So while you're in the back there looking at the blower, you may want to check the V-belt, the belt that goes between the motor and the blower. And just give it a quick look, because a lot of times these belts will have cracks in them. I mean, they wear. And if they're cracked, you want to make a note of that, because that belt has to be replaced. It's not an expensive issue, because if that belt breaks and that blower is not going to turn, that means this furnace is just going to keep operating and keep coming on and off, shutting off on high limit and turning back on again. It is a safety issue, right? Especially if there's a problem with the limits. So that's something you want to make sure you take a look at when you're looking at the blower. Also, another indication, if you look at the blower, hard to see if you have a mirror or something, an inspection mirror, that's great, because you can kind of take a look and see what the condition is of the little veins in the blower. And if they're really dirty, that's an indication that the furnace hasn't been cleaned on a regular basis. A lot of times, even service guys, when they come in, they don't pull the blowers out and clean them, because it is a bit of work, but it's something to note. And 9 times out of 10, you will, and this goes for any type of a blower, by the way, not just low boy blowers, but 9 times out of 10 on older furnaces, the blowers will have an accumulation of dirt, from dust and things like that. If owners have cats, oh my God, you'll get cat hair in there. If they smoke like chimneys, the blower will have residue on the vanes itself too. All right. So that's the low boy. Downflow furnaces, or counterflow as some call them. The blower unit is generally on the top side of the furnace, and it will blow down through the furnace, and the supply air ductwork actually would go through the floor, and the ductwork would be underneath. And this is very common. This is the common design that are used in mobile homes. If you've ever been in a mobile home, they have a little furnace. You open the door, the closet door, or whatever it is, and you'll see a unit that will that basically the ductwork goes down. These have to be installed on a special base, generally supplied by the manufacturer when you get the furnace. So that is something to note, that it has a downflow or counterflow furnace. All right. Again, same thing. The blower is accessible up top, but the return air on mobile homes, by the way, is generally just a straight duct out the top with a big grill up there, and it's usually around I would say 12 by 20-inch grill. And that's generally all the return air that you get going to that furnace, which, by the way, is why if you ever been in a mobile home, you notice that the doors are usually about 2 inches above the are cut so that they're at least a 2 or 3 or 2.5 inch gap between the floor and the door, and that's because it's relying on that area there for it to draw air out of that room and back to the furnace. Horizontal furnaces are very common in homes that have crawl spaces or have limited ceiling heights in their mechanical rooms, and they're a horizontal furnace. They operate exactly the same way as any type of other furnace, except for the fact that the return air comes in on the bottom and goes out or on one side and goes out the other. So the return air, the filter rack for that is generally right in. You'll see it right there, and hopefully the access doors are on the right side so you can get at them easily. A lot of times you have to crawl around the furnace and through ductwork and everything because the access doors were put on the back side. This is a high efficient unit, but now most of the units that you can purchase new furnaces are what they call multi-positional. So you can actually install the furnace either horizontal, upright, or downflow, counterflow furnaces. Just have to make a few changes to the furnace inside, which is all all done by the installers. So this is like pretty well very common. Wall furnaces, you may run into these in homes that have an addition, for example, where they weren't able to extend ductwork into from the existing system, or in rooms that have like a sun room or a patio room or whatever, So it's a wall furnace is put in. They put a wall furnace in, and it basically heats up that area. You find these also in smaller homes that only have like one bedroom and not a big heating area. So you may have a wall furnace put in there. They don't have a tendency to be as efficient as the larger furnaces, but they're a good unit. They're a good option. They're better than nothing at all. Better than a plug-in electric heater. So another design on the wall furnace would be instead of being tall like that, it may be a bit. It might be shorter, which usually they're about 3 feet high, and usually about 3.5 to 4 feet wide. And again, they have a burner in there. A lot of these are vented straight out the wall, so they're always situated on an outside wall. You won't find too many now that have any type of of a chimney or a C vent connector going up through them. So again, this is another thing. You can take the panels off to take a look at it. And generally all you're going to really look for is if there's any corrosion, any signs of soot or rust or debris, and if the blowers are actually working, because again, these are electric and a lot of times these things will not work. Again, if they don't work, same thing. This thing will come on, but it won't blow the air around, so it'll just come on and shut off again, you know, on its own regular safety switches. Quick talk about fuel loss. I'm sorry, flue loss. Basically, that's the air that goes out of a chimney. That's wasted heat. So on the older furnaces, and we'll talk about them in a minute or two, they're hooked up to chimneys, right? Your furnace and your hot water heater are tied into it. These furnaces are generally a lower efficiency. Basically, they're below 83%. They're probably closer to 78 to 80% if you did a combustion analysis on them. So that means that 20% of your heat is going up the chimney, right? Now, for back in the old days, there was all kinds of ways they were trying to get away from getting all the heat from going out the chimney. Sometimes there were people that actually put these little special aluminum, what would you call them, like a fin around the vent to see if they could get more heat out of it. The important thing to know is that you need to have a specific amount of heat going up that chimney, because if you don't, the heat will, the temperatures in the chimney will drop, and the inside of your chimney will start to condense, which means you'll start to get water in the inside of your chimney. And this an indication of this happening is if you're looking at the bottom of a B vent chimney when you're in the mechanical room and you see a lot of rust built up on what they call the base T. This doesn't show a base T, but generally this is a T at this spot here, and this would go to the furnace, and this is going to the hot water heater. They're hooked up separately. They can be hooked up together with a special Y saddle, but anyway, if you notice rust in anywhere around this T area, that's an indication that you're getting that water's been coming down that chimney. There's the only two reasons for that. Either the chimney cap's missing, which is what you're going to look at before you go into the house. Make sure if it does have a chimney, it does have a chimney cap, and what height it is. We'll talk about that in a bit. Or the products of combustion are cooling off so much that the gases are now turning. Remember I said carbon dioxide and water vapor? Well, that water vapor is now turning into water, and it is now sweating, or whatever you want to say, along in the inside of the chimney, and it's dripping down through the unit. That's a cause for concern. There's reasons for that happening, but we won't get into that. You want to make a note that the chimney is rusted, and there's signs of condensation from the inside. Okay, so now talking about chimneys, the chimney or not the chimney. This is going to depend on, of course, the type of furnace we put in. We're only going to deal with category 1 and category 4 furnaces or heating appliances today because of, again, our time constrictions and the length of this module. So the category 1 furnace, to make a long story short, uses a chimney, uses what they call a draft hood, and they are the older furnaces, the older style furnaces that you will run into in a home. So that's basically a category 1 appliance, the same as a hot water heater. We talked about hot water heaters yesterday, the natural draft type. Those are category 1. Anything that burns less than 83 efficient is considered a category 1. And again, we talked about the blower motors found on these standard efficiency furnaces are generally a single speed. You may get a 2-speed one, depending on the model. And the 2-speed ones are generally if you have an air conditioner tied in with them, because when you go into air conditioning, you need more airflow to go through the evaporator coil that would be in your ductwork. So you would have that furnace would run on a high speed when it was when it was in the cooling mode. But anyway, belt driven. There are some older furnaces that are direct drive driven, which means the motor is actually installed inside the blower assembly. You can't get at those; very hard to access. But anyway, those are things that you want to make note of. This is where the air would come up from the inside of your room. It would come through here into this. Basically, it's like a collector. The air would inside air would be drawn in there, and it would mix with the products of combustion that come out once the heat goes through the heat exchanger, and that's basically to cool the temperatures down to a level that the venting will be able to handle properly, right? So that's your draft hood or your collector area. Again, if you see products of combustion here, ash, soot, anything like that, you make a note of that. That means that this thing's been backdrafting, similar to what I was talking about yesterday on the gas hot water heaters. That means that you get a certain amount of backdraft. I'll make a quick note here regarding when you first fire up a furnace, especially if it's in cooler temperatures in the wintertime, for example, because it's a natural draft chimney. When the furnace first fires up, it's normal to get a little bit of spillage coming out here. In other words, you'll feel hot. This air will feel warm, and it'll feel like it's coming out. That's normal. It should do that for about 10 to 15 seconds. Not a lot, but enough until the chimney actually warms up enough, because it has to get to a certain point to provide a draft, a natural draft to go up and up through the chimney and out the chimney. So out the chimney roof cap. So again, if you do run into this, and this goes also for hot water heaters, you'll get a certain amount of spillage when they first start. But after a minute or two, you shouldn't be getting anything back through there. And one way you can determine that if you want is just do a little smoke test. You can light a lot of people carry cotton wick. It's like yarn almost, or you could use yarn, I suppose, but I think yarn now probably melts instead of burns. And you just take a piece of that, or even a piece of wood that you can light up, but it'll smolder, so you get a little bit of smoke coming off of it. And you just hold that little that burning that smoldering end of your cotton wick or your stick close by, just so you get some smoke. And if the smoke's being drawn up through this area, and same as on a hot water tank by that draft hood, that tells you you're getting a proper draft. If it keeps coming out this way, then you're getting backdraft conditions. You're going to want to definitely make a note of that. There's reasons. There's got to be a reason why that's happening, whether the chimney's obstructed or so there's or it's not installed properly. But again, if this is a regular occurrence, you'll see it when you first look at the furnace. So that's the category 1s. The mid efficients still fall into a category 1 furnace because they do not they're approximately 80 to 82% efficient. They don't go over the 83 efficiency point, and I'll tell you what that means when we do the category 4. Except now we're not dealing with a natural draft type unit anymore. We're dealing with a furnace that has a draft inducer motor or a venter motor. In other words, there's a power fan in here that comes on and it helps pull the air through the system and it forces it up the chimney, right? These still will be commonly vented to an aluminum C vent, which goes to a B vent, which we'll talk about later. Some may have B vents connected right to it. It's still a chimney that goes up to the roof. At one point many years ago, when they first came out, they had developed a plastic that they used that would go out the side walls called ultra vent or something, and it turned out to be a nightmare. It cracked and stuff like that. People who had built homes based on this type of furnace, who didn't put a chimney in and used that type of venting, were now in trouble because that venting was no longer suitable. So they had to get very creative on ways to vent the system out the side wall without having to tear apart their house again and put a chimney up through the roof. So they came up with power venters and stuff like that. We'll touch on them later. This is a picture of the venter motor. I call them the venter motor, and it would be installed. You would be, if you were looking at it, you would be looking right here at this point. This is the motor here. A thing to note is when these come on, if they're noisy, that's a good indication that they're on their way out. That means their bearings are starting to seize up or different things. Had a lot of problems with these at the very beginning when they first come out with the mid-efficient models, because they were making the housings out of metal, and they made the blower wheels out of metal, which a lot of them still are, but most of them are plastics now. And one of the problems that they had was the shaft on the motor and was a different metal than the blower wheel, which was attached to it. So the two metals expanded and contracted at different rates. So the blower wheels kept coming loose and they would start rattling around. They used like a liquid weld to try to keep the things on, and that worked. But most of what they finally just did was design a unit that was all high temperature plastics, so you don't run into that problem so much anymore. You want to check to make sure that there's no cracks on this unit, like in the housing, because of course this is where all the gases collect right here, and they're forced up here, and this goes out the top of your furnace through a plastic vent pipe. You want to make sure there's no cracks or indications of leakage. So if it's noisy, if there's any indications of leakage or cracks, or if you see a big smear of red silicone here, that means it probably had a crack or something, and somebody just used high temperature silicone to repair it instead of replace it. So these units are almost are pretty much identical to the high efficient ones, so they're very common. And one of the most common problems with furnaces are these units themselves. They have a tendency to have a lifespan of about 8 years, 8 to 10 years. Your furnace should last much longer than that. So now we're going to talk about category 4 furnaces, which are the high efficient models, the high efficiency models. And basically they operate at anywhere between 88 to 94% efficiency, which means that 88 to 94% of all the heat that is being used or is going to the proper place, with only a small amount being vented out as exhaust, right? So because these have become a higher efficiency, one of the problems one of the situations that we have is when the flue gases are low like that, what happens, what we talked about, because one of the products is water vapor, we get condensation. So these are what they call condensing furnaces. They have they're special. They have special parts and pieces on them to make sure that the condensation that's created in the furnace itself is handled properly. In other words, it's not going into areas where it could become harmful, like dripping or anything like that. So these furnaces actually use two different types of exchangers. In other words, that when the furnace fires up, the heat goes through a one primary exchanger, and we'll talk about those a little bit more later. And then it goes to what they call a secondary exchanger, and then up through the venter motor and into the exhaust going out. Most of these furnaces now will have two pipes coming into them. One is the exhaust, the flue gases. The other one is the air intake, right? We will talk more about those too. So that's category 4 furnaces or appliances, anything that's high efficient. You won't run into these in certain types of appliances. For example, most 99% of all hot water tanks, though, they're not category 4. Even though they may be vented out the side wall, there's still a category 1 furnace or appliance. They don't produce that kind of efficiency. High-end hot water tanks and instantaneous hot water heaters, tankless hot water heaters, stuff like that. Yes, they do. They're specifically designed to be high efficient. If you have any doubt at all you have to do is look for some type of condensate drain. If there's a condensate drain on the appliance, that means it's category 4.
There's a question, Vern.
Yeah.
Just regarding the inducer fans, can you grease the bearings in those fans, or do they have to be replaced?
No, you can't grease the bearings. They will not. What I've done in the past when I've gone on a service call at 8:30 at night, and somebody's saying, well, my fan is making one heck of a racket. What I've done is I've given this area here a little shot of like silicone, liquid silicone, whatever you want to call it. Like WD-40, right? That'll quiet it down, right? But you know darn well that this is only a temporary measure. It's going to be noisy again in the next day or two. The bearings and all this stuff here, these are all sealed. Now, you can't take them apart, because if you do, you've lost the CGA rating on them. And if it is noisy, it has to be replaced. Sorry. And by the way, these things run anywhere between $250 to $400, depending on the furnace. Older furnaces, because they're harder to get, they're running $300 wholesale. My cost to get them. Okay, does that work for you? I hope so. Category 4 has I've talked about secondary exchanger and the venting now. Regarding this, we'll talk more about this, but it is a special vent that is now has been used for a number of years, and it's called Royal Venting or System 636. In other words, it's white venting. We'll talk more about that in the venting portion, all right?
There's a question from Iqbal as well. It's just, I notice sometimes a small water pipe beside a high efficiency furnace. Do you know what the purpose of this water pipe is? And we'll talk about that in a bit regarding condensation drain pumps and whatnot. But it alludes to what Vern mentioned about that secondary heat exchanger.
Yeah, exactly. If the what he calls, or they call the water pipe, is actually a 3/4 inch white PVC plastic pipe, or a tube, like a vinyl tube, for example, that's usually about 5/8 in diameter. That's condensate drain. If there's a water pipe, a small water pipe running beside the furnace, that could be going to a humidifier. If it is indeed a water pipe, it goes back to the water system. Obviously, it's supplying water to something, right? So it's generally just a humidifier, but either, if that's your interpretation of a water pipe anyway. So combustion air. Now, this is a big concern for category 1 furnaces, because guess what? What goes up the chimney has to be, the air that goes up the chimney has to be replaced somehow, right? If you'd have inadequate combustion air in the furnace and hot water tank, any area that has natural or a category 1 appliances in it, if you have an inadequate combustion air, it's going to get its air from somewhere. Doesn't matter how it's going to get it, it's going to get it, right? Because either it's going to start to starve the furnace for proper air, which means the furnace will not, the gases will not burn properly. You'll start getting sooting inside the furnace, stuff like that. Or you're not going to get anything going up the chimney at all, because the air from the chimney, the air in the room is going to try to be replaced by the air coming back down the chimney instead of into it. So combustion air is very important. A lot of older homes, we didn't worry about combustion air so much because they were so leaky, as you call it, that air was coming in through everything, the wall plugs, doors, windows. You know, a lot of homes didn't have a vapor barrier, so they were coming in through cracks. They come in anywhere, right? But as homes were upgraded and renovated, they started sealing them up, changing the windows, stuff like that. Well, that's causing a problem. Now you're not getting that leakage like you used to, and so that would mean you'd have to bring in your own source of combustion air into that area. And we have so what we want to have is to make sure that you've got adequate air and pressures in that area to keep from any type of backdraft occurring, because that is where you get the possibility of your carbon monoxide production and buildup occurring, is if this appliance, because carbon monoxide is a product of incomplete combustion, if this furnace isn't burning properly, it's gonna create carbon monoxide. That carbon monoxide, even if the furnace was burning improperly and the draft system and your venting system was working fine, you wouldn't notice it, because all the products of carbon monoxide or the products of combustion are going up the chimney, right? But if for some reason this thing wasn't drawing the way it was supposed to or anything, or you were getting negative pressures in the house, and that carbon monoxide is going to spill into the house, and it's going to become a very serious issue. So that's why you need to have that air. In this drawing here, you're going to see this is all positive pressures here. This is negative pressures here. So what happens is positive wants to go to negative, right? Cold wants to go to hot, which is why in some of the older homes or some houses, when you open a door in the wintertime, and you get that rush of cold air and it kind of fogs up for a minute, that's an indication that your house has a negative pressure, which means cold air is trying to get in to that house no matter what. So if you have an appliance with a draft hood, it's going to come in through the chimney when that appliance, especially when that appliance is shut off. So that is why you want to have a combustion air in the furnace. Combustion airs would go to outside, and we'll talk more about them further down the line. Carbon monoxide detector placement. Now this is an interesting little issue, is that there's misunderstandings revolves around proper carbon monoxide alarms. I'm not sure if you've taken this in building module, but if you haven't, I'll give you a quick Cole's notes on what I know. Carbon monoxide detectors should be placed high in a room. It really doesn't matter the location. There's a lot of them that are plugged into the wall, right? Into a wall outlet. You'd have a carbon monoxide detector, you plug it into the wall outlet, which would be normally, around 18 inches or so above the floor level. That's fine, all right? Some say putting an alarm near a heat register will allow for quickest detection. I would not do that, not near it. I would not put it within 5 or 6 feet of it, because you don't want air blowing onto that. It can give you some false readings on that. Because carbon monoxide is a little bit less dense than air, slightly, it will have a tendency to collect in the higher areas. I wouldn't, like so. So if you if you do put a carbon monoxide detector or you are observing them, they shouldn't be any more or any less than 12 inches from the ceiling height. In other words, they should be at least 12 inches down, because that's a good area for being able to detect carbon monoxide. You also want to make sure that they're on every level of the house, including the basement. They should be in an area that is relatively close to where you're going to hear it. So if it's in a hallway beside your bedrooms, or in a kitchen area, in a basement, don't rely on one carbon monoxide detector being in your stairwell if it's distance, because you want to make sure that you can hear it in the middle of the night if it goes off, and B, you want to be able to make sure that you can get at it so that you can maintain it, right? Um, Another thing is you don't want to have them near any areas that have high humidity. Laundry rooms are not the best place for them, or neither are like near a kitchen sink or in a bathroom, obviously, because of showers. Make sure they don't get put in behind a curtain. If you've got, full length curtains, while a carbon monoxide detector stuck behind a curtain isn't gonna sense very well. And if it is if you do have you want to have a carbon monoxide in your furnace room, but you should keep it at least 6 to 8 feet away from the furnace or the hot water tank itself, just so you don't get any of those false readings when that unit first starts, especially on natural draft units. Okay, so I hope that kind of clears it up. You can read on it. So we're going to talk a little bit now about some of the components that you will find in a Category 1 furnace, the older style. We'll make it relatively painless. You'll see this unit here. I think I recognize it. It looks like an old Lennox, what they called a G8 furnace. Because see how they put a filter, they had a filter rack in here. I have no idea who came up with that bright idea, but they are painful because they're hard to get in and out, and you have to have special filter media to replace them with. Most of the people that had these furnaces are pretty much gone now. They go back to like almost 30 years ago. If you run into a furnace like this with a filter set up where your air filters like that, make a note of it. It's painful. They may want to have this portion changed so you can actually put a filter in the regular spot, right? So that's your filter area. This has got a blower, the blower unit here, and this one here doesn't use a separate motor and a V-belt assembly. So the motor is actually installed inside the housing, and it's directly attached to the blower wheel. Again, you want to just note here if there's any noise coming from it, any vibrations while it's running. And this will run if you have the compartment off. And a little tip, on almost all furnaces now, they have a blower door switch, right? Usually situated here. It could be a push button, it could be a black little clip. You might want to, what I have is I have a little clamp that I put on so that it'll close the switch, because if that switch is open, nothing operates, period. It's just like your kill switch on your snow machine. Nothing operates. The blower, the burners won't work. The blower won't work. So you're going to want to have some way of being able to hold that in. You don't want to hold that in with your finger while you're working on everything. You unless you have 3 hands. And if you do, you shouldn't be an inspector. You should. There's better trades than that to get into. Anyway, so when you're running this unit, and you're watching your fan, if it's vibrating, like shaking or whatever, it's an indication that either the bearing is starting to go on the motor, or that there's debris or something's throwing the balance off on that wheel, so it's spinning like and vibrating because it's out of balance, right? Notes should be taken. Yeah, you might want to use a mirror to take a look to see if in here. You don't really want to pull these out because a lot of times you have to unhook some other wires in order to get these out. Generally, they're fairly easy. There's usually just a couple of screws here and here, and you take them out, and this whole thing will slide out on kind of a rail. But again, it's the wiring that is the issue. You may have to unhook wires. You don't want to do that. Okay, that's not your job. You just want to observe it and check it. This is the burner compartment, right? So this is where the flame and all that comes to, and this will have a standing pilot. Some category, well, other category ones will have an igniter. We'll talk more about that. So it'll have a pilot flame. There'll be always a flame going constantly, little pilot flame. So what happens is when there's a call for heat, the signal is sent to this. This is the gas valve. The gas valve sends a signal down to the the gas valve opens a small tube. This tube right here that comes out is going to the pilot assembly that will emit a little bit of gas through, so that now that pilot will now oh, I'm sorry, on this one here, this pilot, it runs all the time. So there's always gas going through this tube to the pilot. When there's a call for heat, as long as this tube is burning and it's thermocouple sensing the heat, it will send a signal through this point right here to the gas valve to say, yeah, I'm good, I'm on, the pilot's working. So it'll open up the main gas valve, which is this portion here. This is where the main gas goes in. The gas goes through these burners and or these ports, and then the flame is comes out in this area. If there's indications of soot here, or when it fires up and you hear this whistling sound coming from any of these points, that means you're getting a flame back at this point. That's not a good thing. There's a reason. There's got to be a reason why that. Either these burners are dirty, and the gas that's supposed to be shooting through to the burners is being obstructed a little bit, so it's flaming out. Because don't forget, there's air coming in here. This is called your primary air source, right? Which is air is mixed with the gas that goes in, and that shoots over here. This is where the flames initiated through the pilot. I don't want to get, but so without getting too crazy here, if you hear whistling, that's an indication that there's a flame, a flashback. You want to make notes of that. If we'll talk more about flame what they call disturbance testing after, just give you Cole's notes on it. So this is the exchanger is in behind here, and of course the ductwork is coming up off the top on this turn here in the bottom. There'll be a combination fan limit switch, which on this I think is right here. I can't. Oh, that might be yeah, that's here. There's wiring going to it. So what this is, there's a probe inserted into that area behind where the heat exchanger is. It senses the temperature, right? When the temperature hits a certain amount, it'll depend on how what the fan is turned on or set at. Usually it'll come on at about 150 to 155 degrees on these older furnaces. Once it hits that temperature, it sends a signal to the motor, the blower motor, to turn it on. The motor comes on. So the motor doesn't come on as soon as the burners ignite. It has to heat up a certain amount first. All right. There's also built into that is a high limit, so that if for some reason this motor doesn't come on, which can happen, and the furnace is running, if it reaches a temperature usually around 180, 185 degrees Fahrenheit, when it reaches that temperature, it'll send a signal back to the gas valve to say shut off. So it shuts the gas valve off, right? Now, the problem is that this will cool off after it's been off for a certain length of time. Once it cools off to a certain point, it turns back on again and the cycle is repeated. So if your blower motor isn't working, this will continue to operate. The unit will still heat. The fan will not come on, but it'll cycle on high limit. Not a good thing to happen for any real length of time. Another thing I want to just make a note of here while I'm at it, you see here, this is the gas pipe coming in, right? It's not a good idea to wrap your thermostat wire. This is the wire that's coming from the thermostat. It's not a good idea to have the thermostat wire wrapped around any of your metal gas piping, all right? This has got it wrapped here. It's got it wrapped inside. That's a no-no. The same as your electrical supply coming in, your BX. If it is attached to the gas piping at any point, make a note of it because it's not supposed to be, all right? Particular reasons for this is that it has happened where you've got electrical leakage that has occurred and you're actually getting voltage being conducted on the armored cable itself. And armored cable, the BX, is really the only stuff that's approved to go to an appliance. If you have regular Lumex wire that you would have a normal household, that's a no-no. Not supposed to have that going. You can have that run to the emergency switch, but you can't have it go from the emergency switch to your furnace. So if it is Lumex or NMD7 or whatever you want to call it, you have to make a note of that. That's an infraction. All right.
There's a couple notes here, Jim. So with that NMS that Vern mentioned, the non-metallic sheeting. So again, guys, just going back to the electrical module, if you see any of that NMS that's exposed below 1.5 meters, right, that is a kind of electrical code infraction. But the question from Jim is, if you see oil leaking into the bottom cabinet, should you recommend replacement of the motor? I would say that instead of saying that it should be replaced, just to have it checked out by an HVAC professional or gas fitting professional, because you never know, maybe something else, or maybe it was already replaced. But obviously, do point it out if you see any sort of leakage or past leakage, if you will.
When you see oil, and this is in the blower compartment, I take it. That could be an indication that somebody spilled oil. Well, that is kind of weird because almost all motors now are oilless. You don't have to oil them, right? They don't have the ports where you put your electric motor oil in. What you might run into is debris like from the belt if it's belt driven. You might see some rubber and stuff. But oil is interesting. Yeah, I'd wonder why that would be occurring. That's for sure.
Yeah, so maybe just get a second look. And Vern mentioned as well with the short cycling furnaces. I mean, I would recommend that when you guys go to test the furnace system, just crank it up 5 degrees. That way, to return it back 5 degrees for the sellers, for the current homeowners. But if it's kicking in and out, by all means, do point it out. It may not necessarily mean that there's a high limit issue. It may not mean that the furnace filter is dirty. It may be a flame sensor. It could be a lot of things, right? So it's best not to say this is what it is. You can just say that it was noticed to short cycle, misfire, however you want to call it, to have it looked at closer, right, by an HVAC professional, because again, it may be something super simple or maybe something a lot more than what you think it may be. So.
Yeah, exactly. And not only that, but it would be something for the existing homeowner to know. Sometimes they don't have any idea what's happening down there, right? They may have a furnace that's short cycling, but don't realize it. And yeah, setting the thermostat up higher to 5 degrees higher is a nice. We don't even want to talk about thermostats, do we? Some of them are so complex you have to have a PhD to run them. But let's just say that if it's a relatively normal thermostat, whether it's programmable or not, it will have an override where you can run it. And if you have any questions about that, you might want to do a little research on the thermostat. You can get that information off your phone if you need it. Say, okay, I want to turn this up, but I don't want to screw up any of the programming, right? So the components on a mid-efficient furnace, again, still a category 1, is basically the same thing. You've got your blower compartment. At least you have a return air system right here. Here's your filter rack. All right, we'll talk about filters after. Your burner tubes. A lot of times now you're not going to be able to access you're not going to see into the burner area like you can here. And you can see here on this picture, even though it's small, it's in your module, I believe. There's indications of rust. That means that the flame's been licking out here a little bit at some point, and probably at that point, because generally a furnace at this stage of life, these are all the things that are starting to go wrong with it. Anyway, so this is the fan draft inducer motor, or the fan or the venter motor. This is really old style again, because it connects to a metal pipe that's going up. Most of these now are connected to plastic, right? So this is old. This is old stuff. And again, here we have that similar situation of the electrical being tie wrapped to the gas pipe. That's kind of a no-no. So even though this pipe, this is basically it's tech cable. They got some nice expensive stuff they used here. Again, that's something you want to note. The gas valve. This here, number 5, I know it's not very clear on this, but that is one of your safeties, an important part. It's called your approving switch, and we're going to talk about that later. All right, your high efficient furnaces, category 4, are basically, again, pretty much the same components, right? This is where the fan, the venter motor is. And now you can see it has been connected to plastic. You want to make sure when you're inspecting here that that this connection is good. There's no signs of discoloring, because if this pipe is discolored, in other words, if it's starting to turn brown a little bit, that's an indication that these gases are getting a little bit high. Yeah, the temperatures are getting high. This stuff's getting hot for some reason, right? Shouldn't have that problem. Another thing you might want to look at while you have this open is the fact that the way that the gas piping is connected to the gas valve. All right, you see here there is a union, which is fine, because you need a union on in this area somehow to be able to take this to take the gas piping apart, should you have to replace the gas valve, right? So there should be a union. Doesn't necessarily have to be in the furnace compartment. It can be out here as long as it's downstream of the gas shutoff valve, right? This furnace here has a particular service switch, which is nice. That means you can actually switch it off right here at the furnace without having to get up and go across the room to find the furnace safety switch. It is not considered an emergency safety switch though, because I'm not sure if you took this in electrical, but the location of your furnace safety switch or your emergency switch has to be somewhere between the furnace itself and a way to get out of the building. That way, like the stairwell or whatever. That way, if there is a problem with the furnace and you got to turn that switch off, you don't have to run over to a furnace that might be starting to lick flames out of it to shut the power off to it. You just kill the power in a spot where you can get out afterwards quickly. Okay. So again, it'll have an air proving switch, which I think is right around here somewhere. This one has 2 of them. Don't worry about that. That's just the design. One switch will be tied into the other. Basically what they do is they just make sure that this venter motor is operating. It's providing enough draft to safely fire up the rest of the system. If this thing doesn't click on, nothing. The burners will not turn on. This is the location of the electronic control board for this particular furnace. Again, it's been put on the backside of the blower unit, which means if you ever want to access this, you've got to take all this off, pull it out, and then pull out your blower motor. Not a real great design, but still is fairly common in some spots. This is where the flame takes place up here. So you can access that even, or you can see that on mid efficients. Generally, these are still open to the air. On high efficient, well, on this one it is, but on most high efficients now, these are totally closed. So the only way you can see what's going on inside there is looking through a little peephole, an inspection port. And at that point, what you see when this cycles is first when there's a call for heat, this will the blower motor will turn on. I'm sorry, the venter motor will turn on. It's going to do a pre-purge cycle. It's going to purge for approximately anywhere up to 30 seconds or so. You'll hear a click, which means that it's working and it's sending a message to the circuit board to fire up the gas valve, right? So then the gas valve will not fire up yet. What it's doing is it's going to send a signal, sorry, not to the gas valve, but to the hot surface igniter, or in this case, there's a spark unit here. I can see a red wire. So it's basically like a spark plug in there. It's going to start to spark. It's going to tick, 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 tick. Usually this is going to, it'll at the same time, it opens up what they call the pilot valve. This ticking is important because the thing should ignite within about 3 or 4 seconds of that ticking starting. If the ticking goes on for any longer, like for 10 seconds before it ignites, that could be, that's an indication of a problem coming up. Either your voltage going to that sparker is inadequate because it's like a spark plug. It has to create a certain amount of voltage to provide an adequate spark to light the flame, or you're having a problem with other things in the system. Either that is clicking, but it's not opening up the gas valve properly, the pilot gas valve, or whatever. So if you hear this clicking on a spark ignited furnace and it goes on for more than 10 seconds, you may want to make a note. It's basically a delayed ignition. And when it does ignite, it will generally ignite a pilot burner, which will run for a couple seconds, and then the rest of the burners will open because it'll say, okay, it's telling me that the pilot burner's on, the flame sensor seems to be okay. We're going to open up the main gas valve. The gas valve opens. Another flame sensor will sense that gas valve has opened and there is flame. Any of these things that don't happen, it shuts down. It's all very automatic. All right. Here is the condenser or the condensate piping, and the condensate will be collected. A lot of times they'll have a pipe coming from this point, or there'll be a collection box, and this is hooked up to a factory setting or place so that you can do your ties. A lot of times the furnaces will have this. They'll even provide a little stub out pipe so you have exactly the right size to come out, and then you just tie this in with PVC, and this will go to a floor drain or whatever. We'll talk more about that after. All right, so that's kind of the Cole's notes on that one.
There's a question, maybe
Yeah.
a couple. So the first question is furnace disconnect located on ceiling above furnace accepted? So I don't believe
Above furnace.
Yeah.
Well, as long as it's not right at like within a foot of the furnace, and as long as it's not somewhere where you'd actually have to go around the furnace to get back out of the room, right? That's the problem. You want to make sure that you don't have to go around a furnace in order to switch off the power properly. So yes, they're very often they're situated up in the joist space near a furnace. I wouldn't say right above it because there's more likely to be ductwork, but within maybe at least 2 or 3 feet away from it, so that you can actually go there, switch it off, get out, and that'll be it, right? So
Oh yeah, I'll speak to that too. So I think what you're referring to, John, is a lot of older homes, you're going to see, like Vern said, the disconnect being attached to the floor joist above. So I don't believe the Canadian Electrical Code, I believe it's 12-806, which pertains to disconnects for electrical heating equipment, or not for water heaters. But I don't believe they actually have any clauses that restrict the height of the location. But some home inspection standards do require that the home inspector indicate where the disconnects are. It never hurts to let your clients know where they are. A lot of home inspectors will actually label the disconnects either with a logoed up sticker. I would recommend, if you do that practice, you may want to inquire with the sellers first, because some sellers are extremely particular. So if you start putting your decals all over the appliances and electrical panels, they may get quite annoyed. But I don't believe there's any requirement from the electrical code that has a height stipulation on the disconnect. And like Vern has mentioned a couple times, you are required to have a disconnect between the furnace and the actual room. So a lot of times you will just simply see a switch, a wall switch. But if you have an electrical panel that's between the furnace and the entry, that is acceptable as well, as long as there's a disconnect, before reaching the actual appliance. And I believe current code does not allow, in this image, you can see number 15, where the disconnect is actually attached to the appliance. You're not allowed to do that anymore. But again, older installations, which most of the time is what you guys will be checking out, it's acceptable, right? So I mean, if you want to point it out to say that's not currently acceptable, that's fine. But a lot of grandfathering in with what you guys will be doing. The second, go ahead, sorry, Vern.
Yeah, and just to talking about the switch itself, those switches have to be on a dedicated type of switch cover. That'll say furnace switch. Usually they're red. Now here's the confusing part, because be careful, the arrows are weird. They have arrows that like on pointing down or off pointing up or whatever. So if you don't look at the arrow and you just flick the switch to the on, where you just read on, that means it's off, right? On, and they'll have an arrow above it. So just be wary of the way that the switches cover is made. I have no idea why they even did that. They should have just put on where you on the up part of the switch, and off on the down part of the switch, right? No arrows.
Yeah, don't be fooled by the orientation. And the second question from Joel is a little off topic, but I have seen 2 brand new high efficiency furnaces with the air intake pipe only being a foot or so long, drawing air from the furnace area. Why would the plumber, gas fitter, not run it outside like most high efficient setups? So that is regarded or referred to as a one pipe system. So a lot of furnace, even water heater manufacturers, but commonly furnace manufacturers, they actually allow this one pipe system where you have the exhaust going through the side of the home or through the roof, however they have it set up. And then the combustion air being drawn from the ambient room, from the mechanical room. So again, just check the installation manual. And again, your installations require that the installation manuals be left behind. One of the reasons that I've heard why, the gas fitters will simply have the combustion air being drawn from the room, and the module does talk about this, but I don't know if you have it there, Joel. But as long as you have provisions for that combustion air, which I think we'll be talking about again here later in the slides, as long as you have that air pod for the furnace, that should be sufficient as long as the manufacturer allows it. But again, going back to your question, why do you see that? In extremely cold climates, some HVAC providers or plumbing installers that do furnaces, they say that if you have your air intake plumped to the exterior, you may get quite a bit of condensation, because you got -30 air being drawn into the intake, into the mechanical room for the furnace. They might get a lot of condensation. A way around that is you simply would insulate and bury the intake pipe 4 or 5 feet from the exterior wall going towards the home. That's how you would alleviate that. The other reason as well is these intakes, and the exhaust as well, but intakes can get frosted up. So a lot of homeowners, they may not remove the screens that are often included with installation packages. So if you don't remove the screens for the intakes, you're going to get hoar frost, which of course, if your furnace or water heater if they're not getting their adequate combustion air, then they won't operate properly, right? So that's a couple of the reasons why you'll have gas fitters not install intakes dedicated to the exterior. But I would recommend to your clients that they strongly consider it, because if you got kitty litter, which seems to be the commonplace for kitty litter boxes to be in mechanical rooms, then your water heater and furnace, they're going to be pulling air from the dirty air in the mechanic room. So the kitty litter or the varsals, paints, gas cans, what have you, it can actually cause damage to the interior components of your appliances.
Yeah, exactly. And yeah, I would say that probably 15-year-old installations where they had high efficient furnaces. There a lot of them would only the manufacturers would only basically discuss the how they wanted the exhaust system installed, right? The air intake, which is actually right here on this furnace, this often came up, and generally you'll want to keep it away from anywhere where you may be drawing air back into the system, like through the filter rack. So sometimes these would extend up and maybe up close to the ceiling level. Again, that's fine as long as you have adequate air coming into this room, that it's sealed, because it's drawing air in, right? And it's drawing quite a bit of air in. You can actually feel it if you've ever put your hand over an air intake, you'll know that yes, it's pulling air in because it wants air, right? The other thing too regarding the condensation problem that Alex was talking about, what I find is most of the problems we have with the venting on high efficient furnaces is the fact that the exhaust is the one that freezes up more often in cold weather. You'll get icicles building up because, of course, that's water vapor coming out. Don't usually have as much problem with the air intakes because the air that you're bringing in from outside in cold weather is dry. It's not humid. It's not humid like your air is in the spring or in the fall or in the winter or in the summertime. But what happens is if your air intake is situated too close to your exhaust, then of course your air is pulling air in, your exhaust is pushing it out. Well, if that air intake is too close to the exhaust, then it's going to naturally pull the air in that's coming up from the exhaust into the air intake, which is going to have condensation and water vapor in it, right? So there's specific code requirements as to the distances and that. And again, manufacturers are very specific on how they want their vent termination set up. And the vent termination is basically where it goes out the wall, right? All right, now safety components. This is for the old style category ones. Back in the day, I like saying back in the day, when furnaces were just natural draft type furnaces, there was very few parts on them that were actually safeties, right? And the one main safety would have been your pilot burner assembly, which is right here. This is the part that goes into your furnace and ignites any of the gases that come through these jet ports, right? So that burner would the pilot burner would normally run continuously, and it would depend on having now this says flame sensor on this diagram. I should have looked around for a better picture, but anyway, what it does is it'll this thermocouple here is called a thermocouple, and that generally goes into this port here, so that when the pilot burner is burning, the flame licks around about the first half inch of this unit here. This is a sensor, and this creates a millivoltage in the unit, or in this, because the flame creates a millivoltage with the materials, the metals that this is made out of, and then it goes down through a copper tube. This is how you get them when you buy them. They're rolled up, and would go down through the copper tube, right, and connect into the gas valve here at this connection. So this is coming from the thermocouple. So as long as that flame is burning properly, it's sending a millivoltage to this gas valve, and it's just saying I'm working. All right. So when the gas valve, when there's a call for heat, because these thermostat or these valves here, the thermostat was directly tied in with the gas valve. There's a couple of point terminals here for the gas valve itself, the TH terminals. So it would say, okay, there's a call for heat. So it would click on a solenoid inside the gas valve, which will open, provided that this is sending enough millivoltage to do so. All right. So that was one of the safeties. So if this flame went out, this would cool off. This gas valve would not open. That was how they depended on it. Fairly reliable, rather ancient, but again, these thermocouples were prone to failure after a length of time. And I know that as a serviceman, if I had say a call to go and replace, to get the furnace going, and it was a thermocouple, and I changed the thermocouple, and then 2 months later I got a call again, furnace was out, and the thermocouple was not working again. That's telling me I have another problem besides the thermocouple, because thermocouples are usually fail-safe. They don't give you any problems when they come from the factory, and that can depend on the type of flame coming out. If this flame is being interrupted, and in other words, if it's pushing away from the sensor of the thermocouple, then the thermocouple is not going to send a signal to the gas valve. If the flame is not set on the thermocouple in the right position, this piece here will have a tendency to burn off, and it'll burn off at the end, which will make it non-functioning. So when you're looking at a pilot flame, a standing pilot flame in a furnace, just take a good look at the flame. If it's a nice blue color and it looks fairly consistent, and you'll see it be touching a thermocouple, it's good. If it's showing yellowish licks of yellow in the flame, that would tell me that this portion of the burner assembly, the pilot burner assembly, is dirty, or there's a little orifice in here also that the gas goes through. And it's like the size of a pinhead. Well, that could get a little bit of debris on it, which will cause a problem with the gas flow coming to the burner, right? This furnace here, if you opened up the compartment and saw a furnace like this, you might as well just close the compartment, put a note on your report saying furnace should be tagged by a gas fitter, because this is not the way a furnace is supposed to look. This is showing all the indications of flame rollout. There's been some burning going on here that will cause all this wiring to go to be non-existent. And this, so then your high limits aren't going to get the proper signals. This is where your fan limit switch is. Again, there's a probe that's inserted inside the heat exchanger portion of the furnace, and that senses the temperature. It tells the furnace blower to go on, tells the furnace blower motor to shut off when the call for heat is finished. And it also has the high limit switch, so that if the blower motor doesn't come on, the furnace shuts off automatically. So this is a problem. This is not a good thing. So those are,
yeah, I'll add to that too, Vern. So you guys will need to use your judgment, I should say, during your inspections. So like Vern said, if you open up, the cabinet and you'll notice a bunch of soot, a bunch of charring or whatnot, obviously do assess it, make note of it. If you notice that you have replaced components, well, chances are, a gas fitter has addressed this, but I would still recommend that you let your clients know of the concern and just ask for, service history record like we discussed yesterday. So, I mean, a lot of manufacturers of water heaters and furnaces recommend annual maintenance. I mean, it's up to you guys if you want to state annually maintenance calls in your reports, or every 2-3 years, totally up to you. But again, use your judgment, right? If you see the rollout, by all means call it out. If you notice that things have been replaced, you can say, looks like things have been rectified, but still recommend to inquire with the sellers of, the history of the events, if you will.
Right. And discussing like the furnace maintenance on newer furnaces, a lot of people are still have the mindset that you have to have your furnace maintained manual or annually, things like this, serviced and stuff like that. To me, if I was a homeowner, I would probably look at maybe not annually, but every second year, have somebody look at it, or for sure every third, because a lot of these units now are just so self-equipped. It's like, you don't take your 2020 car to a garage to say, well, could you give it a tune-up? Because like, what are they going to look at? They'll put it on the computer and say, yeah, okay, tuned up. Here's your bill, $120 later or whatever. Um, Same thing applies on furnaces. A lot of times, people will call for furnace services, and a furnace man will go in and look at it. What I do if I had to do annual maintenances was I do amperage checks on all the equipment just to make sure that there's no discrepancy, because I keep a record of every furnace that I ever serviced or did repairs to. I have all the data, all the model number, the serial numbers, the type of repairs that were done, any of the particulars that I notice on, or the information I get when I do a service. And I just do a quick, I even put down the name of the people's dogs, just so you remember, or the cats. But anyway, then all I do is I just do a check on the regular stuff. Is the blower motor drawing the same amperage? Is the venter motor drawing the same amperage? Is it igniting within the same time? Stuff like that. Very, very little maintenance to do if they're not broken. You want to make sure the filters are clean. Most homeowners are pretty good with that stuff now, as long as they can access the filters, right? So, but the old ones, well, they were a different matter altogether. Uh, on a newer one, the ones with the venter, the power venter motor, the induced fan motors, the ones that have the the pipes going out, but or maybe going to a chimney, they'll have air proving switches, and that's an air proving switch. That's a safety device on those units. And what that does, pardon me, is that when the blower motor comes on, there's a little tube that goes from a housing there, connects to that, and this unit here would have another tube going from it, and it would go to a compartment in the heat exchanger area. It would be in a sealed area, and it's just going to be able to monitor the pressure differences at that point, which this is just a diaphragm, right? Just a diaphragm. So when the pressure is proper at this point, it'll click open the diaphragm, which opens up a switch, and that basically it sends a signal to the circuit board, to the rest of the system, that yep, the venter motor is working and it's providing enough pressure to adequately open up the switch here, so you can carry on with the next stage of your firing cycle, right? So that's what the air proving switches are for. You'll want to check, there'll be tubes coming down from these things when you see them in a mid-efficient furnace or high. This also pertains to high. You want to just check to make sure that the tubes are in good order, that they're not cracked or anything else. Those are things that are supposed to be looked at when a furnace is serviced, right? And I'll be honest with you, some companies service furnaces much better than others. Some of them just go there and give her a little dust off, and here you go, goodbye. So those are things you want to check to make sure that there's no leakage or indications of corrosion anywhere on this switch or at any points where it connects. So that's another type of switch. We won't get into them too much. This here is a high limit switch, which means it's inserted now into the again the heat exchanger area. And what it does is it senses the heat again, but this time, instead of it being a probe, this is a thermal disc in it, so that if the temperature gets up to a certain amount, it'll click which basically breaks the circuit. It shuts down everything again. All these safeties, all the wiring is tied in series so that if any safety at all shuts off, the whole thing shuts off, right? Now, some of these switches are located in places where you wouldn't even think of, like some of them are down behind the blowers and stuff like that. You're not concerned with that. You just want to know that this is where the switch is. Would be mounted on the outside, and there'll be some numbers here, and that'll actually tell you at what temperature that this switch is set at to shut off. Most of them run around 180 degrees or so. So that's something to note. All right, that's your safeties.
There's a question here, Vern. So John's asking, what can be wrong with the furnace blowing cold air instead of heat? And honestly, it could be a lot of things. Dead batteries on the thermostat, dirty furnace filters, pressure switches being off, inadequate combustion air, overheating and whatnot. I mean, really, there's quite a few, Vern. If you want to throw in some more, you definitely can. But obviously, it just means that there should be professional gas fitter or HVAC professional look at it.
Yeah, exactly. Now, when I always enjoy the term cold air. When somebody says, "Well, this thing's blowing cold air," well, actually, it's not going to blow cold air unless it's drawing air from outside. It's blowing room temperature air, ambient room temperature air. So it would be, it's cooler, right? Now, when on the new furnaces like the high efficiency and the mids, one of the biggest complaints I had when we replaced an old furnace with a newer model was the fact that they said, "Well, holy cow, this thing's blowing cold air." It's not blowing cold air. It's just not blowing hot air like your old one used to. We're not dealing with air temperatures that are 150 degrees coming out of your registers. We're dealing with air temperatures that are running around 100. And we'll talk about data plates on furnaces because they're very important. There'll actually be a spot on the data plate that will tell you what the furnace temperatures should be when they're running, right? So normally a mid efficient or a high efficient furnace, their air temperatures coming out of the registers will normally be not more than 120 degrees. They're made to move a lot more air, just a lower temperature air. Now, if you're talking about a blower that comes on, that's running, even if there's not a call for heat, that's continually running and it's blowing cold air, as you want to say, that could be an indication that either the thermostat's got a fan switch and it's on the it's set in the on position, not on the automatic, which means it'll run continuously. Or it could also mean that if the furnace has been acting up, sometimes certain safeties do go on certain models, that the blower motor will come on and it'll stay on just to make sure that if there's any overheating or anything else develops, it's not going to cause a serious problem at the furnace, right? So generally, if the furnace, the blower motor is running all the time, it means that the furnace, the fan switch is on, or there could be, who knows, if it isn't on and it still runs, there could possibly be a problem with the circuit board where it's not sending the proper signal to the blower to shut off, right? Those are indications of that. On older units, on older furnaces that have that fan limit switch that I talked about on the older ones, there's settings on these switches that will give you a fan on setting and a fan off setting, right? They're little wee dogs, and they call them dogs. They're like little levers that you move on a dial. And if the fan off setting is down too low, for example, if the fat furnace comes on, is set to come on at say 135 degrees on an older furnace and shut off at 100, then okay, the furnace shuts. When the furnace shuts off, the air will cool down enough to 100 degrees. The fan will shut off, right? If the fan switch is on off switch is set lower, say to like 70, well, that furnace may not, the fan may not shut off because it's not gonna, it's going to sense that room temperature air going through the furnace and still be above the the offsetting. Hope that answers your question. Okay, a little quick talk about the heat exchanger on furnaces. This is basically your, this would be um, your category, or I'm sorry, your mid-efficient type furnace or your high. It doesn't matter. It'll have the burners. In these cases, you'll see on most furnaces, the old furnaces, the burners were at the bottom. The heat went up through the exchanger and out, right? What we have here is we have heat that actually is ignited here. It goes through the exchanger through a number of passes, and then it actually goes through a secondary exchanger, which is what you're doing is you're trying to get as much heat as possible out of the flames, right? So as it goes through here, it starts to cool off because you've got air blowing through the jackets or whatever you want to call them. Then it'll go through what they call a secondary exchanger, which looks like a great big rat, and that will draw the rest of the heat out of the system as much as it can, so that the products of combustion now are starting to vapor. You're getting water vapor, right? That's the purpose. So then this water vapor is collected and it goes out to condensers. So that's basically your calls and notes on the heat exchange, uh, the heat exchange setup in a high end and even mid furnaces. We're not going to worry about dealing with cracks or anything like that in this, because that's a much more complicated inspection. But if you notice any type of condensation, or you know how you get the scale building up because the products of the condensation are going to be caustic, they're going to be acidic. If there's white, uh, any type of white powder, or indication that there's some kind of spillage in here, you're going to want to make a note of it. It could possibly be an indication that the secondary exchanger has a crack, so that moisture condensate is actually dripping out of it instead of going out of here, or that there's something else loose in the system. Okay. The old heat exchangers, they were made out of a good thick steel, and the exchangers didn't crack very often. But like I said, most of those furnaces now have surpassed their life expectancy. I would not expect that you're going to run into too many category 1 furnaces out in the field anymore. You can check inside if you have one of these little sea snakes we talked about yesterday, because they're handy. You can just take it and take a little peek around instead of trying to view everything with a mirror. That's nice. If you have a problem with a field exchanger, a good way to check is while the furnace is running, when the fan is blowing and you see an erratic flame pattern. In other words, the flames aren't a nice smooth burning. If you can't see it visually that they're burning nice, but they're flickering a lot, then there's a good cause that there may be. It's because it's getting air from places it's not supposed to be, and that could be from a crack in the exchanger itself. We'll talk about air filters and filtration. Now, most of the filters are installed at the return air duct at the entrance of the where it goes into the furnace, and should be accessible. You want to make sure that the filters are put in the right way, because there are arrows on them. And if you even the cheap furnaces, or I'm sorry, the cheap air filters, if you put them in backwards, what could happen is that the air blowing into the furnace could actually pull the media, the fiberglass, or whatever you want to call it, the type of stuff here, could pull it off of the filter itself. Because if you look at a filter, it'll have those little aluminum metal holes, like a cheese board kind of, and that's basically to keep the the filter from blowing inside inside the filter compartment, right? So sometimes if they put them in backwards, the damn fiberglass or the media will pull off of that, and it'll get into the blower motor. It'll jam up in there. And that's nasty. Now, as we're talking here about filters, it's a good idea to have an identify the type of filter, the condition, and the operation of the filter itself. Now, 9 times out of 10, if the homeowner knows you're coming in, they're going to change this filter. Oh yeah, better do that. So you're probably going to run into a clean filter, right? Take a look around the room, see if there's been any dirty ones left there, because if they're coated with dust and debris and cat hair, you know that no, they haven't been changing them on a regular basis. People used to ask me, how often should you change your air filter? Well, if you've got cheap ones, I'd say every statutory holiday, July 1st, thanks, Valentine's Day, Easter, stuff like that, about every 6 weeks. Again, depending on the type of lifestyle you live. If you've got a lot of animals or there's a lot of dust in your house, you may want to change them quicker. There's a MERV rating on filters now, because most people are putting higher end filters in because they're worried about air quality. And if they don't have the money to start putting in really high, expensive type of air quality devices like UV equipment or electronic air cleaners and blah, 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 you can go to a better filter that has a MERV, what they have that will pick up more particles than normal. And just so you understand that what MERV means is minimum efficiency reporting value. And it's basically, it's a number. And the higher the number of the MERV rating, that means the smaller the particles it will remove from your air. So if you have a MERV 8 filter with a MERV 8 reading, well, it's going to remove less particles, like it'll remove big particles, but it won't remove the smaller ones from your air than it would if you had one that has a MERV 13 rating, right? MERV 13 is a very popular size among on many high efficient unit furnaces now. Seems to be good, but one of the problems with that is the higher the rating, the more restriction you get in your airflow, right? Because it's now restricting the air a bit more. So that's just something that you have to know. Those are things that can be overcome because most furnaces now have multi-speed motors. So if somebody doesn't think they're getting proper airflow, this would be up to what a service technician would do. They could increase their fan speeds by just changing some things on between the motor and the circuit board to say, okay, you're going to come on at medium high speed instead of just medium speed for heating, right? Another thing you might want to note regarding filters is that the ones you buy at Canadian Tire, just the green ones and that, they're okay. But if you really want to put a decent filter in, I would go with the pleated type, like this, only because they have a larger surface area, which means that the air will go through more filter material, and they do a better job of filtering your air. They will restrict your airflow a little bit more, but not in a fashion that you would notice on a regular system, right? So the pleated filters are good. They're going to cost you about I don't know, I'm going to say probably about $6 each, in regards to like $3 each, but 3M make a good product. Okay, alongside that, where the air filter cabinet or the air filter rack should be, you may instead come across an electronic air cleaner. All right, so this would be a unit here that this would be tied right into the furnace, and your return air duct would come over here into it, and this unit here would be what they call the electronic air cleaner. And what it is inside is, if you lift this up, you'll find a metal kind of a casing that has all these wonderful little plates in it. It uses like an electrostatic type of system to pull air particles, to hold air particles then and then they get blown onto the filter material. I'm gonna be honest with you, most of these electronic air cleaners that are any more than about 10 years old don't function anymore. They have a short lifespan. They're not the most popular things for people to put in anymore because they've designed now a filter, an air filter, which doesn't use any power and is much is just as efficient as these electronic ones. These electronic ones just they don't seem to work very well. But if you do see it, you might want to just and it is operating, which you would really not know, other than the fact that if a chunk of debris goes through, you'll hear a little tick, like those electric or electrostatic mosquito traps that you have that you can put outside. These units here, you'll have different brand names. April Air is a big one, and all they are is they have just a bigger filter. Instead of only being 1 inch thick, they'll be 4 inches thick. So you've got a lot of filter that can take out a lot of debris without having to deal with an electrical appliance. Costs on these probably run about, I'm going to say $350, where these here would run probably about 150, right? The filters are a little bit more expensive to replace, but these filters will last a long time. In most cases, one filter will do you for the whole heating season. They're about $35 to $40 to replace. Condensate drains. Now, every high efficient furnace or every high efficient appliance will require some type of way of getting rid of the condensate. Now, in some of the pictures you saw the pipe coming down. In a perfect world, you'd have a floor drain very close to the furnace, so you could run it to a floor drain, provided it's not in the middle of the room. You don't want to have to step all over the pipe every time. But in a lot of cases, you may not have a floor drain. So what they'll have is a pipe that'll run to a condensate pump. This is a condensate pump. So normally you would have a pipe that would that little white PVC 1 inch or 3/4 inch pipe would run right here into this port. These are situated right beside the furnace on the side where the condensate comes, and then you'd have a little tube, a vinyl tube sometimes, most often they're vinyl, like clear plastic, and that would run up and it would discharge into an appropriate drain, right? Okay, that was all good. So these are also electric. So some of them in some situations they actually have a provision to operate these on a furnace. Not very often. Most of the time you have to run this would have a cord and you'd run it to a receptacle 120 volt receptacle that was close by. If you want to test them, one of the things you can do is there's a little plug here you can pull out, and that just gives you an access. You might want to peek in here, see if there's any scum or debris buildup, because this will have that at times. And you're not going to see a lot through that hole. And you can get something and pour some water. I use, you know what is great is just one of those things that you water flowers with, with the little green flower watering bucket. It doesn't have the sprinkler head, just has a little spout. You just pour some water in and wait for the pump to cut on. It usually only takes about, I'd say about 4 cups of water before it comes on. It'll turn on. Pump will pump this out through the tubing to a drain, and then it should shut off again. All right. If it doesn't work, you'll know, because there'll be signs of water on the floor. It'll overflow. Okay, that's pretty simple. Another thing that you're going to encounter, especially on newer installations now, is on the condensate lines themselves. They are putting more and more. There's more cause and concern regarding the type of of liquid that's coming out of a condensate. It's acidic, so it has a tendency it's corrosive, right? And yes, if it goes to a floor drain, you don't seem to be too concerned about it. But believe it or not, a high efficient furnace or a boiler uh, will create a fair amount of condensate within a day. Like you could, it would be normal for if you put a 5 gallon pail underneath a condensate, it would be normal for you to collect about a gallon and a half to 2 gallons of water of condensate on one of your colder days in the winter because that furnace is running a lot then, right? Most furnaces are designed or should be designed in size to run almost continually on the coldest day of the winter. You know what I mean? So in other words, on a day when it's minus 30 outside and you got a little bit of a wind chill going on, that furnace should be cycling on and off about 3 times an hour for sure. Usually running for about 10 to 15 minutes a shot. Anyway, the condensate, so a lot of places are now requiring that you put on what they call a neutralizer, which is just a cartridge. It's got these little lime chips in it, and it neutralizes it takes out the acidic properties of the liquid that goes, and then it goes to the drain itself. So these here are they're being put in on every new installation, as far as I know, for high efficient equipment. They run about $60 to $70, which to me is a bit of a is a bit of highway robbery because it's probably only about $6 worth of materials in it. But anyway, these are put in, and so if you see one of these, you know that it's probably been installed fairly recently. You just want to make sure that it doesn't look like it's been plugged up with anything. It's kind of hard to tell. Just make a note that it has that.
There's
Yeah,
couple, I guess, a question, and if you can go back one slide there, Vern. So I'll
sure.
just yeah, speak a little bit to both these components. So typically you're going to see these condensation drain pumps on retrofits, if you will. So because most new builds, they'll have,
Can
oftentimes
I
they'll
go to
actually
this
have a
slide where you are?
I'm sorry.
Can I go to this slide so you can see? So you
No,
can
you'll
see?
need to go back to the other one as well. But I mean, sure, that's a retrofit, right? But yeah, if you can go back one slide, Vern. So yeah, most of the brand new builds, they'll actually have a dedicated drain line through the slab, like a 1 inch or 1.5 inch for the condensation drain from the water heater, furnace, HRV, humidifier, what else they got tied in. And of course, do check out the condensation drain line or the condensation drain pump line, because if it's dirty, the actual canister, you'll see a lot of debris or even vegetation growth in the actual clear line. When you guys are doing an inspection on older homes or acreages, you may want to point out or recommend to your clients for these neutralizer chip sleeves, whatever you guys want to call them, just because again, when you have the condensation drain, condensate, I should say, it is highly acidic and corrosive. So if you're on a private disposal system, a septic, the high acidity can actually cause damage to the microbes in the septic tank. So just something to inform your clients, potential buyers of that acreage, that they should consider installing one of these. The other thing too is because your condensation is quite corrosive, when you see retrofits in older homes where they have a cast iron floor drain, you would also want to recommend that they install one of these tubes, these sleeves, because it's not uncommon to hear a lot of plumbers now or HVAC providers saying that they got to replace cast iron floor drains now because again, the corrosive nature after years will destroy those floor drains, right? So again, if you
Beating
see,
out the bottom of the trap.
yeah, you betcha. So
Exactly.
yeah, so again, just a couple things to keep in mind. I believe that they are mentioned in the module, but yeah, and there's a question from Sean here. What are your thoughts on UV light air purifiers, the ones that are cut into the return air supply? So those utilize ozonation. They, in my opinion, they work fine. They do require some maintenance, I should say. So you have to imagine that if people have dirty air ducts, return air ducts, or just dirty homes, if you will, those light bulbs will get coated in all that debris. So I mean, every 6 months, every year or so, I recommend to the homeowner to pull out those tubes or get qualified professional to clean them. You can simply use vodka or any sort of high alcohol cleaner that is rated for the tubes. They're great. Some people may get headaches from ozone. If you don't know what ozone is, if you ever stand by those big commercial printers, it's got that metallic, almost chlorine-like smell. Some people love the smell, some people can't stand the smell because it gives them headaches. Lightning strikes, they also create ozone through electrolysis. So I guess going back to your question, they're not terrible. They do help clean the air, but they do require some maintenance. And of course, some people can be affected by them. Typically, it's in very small quantities, percentages of ozone, but yeah, it's each to their own. Do you have anything to add to that, Vern?
Yeah, just you must have taught the science portion, right?
I'm sorry?
Did you teach the building science portion?
No, we had a different guy, but
Okay, yeah. I had a UV set up on my furnace when I put it in, and I got to be honest with you, I didn't notice any difference, but I did have a decent air filter system also. The problem with those UV things, UV setups, are the bulb life. You might only get about 18 months out of it. It depends. And to change the UV bulb is usually about $100. Um, I think if you're rich and famous, go for it, because you're going to get somebody else to do it anyway. For the most part, I would just rely on your media type filter systems to take care of the air. That can differ if you have people in the house that are particularly susceptible to dust through allergies and things like that. You may want to invest more in air quality then, but otherwise, on the most part, I would save my money.
one last note, and then we'll take a break. So some guys will actually also install these UV light systems above the condenser coil for an air conditioner, because of course you can get a lot of bacteria growth on them because there's a lot of condensation, which we'll talk about during the AC portion today. But it is 10 o'clock, so maybe we'll take 15 here and just.
Okay, I think we covered condensate. So when we get back, we're going to be starting to talk about some of the quick little tests you can do visually while when you're looking at a furnace. All right.
Sounds good, guys.
Okay. Are you back yet, Alex?
You betcha. Yeah, we're good to go.
Oh, are you? Okay, great.
Yep.
Um,
Actually, you know what? Let's give him 1 more minute. 14 past.
okay, that's fine. How do I switch to away from the share screen? I just have to put stop share.
I believe so.
I want to do a little thing here
Sure.
live.
Sure.
Stop share will work.
When you say live, what do you mean by that?
I mean, I want me on the screen.
Oh, we can still see you
You can?
this whole time.
Oh my God, I had a smoke too.
That's okay.
Are you sure?
Oh yeah,
That's nasty.
your house.
It is my house, yes. My
Yeah, we
castle,
can see
my
you as
bad
well.
habit.
That's all
Pardon?
right. We can see you. That's all good.
Oh, I didn't know that. Okay, well, I want to go to full screen. How do I do that?
Uh, basically, we can see you. The viewer of you will choose how big they want to see you.
Oh, okay, great.
Yeah,
I didn't know I was on. God, I'm
all
gonna
good.
have to use this thing more often in case I have to like hit my nose or something.
There you go. You got
Yeah,
it. Yep.
yeah, right. Well, that's fine.
Yeah,
It's all
take her
good.
away.
I'll give it another 30 seconds here. So well, I don't know exactly how. I don't have to admit anybody that they're all on. So
You betcha. Yep. Unless there's
great.
someone that's in the waiting room, but I'm not too sure.
I don't have anything when I hit participants.
Sure. Yeah. No, you're
I
good to
just
go
have to
then.
get more used to working this end of things. And problem is that the fellow that was giving me lessons, he only gave me one lesson. And what happened was uh, he was told that he had to self isolate because he was in contact with. He got called by a contact tracer, so he decided maybe it wouldn't be a good idea for me to go over to his house and take any lessons right now. But that's all fine. All right. I want to welcome you back here. Hope you had your coffee and et cetera, et cetera. I'd like you to pull me up on full screen if you could, because I want to give you a little demonstration regarding uh, a piece of test equipment that I think you should uh, seriously consider uh, picking up in your travels. This is gonna help you in a lot of situations, not only for HVAC, but for electrical and a lot of other things. You'd be surprised how often you use this. So this here, if you can see it, is a it's a multi-tester. I call it an Amprobe. It's only because Amprobe was a make at one time. It's very easy to operate. This one here is made by a company called UEI, I believe, or UE. It seems to be a good product. I've had this tester for about 8 years. I had a better one, but I gave it to my son, who's also in the trade. He uses it more often than I do. So anyway, what it is basically you can get leads like this, and you attach them here and here, and you can test for voltage and continuity through stuff like this. And continuity, by the way, is very important if you want to make sure that actually something is uh, that a circuit is indeed uh, uh, good, you know, and you have a closed circuit. So you can set it to a continuity. So that way, if you are checking, it'll buzz, right? It also has a magnet, so you can set it onto the side of a furnace or whatever you want to do. Okay, so that's one thing that you have going for you. The other thing is that it's also a clamp-on amperage meter. So you just push this on like that, clamp, and now you can check amperages. All right. Now, normally what you would do if you were in the field and you wanted to check an amperage, you would have to you'd clamp this around one wire. And that wire would either be the neutral or the feed, doesn't matter, going to say a motor or some specific electrical device. You clamp that on while it's operating, it's going to give you a reading right here, whether it's drawing amperage or not. Okay, so we're going to set that at the amperage, right? Like just like that. So right now it is, so it's just bouncing around, takes a minute, but I don't know if you can see it clearly, but I can. Right here is say drawing 0 amps right now because we're not testing anything. So we're going to test something, and I'm going to try to do this in the confines of my little space that I have here. And what we're going to do a test on is what the amperage draw is on my second favorite cooking appliance, the slow cooker here. All right. So the slow cooker, you can see, was on, and I have it plugged in. Now, here's the problem. How do you put this clamp around a cord or a plug-in if it's plugged in, right? Because if I put it on both things, I'm not going to get a reading. So what I have, and it's real simple, is I just made a little, oh, hold on a second, a little more cord here. I made a little a device that I just plug in line with. This works for plug-in appliances. That's just a cord, male and female end. And in between the two, I've separated the wires. So I've got one of these is the hot, one of these is the neutral, right? So I just put my clamp on one of the wires, not the ground, because that's not going to give me nothing. And I'm going to do an amperage test. So you can see here that it should be, and it is, drawing, if you look right here, 2.82 amps. That means it's drawing 2.82 amps. So it's working, right? Obviously, because I can feel it and it's warm. So that is basically a real simple way to do some tests on a plug-in type of piece of equipment. You know, this could be for anything from a little heater or a fan or your TV if you wanted, things like that. So that's a pretty handy thing. Another option, another thing you get with this type of a setup is there's a lot of times in the field that you run into places where you just can't get this clamp the way it's set up in to do a proper amperage test because it's kind of big and it takes up a little bit of room. So this particular meter here comes with another add-on, which is this here. So all you have to do is pull this out and you push this one back in. There we go. Now you'll see here, this here will be the thing that goes around the wire, which I'm going to do again. So this will get you into tighter places than you would be able to with the larger clamp. So I'm going to take that wire and I'm just going to clip it on here again. And whoops. And again, this time we're only reading, we're actually reading 1.2 amps because this thing is actually going up to temperature now. And so what's happening is that the heating element itself is is shutting down a bit because it's reached temperature, right? Okay, so that's pretty handy. Another real good function on this is the fact that this here unit has a spot where you can plug in. You get a special adapter, a little what they call a K adapter, and you plug that in a K coupler, and you plug it in here, and that will actually give you a temperature reading. Also, you can do temperature readings with that. The only thing with that is you have to take these out, and you have to turn it to temperature where it says on the bottom temperature, and it's a dedicated temperature thing. Now I don't have that C connector here because I don't know what happened to it. They have a habit of springing legs. So that is a really nice touch. And you can read you can read microfarads for capacitor testing, micro amperage, millivolts, all those things that you need to do in the field. So rather than having like 4 different testers, this is all combined in one. Real good product, not that expensive. Probably costs about 100 to 100, about $150 now. And you also have these little units here that you just snap on over top of your prongs. Just gonna put it in right there here. And that way you don't have to physically hold it in place. You got an alligator clip that holds it in. Okay, that's Vern's amperage tester. Another thing that you're going to want to invest in, and you maybe went over this with electrical, is one of these. Did you talk to them about, have they been talked about this with electrical
You bet, Vern. Yeah, you betcha.
Yeah,
In depth.
okay, that's a simple test, right? You go around, and I'll tell you whether your receptacles are grounded, if the polarity's right. This here is also another electrical tester, and
Yeah,
this
we
one's
spoke
just,
about it as well.
okay, great. So you know that if you stick it in, or you have it close to an electrical device that is energized, it should make some racket. There we go. There we are. That'll tell you that's life. Don't bet your life on these things, but I'm just saying that's that it's nice in its pocket and you can get it real quick. Okay, good. Now we're on. We're going to talk about some simple observations you should make while you're doing a furnace test or check. And one of them is called the flame disturbance test. And this basically will take mostly on category 1 units, but you can see some of this stuff occur on the category for the high efficiency if you've got good access to seeing the flame, because the flame set up in those cases is sealed, and the only way you can really see anything in there is through a peephole. But generally what you do is when you have a call of heat, once the fan comes on, once the blower motor comes on and starts circulating the air through the house, if you notice some kind of a change in the way this flame pattern is, once the blower comes on, that indicates that you're getting air into the system from a place it's not supposed to be coming from. It could be through, in more cases than not, it's coming through a crack in the heat exchanger, right? So if the flame starts flickering, and sometimes it won't be widespread, not normally, but you might have it in a certain portion, in a certain area. You might see, oh, it's flickering over there. That could well indicate that there's a crack in the exchanger, and you're getting air that would normally be blowing through the house from the blower unit, blowing out of that crack into the firebox, and it's causing a change in the air mixture at that point. So you'll get flickering, or you'll get sometimes orange flames a little bit licking up. So that's one thing, and it's relatively simple. You don't have to get too elaborate on it. Just have a good look. You got to let the furnace run for about 5 minutes before you really start to notice it, because don't forget, when an exchanger heats up, it expands, right? When it expands, whatever cracks are in it are going to amplify. They're going to become bigger because the heat is the metal is expanding. So that's one thing to note. Another thing that you're going to want to have a look at is what they call temperature rise. So your temperatures in the furnace ductwork itself are important to see exactly what's happening here. And the best way to do it is you can have like one of those probe thermometer like I showed you yesterday, or if you have one of these setups, it'll have a probe on the end of it. So normally what you do is you'll stick that probe in a spot in the supply air. Now, if you look at a furnace, a lot of times they'll have, you may notice on the plenum itself, a little spot of tinfoil, like a little piece of tinfoil. That's a tape that may have covered an existing hole that somebody has done a temperature rise on, because it's a very good idea to, when you install a furnace, to do these checks just to make sure that you got everything in order, right? You got a good temperature rise, everything's working okay. So they'll just put a piece of tape over it. If you run into that, that's a good spot to use. Just make sure you keep some of that aluminum foil tape with you so you can just replace it, right? So normally what you would do is the bare minimum is you would take a temperature reading at the supply plenum, the hot air plenum, going up to your floor registers, and you'll record that, and it should say, maybe 100 and say 120 degrees if it's a mid or a mid efficient furnace or high efficient furnace. Okay, so if you don't want to take one at the return air, you can always say, well, you know what, the return air is probably going to be about the same as the room temperature air anyway, which it is. So if your room temperature air was 70 degrees, or say it was 65 degrees even, and your supply air temperature was 120, then your differences are about 45 degrees. That's your temperature rise. You got a 45-degree temperature difference between the two. And on a data plate, will have actually temperature rise. And I know you can't see it in here, but I can see on the data plate, it says air temperature rise, real small, 75 to 150 degrees. So in other words, the air temperature rise for this particular furnace is acceptable between 75 and 150 degrees. This is an older furnace, right? This furnace is like a, oh my God, I don't know, I can't tell because I don't see the serial number, but it is 120,000 BTU firing unit, I know that. And so these are older furnaces, they're made to blow hotter air, right? So it would be fairly common for the air temperature to come out of this furnace to be anywhere between 150 and 160 degrees, supply air. Your return air is say 70 degrees even, you're looking at 160, you're looking at a 90-degree temperature rise, right? Which is falling within the limits of what this is calling for, 75 to 150-degree temperature rise. So that's your temperature rise thing. That's where it's nice to have those that particular piece of equipment, the thermometer, digital thermometer. You can make a note of that. The temperature coming out of the supply air plenum when the furnace ran after, you always do your tests after the furnace has run at least 3 or 4 minutes because everything's got to get up to speed and up to temperature, was 130 degrees Fahrenheit or whatever you want. If you want to make it Celsius, go for it. Okay.
There's a question just
Yeah.
about location for that temperature rise test. John's asking, how about taking the return air temperature at the filter slot, the return plenum?
Well, you could, but to be honest with you, I would, as long as you don't think that any, especially on the older furnaces, any of the heat that might be radiating out of the furnace itself while it's operating would be affecting the temperature at that point. Again, sometimes you'll see a piece of tape. If you don't, just what you could do if you had 2 thermometers, which is ideal. My actual tester that I used to do these temperature rises wasn't this particular unit. I had a digital thermometer. It had 2 provisions for 2 probes, one for supply, one for return. I would hook it in and it would give you what they call a delta T, the difference between the two, right? So I suppose it would be all right to do that, but what's the difference if you have it at the filter or if it's just right there close by? It's still going to sense room temperature on the most part. So yeah, I don't see any problem with taking it at the filter. And hey, by the way, I appreciate the fact that we're getting more questions now because that means you're more engaged. Thank you. And we're between me and Alex, we know everything, right, Alex?
Naturally.
Okay. All right. Total static or internal static pressures. This is something we're not going to get into. This is more of a specialized trade where they go in and they do test, what they call open door test. This would be done on a house that has R2000 ratings and equivalents, but we're not going to even worry about stuff like that. Airflow testing would be nice if you have the equipment. And I know this is a terrible picture, but I put this in this morning, snuck this in on Alex. And it basically is an a vane anemometer, which means this thing has a little fan in it. So all you do is if you take this to a register, a warm air register, a floor register, you put that on top of it or on top of it, so the airflow is directed. Actually, it don't put it right on top. Just put it in the same direction the airflow's coming out. Because don't forget, the air that comes out of a register doesn't come straight up, it goes off to the side. So you want to put it in the best airstream possible. Just hold that, the thing will spin, and it'll give you an automatic reading on how many cubic feet per minute come out of that register. And most registers, most 5-inch pipes can handle up to around 50 to 60 CFM. The register grill may restrict it a bit. And of course, they have dampers in them that you want to make sure it's fully open, so you know. And this is actually a good way of testing when people say, you know what, I got one room here. It's pretty remote from the furnace. It could be the upstairs furthest room away upstairs from the mechanical room, and it seems cold in there. You go and do an air test on it and say, well, you know what, you're only getting like about 20 CFM. You're not getting enough air out of this because there's so much restriction in the piping between the furnace and that floor register that it just doesn't blow anymore. There's not a lot of ways to rectify that. If the space below is open, if you have an open ceiling, you could possibly put in a small booster fan. They make little booster fans for 5 and 6 inch round pipe that you can put in, and that just moves a little bit more air, kind of pulls some more air through the system. So anyway, that's an optional thing. Electric conductivity, you've probably discussed this more in electrical. So you want to make sure that gas piping is going to be bonded to an electrical ground. And this is basically the type of clamp that would go on to the gas pipe itself, which would be metal, of course, because black iron and copper both are conductive. And then there'd be a number 6 bare wire going down and tying into a ground source of somewhere. Sometimes they run back to the panel. Sometimes they run down like to where the water pipe comes in from and ties in with your main electrical ground at where the water pipe comes in from the city, like a copper line, right? It's a good ground source. A lot of places don't want you to use those anymore, but whatever. All right. Now we're going to go on to inspections of furnaces. And this will apply pretty much to all furnaces that you're going to deal with. And a lot of the stuff that's in there is also going to apply to the other appliances, boilers, fireplaces, and blah, 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 that we'll be covering. We're going to go as quick as we can so we don't bog down too much by the end of the day. Rating plate, I showed you one before. That is particularly important because that's going to give you all the information that appliance has. It's going to give you the manufacturer, the make, the model number. I'm sorry, the model number, the serial number, the BTU rating, which means what capacity it's rated for. Is it 75,000? Is it 100,000 BTUs? It'll also have all those other things there, the power source, the temperature rise, a lot of the things. So that there is important. And I know that when you do your inspections, you're going to be using your camera. If you can get a picture of that, you take it for sure. Keep that in your file. That is the rating plate for that furnace. That overrides everything else you've done so far because that's going to give you all the information. What you do with it is just, there's your file. This is what you can base your documents on. This is the furnace that you have. This is the size, blah, 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 right? I stress this to any of the guys that do furnace work and servicing. Take pictures. I mean, you know what? That 15 years ago, 10 years ago, it was a little bit painful to, you carry around a camera. I carried around a camera, one of those little Canon shot cameras that digital you can download. But now with a phone, you can fill your boots, take the pictures, download it on a file. There's your file. Joe Blow's house. There's all the pictures from it, right? Good starting point for the furnace inspection, especially on the high efficient units, is to check the LED displays. Now, what you'll do is when you come in and when you look at a furnace and it's a high efficient, which you'll be able to determine quick enough because it's going to have white plastic pipes coming out of it, 2 of them, one going out or both of them going out. You're going to look at the blow on the lower compartment. Usually that's where the blower door is. There's usually a peephole that's on that door. You look in that peephole, you might not be able to see it directly in front of you, but look side to side, and you will see a light coming from the circuit board. Now that light, in normal cases, if there's if it's not calling for heat, will be on, and it may just be a slow flash, right? Then when you activate the furnace, when you turn it on, it'll start to display different lighting codes, and these codes are really important because that will give you an indication of anything else. And as a serviceman, those are the codes that you need to know in order to check. It helps you diagnose the problems that you have with the furnace. It'll give you a code. You check with the manual to see, and sometimes the codes are even on the inside of the lower doors. You can pull it off and it'll have the wiring diagram. It'll have a code thing. That'll give you the, if it's like 3 flashes, three quick and two long flashes, that might say it's got a problem with the air proving switch. So, okay, air proving switch, all right, what could go wrong with that? Well, first thing that we want to check, make sure that the vent's not plugged outside, right? Because if that vent's plugged, the air proving switch is going to come on. So you want to take a look at that. You want to just see, is there a light there? Is it blinking? Is it doing the normal thing? Fine. You're not going to know until you open the door. And at that point, a lot of times, as soon as you open that blower door, bang, kills the power to it, right? Now, on most furnaces, you're going to find a lot of them will have 2 compartments. One will have the upper compartment where the burners and all that are. So that one always comes off first. So don't try taking the blower door, the bottom door off if you don't take the top one off, because a lot of times the top door is tied in kind of with the bottom door. You got generally in most cases you have to give it a little push and a lift, and it'll slide it up, and then you can pull off the burner door. Same as the blower door, you pull that out. Now that blower door, once you open it, that's going to activate that kill switch I was talking about earlier, which means you've got to be able to close that off. Use, you know what, if you don't have any clips, what's great is that Gorilla Tape, that black Gorilla Tape. Looks like electrical tape, but it's Gorilla Tape. That stuff sticks to everything. That'll hold that, because a lot of times electrical tape will pop off, but the Gorilla Tape seems to hold it. Okay, once you got the door removed, you're going to inspect for all the stuff we talked about before. Again, pay attention. If you smell gas, that is a problem. If you don't have a combustible gas tester, you're not going to be able to exactly determine where it's coming from. You can, however, get products called leak detector, and I think that you may have talked to. There's some other stuff in this module that you can just use, and it's just a liquid. You pull it out, and it's got like a little round sponge ball like you have on some of those little glue containers. You just take some of that and soak the joints around inside the furnace where the gas valve is connected to the gas piping. See if it bubbles, because basically it's like a soapy solution. If you have bubbling, you've got a gas leak. You got to notify the owners right away that there is that. You're not gonna. I don't know if it's bad enough. Take it upon yourself, shut the gas off, and say, look, I had to shut the gas off. There's a severe leak there, right? And you'd be surprised what happens. I had a furnace one time. A friend of mine had a furnace, and he said he gave me a call. It was in July. He says, yeah, you got to come over here. He said, I got like this crazy gas bill. My furnace isn't even running. That's the only thing that is gas in my house. And I went over there, and he had a flexible supply in his furnace. We'll talk about flexible supplies later. And it had gone out, and there was a big scorch mark on the side of the furnace. And there was a hole in this gas flex pipe, and there was gas leaking through this hole steady, right? We figured it out because we both were on the fire department at the time. We figured, how could this happen? He had a lightning storm about 2 months earlier, and he had a lightning hit very close by. It must have zapped his gas piping because his gas piping was not bonded to a ground, and the power and the gas pipe went to the easiest point it could possibly go to. That was grounded, which was the side of the furnace, and it caused a hole. Anyway, those are things that you can run into. Blah blah blah. Sorry. Category 4 appliances. We know condensed fuel gas. Check for signs of leakage, as condensate will damage material within the cabinet, and it'll be very evident. All right. Condition of the filter. Those are things you want to check. If you have a humidifier, we'll talk about later. See if there's been leakage there. Anywhere where there's possible leakage, again, you're dealing with just basically the furnace area. Is the blower motor, if the blower motor is visible and can see it relatively easy, is there a buildup of dirt? You can usually tell. If you can't tell if there's dirt on the blower, inside the blower itself, then at least take your hand and make sure the blower is not going at the same time. You don't want to safety first, but take your hand and just rub it along the side of the housing, on the side where the air, where the return air, where the filter is, and just give it a rub and see if there's any residue on that right there. If there's any type of oily or dirty residue or dirty, that's an indication that the inside of the blower is probably really dirty too, right? That's an easy way. If it has a belt, you'll check the belt. We talked about that. And that's basically visual stuff you might want to do before you fire up the furnace. Then you can fire it up. You'll probably want to put the cabinet door back on to do that, because there's no reason why you don't have to get into that compartment anymore. And you don't want to have too much air drawing out of that compartment anywhere else anyway. So then you can fire up your unit, check your flame, your patterns, check for rattling, the venter motor. We talked about anything that doesn't look right. Now, when you're done all this, I have to stress something. Make sure that after you put all the parts back on the furnace, including all the doors, that the furnace turns back on and off again. Nothing worse than not having a door put on properly and the furnace switch doesn't operate the furnace, right? So you leave, and like the next day you're getting a call because this furnace hasn't come on since you left. Very embarrassing. It has happened to me. And don't check anybody's furnace on New Year's Eve after you've been drinking either. It's not funny. Do not check furnaces for your friends at a party. You say, no, I'll come back and do that in a dedicated time, because that happened to me and I left the compartment off, the door off improperly, and I heard about it the next day. Okay, we're going into boilers now. So boiler situations are now becoming very common. They were common before, and for a while they sort of, like in newer homes, they were sort of dropped off because there is quite an added cost in putting in a hot water heating system as compared to central air. But because some homes are getting so big now, in order to properly distribute heat through a house, sometimes the ductwork systems aren't adequate, and a lot of homes aren't designed to accommodate ductwork on second floor levels. How do you get ducts up to each bedroom and room up and onto the second floor without having to run another ductwork system, which would mean you'd either have to bulkhead the ceiling or have a higher ceiling and drop it, which most builders don't want to do. So hydronic heating is becoming very popular again. Plus, with the advent of really good top-end equipment that can provide heating for this type of setup, that it's becoming very popular again. So anyway, we're going to deal mostly with the standard systems. So your basic components of we call this a hydronic heating system. By the way, do not call a boiler a furnace, please, or I'll take away your license. Anyway, so basically you have a boiler right here, and you'll have circ pumps, and we'll talk about circulation, and I can't, and I stress how important circulation pumps are in a hydronic system. Flow is everything. That was what I was told by an expert who trained me when I first started getting into hot water heating 30 years ago. He said, flow is everything. So you'll have circ pumps, you'll have air expansion, you'll have makeup water, a control system, and of course what they call heat emission units. In other words, how do you distribute the hot water from piping to the living area? So of course you can have, very popular now is becoming radiant heat. We're not going to really deal with a whole lot of that because it is complicated, but we'll touch on it. But you'll also have what they call convectors, which are the common baseboard units. You'll see that stuff on that further down, and or radiators, or sometimes heat coils in a fan unit that blows air that heats up and heats up the air that's moving around. Very common. So anyway, you have a boiler system, basically heats up water. We got a little section here on steam heating. What can I say about steam heating? Honestly, do your visual checks. It's very complicated. Those are things that even a lot of younger journeymen and plumbers and heating guys are not very familiar with, because they're not as common. They're not very common. We don't even find them in houses, so we're not really going to deal with them at all. If you do run into a steam system in a house, I would make a note of it. And if, to be honest with you, I would just make a note of it and move on. Perfectly honest. Just say, house has a steam boiler. Chances are it's very old and should be checked by a qualified steam fitter or gas fitter. You got anything to add to that, Alex?
No, that's right. Chances
Good.
are you guys won't see it.
Yeah, exactly. So let's not go on to this page. We'll talk about, we'll get into the boilers now. So it will be fairly common that you will run into category 1 boilers, because they're I'll tell you about boilers. Some of these boilers will last 30 to 40 years easily. I've seen boilers that I worked on when I was 25 or 30 years old, and they're still running today. It's really hard to talk the homeowner, especially if they've been living in that house all their life, to change the system unless it absolutely starts blowing apart and burning, because there's very few things that actually can go wrong with them, right? Not like furnaces, for example. But so you will run into furnaces. They'll have a draft hood, just like everything else. They'll have a vent that goes up to a chimney, and you'll see here in this picture, this is what they call a C vent. We're going to talk about that, which means it's basically single wall aluminum pipe, heavy gauge aluminum pipe, right? So that goes up to a chimney, and heaven forbid the chimney should have a liner in it. But a lot of times in older houses, the chimneys were brick with a tile liner, and a lot of old boilers that, if they haven't been upgraded, may still have that going in, unless the gas company has said, no, you've got to put a liner in, which can happen, right? So the boilers are usually made out of cast iron. The older ones they're cast iron, so they're very heavy, maybe considered high mass. So they contain a large amount of water, and they run quite well, despite the efficiency, which means that at least 20% of all your heat is going out the chimney. So you'll have that type, and then you'll have copper fin or stainless or aluminum fin tube boilers, and they're basically called a tube boiler, is what we refer them to, not a once through. That's more of an American term. All right. So now what we've got here is, on the most case, The boilers, this year boiler is still considered a class category 1 boiler because it still incorporates a vent hood, which is this. This is where the air comes in from the dilution air from room, mixes with the flue gases that come up, and goes out the chimney. What you see here is called a vent damper. We're going to talk about those later. And of course, this has got a circ pump. It's going into the return side of the boiler. Here's your boiler feed coming in. We'll be discussing those with more detail. And this is the pipe, hot pipe going back out. All right. So for a while, they came out with a more what they called mid-efficient furnace, which meant they were a little bit higher than 80%, but still lower than 83. And some of them would incorporate this vent damper to do that with. Some of them used a different type of pilot system. So instead of the pilot light being on all the time, it would be activated by a sparker. The sparker would come on, ignite a pilot. The pilot would then do the same thing that it did if it was running all the time, heat up a safety, a sensor or a thermocouple, and turn the boiler on. Okay, so but the procedures on those are not much different than the visual checks you would do. It would be on it the same as on any gas appliance, right? So then you get into the category 4 boilers. Now these are more high end. These are very expensive. This boiler actually here is exactly the same as one of two that the city of Kenora uses to heat the Kuwait Arena. Now we're not heating the inside of the arena portion, but we are heating a large area. And these are high efficient units, so they incorporate a very elaborate air a power venter to displace to move the air of the products of combustion up and through the exhaust system. They have your vent piping going out to the outside out the wall, or some of them go out the roof. This one here has an intake pipe coming in. This is air coming into the unit. And you might notice here that there's a different color in the pipe. This manufacturer here says that you don't have to use the 636 system in order to vent or to exhaust or to bring air into the system. So they said you could just use a PVC pipe. So it's approved for that. The gas company says, okay, we're going to do that. But anyway, regardless, they do condensate. So you have the same situation you do with a furnace. It'll have condensation coming out, which is right here, and it'll go to a neutralizer and to a floor drain or a condensate pump. All right. So these are, you can open this up and you can take a look, but she's pretty well, looks Greek to most people. The system, another really important component of the hot water heating system is an expansion tank. And yesterday we talked about expansion, how water expands when it heats up at a hot water tank. Well, this definitely is going to happen on a boiler system, because a boiler system is a closed loop system. In other words, you've got water feeding into it, but there is no way that any of the water from the heating system itself can ever back up into the potable water. So there's no way that it will ever there's any room for any type of expansion to occur once the water heats up. So you're very dependent on an expansion tank. And depending on the size of the boiler system itself, the expansion tanks can vary anywhere in size from, usually smaller systems might have a tank that's 3 or 4 gallons, which is about maybe about 20 to 24 inches in height or length, and usually about 16 inches in diameter. It's important that this is in place. You'll see actually on, oh no, you won't. Sorry, I was going to say that the expansion tanks, for example, that are required for bigger systems are much bigger. The one at the arena is about 24 inches diameter, and it's roughly It's probably about 48 inches high, so that's a big tank. If if the expansion tank uh, didn't exist on the system, then what would happen is every time the boiler is heated, the pressure relief would open, just like we talked about on hot water tanks. If you have a tank that is faulty, there's going to be indications when the boiler is fired up. There's going to be some situations that'll occur. So when the boiler fires up and you want to and you're going to test its performance, you're going to want to for sure monitor the gauges. You'll have this gauge is what they call a triactor, which means it has a temperature, water temperature reading, and it also will give you a pressure reading. All right. So what you want to do is make a note of what the pressure and the water temperature is before you start. So if it's a boiler that hasn't been on, if it's not in the heating season, generally your water temperature will be around room temperature. It might be 70 degrees Fahrenheit. Your pressure though should be reading at least between 10 to 15 pounds pressure. That has to be on. If there's no pressure, that means either there's no water in the system, something's wrong, right? Like there's no pressure in the system. Could be a possible problem with water coming in, your makeup water source, or a valve shut off somewhere that shouldn't be. That you shouldn't run into a case like that at all. So you make a reading of that. You fire up your boiler. It's going to take a while to heat up. Again, probably much longer than a furnace. You're going to want to fire it up and have it run for at least 10 minutes before it starts really getting your temperatures up. Again, depending on the type of boiler. Older boilers take longer to heat up because they're high mass. Cast iron, a lot of water, takes them a while to get warmed up, but it also takes them a long time to cool off. So after about 10 minutes, you should be able to start recording some stuff here. Your temperature should be starting to climb, and your pressure should remain relatively static. In other words, it should be staying around the same pressure it was when it started, right? If it starts to climb up significantly, like if all of a sudden this pressure gauge is reading 20 pounds, that means that water that's in the system is expanding, but it's not being handled properly. The expansion tank is not doing the job it's supposed to be doing. It could be faulty, right? And in cases like that, what happens then is the pressures will eventually climb, especially when it gets colder out and your boiler is going to be, you're more dependent on its use, is running more often. The pressures are going to climb right up and start triggering the relief valve. And we'll talk about the relief valve because it is much different than the one on your hot water tank. Hot water tank senses temperature and pressure. On a boiler, you're only sensing the pressure, right? It doesn't go by temperature. Okay, another device that is on the system is a backflow and pressure valve, which is basically a pressure reducing valve. This will be coming in from your water pipe. Usually you just have a 1/2 inch copper or PEX line coming from the water line, feeding this. Make sure you've got a valve that'll shut that off, isolated, because you have to be able to shut the water off the boiler somehow if need be. All right. And that this is in place. Generally, the relief valve, I'm sorry, the reducing valve will have a tag on it, and it'll have the make and the model and the specifics of that valve. So this valve, for example, is made by Watts. I just know that by looking at it and the type of tag that's on it. And it'll say Watts number 30XL pressure reducing valve. Factory setting, 15 degrees PSI. Its rating is for up to 150,000 or 200,000 BTUs, which means this boiler feed is made for boilers that are rated at up to 200,000 BTUs. You wouldn't have a feed like this on a big boiler in a commercial system. You'd have a bigger feed. And it'll also tell you, it may have a date code stamped on it, because these two are susceptible to the conditions of the water that comes in. You're going to get these are going to collect the sediment, especially so because most of the time, once the boiler is filled up, these operate very hardly at all. The only time that they ever come on is if for some reason the pressure starts to drop down on this side of the system, and the diaphragm and the sensors say that, then it just puts in a little bit more water. It doesn't take a lot. It might only take half a gallon, if that, of water to take a fairly a relative medium-sized system from say 10 pounds pressure back up to 15. It takes very little water to do that. You'll also want to note here that this type has a built-in backflow preventer. So that means that you don't need any other type of device on this side to ensure that water doesn't go through the back from the boiler into the potable water system. Some of them don't, and I do have some examples of that, I think, further down. But if it has a system like that, it's a combination unit. If it just shows one thing like that, that means it doesn't have a backflow preventer. Okay. So that is there. Incidentally, these lines here, the water here, usually will tie into the return water piping, so that if you do get any water that mixes in, it'll mix in with the return water temperature or the return water, and it doesn't affect the temperature that's going into the boiler greatly. And that's usually the convenient spot to put them. Now, you'll have a sediment drain or a boiler drain, and that's pretty much a must on any boiler. It doesn't matter where, how it was made. You got to have some way of draining that thing down, especially if you're going to, remove it, or if you're going to, if you so believe in shutting down your whole house and moving away for the winter months, which is a nice thing. So you'd want to drain your boiler and stuff. That usually doesn't happen with boiler systems, because you're going to want to maintain the heat in a house like that, no matter if you're there or not. There's just too many things that can go wrong by not heating a house that is hydronically heated when you're gone for the winter. There's just too many places for water to collect. Piping breaks. It's nasty. Anyway, you need a sediment drain. One of the purposes also is that that the homeowner should open these up periodically and just run off a little bit of water. It doesn't take much. Maybe run it off for about 30 or 40 seconds. And all you're doing two things. Is you're flushing out any of the sediment that might be collecting at the bottom of the boiler, and you're also cleaning out this bit, because if this thing doesn't get opened up very often, and you go to open it when you need to, you won't get any water coming out, because this whole thing's all plugged up with sediment, right? So that's a thing. I don't know, and Alex may add into this if he wishes, but I don't know if I want to open that up if I was doing a home inspection, because if they were corroded, you may not be able to get it to close again properly, and it'll leak, and then you have a problem in your hands, right? Same goes for the relief valves. So your pressure relief valve is on the top of the boiler, right? And again, we're talking pressure relief only. It's not a temperature relief. These will go off generally factory set at 30 psi. So boiler systems and hydronic systems are not made to be subjected to pressures higher than that.
Yeah, don't touch valves, guys.
No.
In general, unless again you get consent from the seller.
Some larger systems, it's code actually to have this valve replaced every, I think it's 2 years or 3 years but these would be pertaining to boilers that are over 350,000 BTUs. So I don't think you're going to run into that. Anyway, that's the story about the pressure instead of pressure relief valve. Again, it'll have a tag on it. You'll see there's a tab on top. Don't touch that. the tab, because that's what triggers off the relief valve. If you see indications of leakage, like if this this tube, this dip tube or whatever, or down piping tube goes and you see water collecting on the floor, or there's any type of leakage there, you want to take a note of it. That means that this thing's been dribbling through somehow. It has to be made out of metal. I know this is white. I'm going to say I'm going to just, as a benefit, I'm going to say it's made out of PEX, because I'm looking at, looks like crimp joints. That's not good. You don't want to have this made out of a plastic product, all right? Because there's some really hot temperatures that can come out of this. So these should be metal, made out of metal. The system pressure gauges are really important. If you find a hydronic system that doesn't have it, that the gauge is inoperable, you've got to make a note of that immediately. That's important. They're there for a purpose. And that's the only way you can really monitor what's going on in that system, is by looking at the gauges, right? And just ask any power engineer. The first thing you learn in power engineering is how to do this. Tap, tap the gauge. I used to share an office with an instructor who instructed power engineering. I used to drive him nuts by going tap, tap, tap. Anyway, some of the boilers that you'll encounter, like the smaller ones, blue ones, if they say Well McLean on them, they'll have a door. Open that up. The gauges on those are inside that compartment. They're not on the outside of the boiler. So you'll see it. It'll be right there. It's very visible. And that's giving you all your information that you need, like we talked about. The PSI here and your temperatures here, right? So again, most of the time you're dealing with a pressure that's sitting somewhere around this area. This gauge is a little bit different. This gauge may be coming off of a different appliance, because usually you wouldn't have a reading of going up to 200 PSI. You sure don't want to have one of those on a boiler. Air valves. Air in a system is going to cause nothing but grief anywhere. Any type of air that is in a hydronic heating system will affect the performance of the whole thing. And I don't know if any of you do have hot water heating in your homes or whatever, you'll know how important it is to have heat coming out of the rads at the upper levels, right? And how sometimes you'll go into a room and you'll say, gee, how come I don't have any heat coming out of this I'll call it a rad, it's, even though it may technically be a convector. How come there's no heat coming out here? Well, there's a good chance that there could be air in it. And because the pressures, especially at the higher levels, are much lower than than down in the mechanical room, then you don't have enough water pressure itself to force that air through the system, right? Now, so you have to incorporate some type of way of getting the air out of the piping system. And one of them is at the high points, very common on each of the rads. They'll have a connection. Usually it'll be on the returns side of the radiator. In other words, the hottest water comes up on one side, goes through the rad or the convector, and then it goes back down down through the floor and off to the next spot. Well, at that point where it goes down, most of the time you'll have what they call a baseboard tee, or sometimes they call them radiator tee. So it'll be like a 3/4 inch copper by 3/4 inch copper. And these are all copper fittings that you'll be running into. That sweats onto the rad, and then the pipes go down. Well, on top is a threaded little a threaded tap, and a vent will tie in. This is an automatic air vent, it's called. These are really popular. This is a Matomist model 75. It's made out of brass, so it threads into that. And then on top is a little air cap. It's similar to your cap on your car tire, only it's smaller. Those there, what you want to do is have that, open about a quarter turn, maybe even up to a half turn. And that way, there's a little bellows in here so that if any air accumulates, it actually, the bellows separate it from the water and the air is pushed out of the system via a little air cap or the air valve that's on top, a little sniffer valve. Okay, so it's important that the cap be loosened. It shouldn't be right off. Reason why, if you leave them off, they get subjected to get debris in it, things like that, and then they start to leak. And if these leak, guess what? Where's the water going to go? It's going to dribble down the pipe into the floor area below, and you'll have a problem, right? So now, sometimes, most of the time, it's really hard to inspect any of these air valves that come off of convectors because they're behind, they're in behind the casing of the unit itself. They'll be on one end or the other. Some of them have hinge covers, so you can actually pop it up and take a look. A lot of times you'll find you can't even access the convectors because there's beds in the way, there's bookshelves, there's all kinds of things that happen that people will put in because you don't have, you don't worry about that stuff, right? So that's one thing. More and more common now is you'll find what they call an air purger or a scoop, and this will be down in the boiler room, very close to the boiler pipe, and it'll incorporate one of these units on top, and down below you will have, in some cases, this is where they actually will tie in the makeup water, so that that water that comes in from that pressure regulator will sometimes run from that point and tie in here. It's got a 1/2 inch port, very convenient spot for the water, or for the makeup water to tie into. So sometimes they just have a hose bib on them and a drain, right? Anyway, as your water goes through this, and you see they're made so that they have a different an arrow to determine the direction of flow, because that's important. As water goes through this, there's a little baffle in here that separates the water so that if there's any air on the top of the water, which is where it would normally be, it would be diverted up into this area, and this here would pick up would take the air and eliminate it out of the system, and the water would go back down, right? So it's very common to have these in the system, and sometimes you'll actually hear air coming out of it, like every once in a while, little sputters, right? Shouldn't get any water coming out of it, though it does happen. If you do see water trickling out, that probably means that this air vent needs replacing. The bellows is starting to rupture, it'll leak, and that's just something to note. Is water dripping, slight leakage out of air vent at the purger. Okay.
There's a question, Vern. What is
Yeah.
the common pressure limit for a residential boiler?
The common pressure limit. Well, those pressure relief valves are set to go off at 30 psi. That's the standard amongst all residential boilers. That means that the pressure inside that boiler or any part of that plumbing system that is part of that closed loop, if the pressure goes up to that point, that relief valve goes off. So 30 pounds pressure. And as I said, normal operating pressures for those boilers usually around 15 psi. Some boilers will have slightly higher pressure. If you have like 3 stories, for example, you've got to have enough water pressure in that boiler system to be able to get water up to the highest level and still have it circulate through the system. So 30 psi is your limit. Hope that answers that soon. Clear enough?
You bet.
Zone circulating valves, zone circulation pumps. Circulation pumps are used to force water through the boiler system, which is one of the reasons why these hot water heating systems have now become very popular again, is because you can utilize pumps to take care of certain areas. In other words, you don't have to heat the whole house up. if you only really want to heat up one particular area, because you can divide your system now into what they call zones, right? And but for all intent and purposes, we're going to just deal with the circ pump itself right now. So this is your common use circulating pump that you will find on a hot water heating system. This actually isn't on. This is on a potable, or this is on a radiant heat system that's probably tied into an instantaneous heater, because I think this may not be a cast iron unit. Yeah, it is. It's okay. This is hot water heating. You'll see here that some circ pumps have what they call a flange. This is a flange. They're always, almost all of them are on hot water heating are flanged. In other words, that's how you connect your pump to the rest of your piping system, through a flange here. Some domestic circ pumps for domestic water, potable water, some of them have solder joints, but on the most part, let's just deal with the flange ones. You'll see on this one, somebody didn't spare the expense, and they put what they call a ball valve flange kit. In other words, there's a valve on each side of this pump on the flange. So if this pump has to be changed, you just shut that valve off, undo your bolts, and this whole thing comes out. There you go. Put in a new pump. Bob's your uncle. You're done in 20 minutes, if not sooner. Then of course with this, when you reactivate it, you're only dealing with a very small loss of water, which means you're not going to get a lot of air in the system, right? So these are really nice to have. What you do want to note, though, is that is there indeed a way to isolate the circulating pump so you don't have to drain the whole system down, or half of the boiler, or whatever, in order to change it, all right? Those are things that you want to know. Now, we talked about circ pumps yesterday, so we're not going to get into them a whole lot. A lot of the pumps on heating systems are multi-speed. They might have 3 speeds, and there'll be a speed selector here. Most of the time, they'll be set at medium, usually medium. Sometimes they'll be set high, and that basically just determines the amount of flow that this pump is pushing through the system. How many gallons per minute it's pushing, because too much flow is not good, and not enough flow is not good. But flow is very important in the whole system, right? Now, you're going to run it into zone valves in most cases now. In older homes, a lot of the systems only had the circ pump, and that was it. One thermostat controlled the whole thing, and your hot water was, when there was a call for heat, it went everywhere. Well, in newer homes, and when I say newer, these can be 25 or even 30 years old, that would have the piping systems are split up. In other words, this pipe here might go to the bedroom. This pipe here may take care of the bathroom and the hallway and certain areas. So you can have individual heating for individual rooms and for individual preferences. One person might like their bedroom colder, cooler. One person might like it warmer. So as long as they're not in the same room and have to share the bed, they can, one can have their thermostat set at 21 degrees Celsius. This one can be set at 18, right? These zone valves are made to control that temperature. So in other words, you're getting a signal from the thermostat to the zone valve to say, yeah, there's a call for heat. So the zone valve will open. And when the valve opens, there's a little end switch on these that will send a signal now to the rest of the boiler system to say, yeah, there's a call for heat. It'll activate a circ pump, and the circ pump, and it'll activate the fact that the boiler says, okay, there's a call for heat. We got a circ pump on, we got a zone valve open. We need to up the water temperature X amount so the boiler will come on. If the boiler water is at a temperature where the boiler doesn't have to come on, if it's still got warm water coming on, then it just activates the circ pump, right? And most of the time, uh, the circ to circ pump, a lot of times now these are set up so that they have individual circ pumps. So this may open up a specific circ pump. In most cases, if this just goes to a single circ pump, all that really that end switch does is just say there's a call for heat. The circ pump will turn on via a relay, and once that happens, everything else happens because the circ pump may be running all the time when the system's on, or if there is a, like I said, but most of the time now they're set up so when there is a call for heat from the thermostat, doesn't matter where it is in the system, circ pump turns on and everything is the system starts to activate. So that's why you'll see a lot of cases 4 wires coming out of a zone valve. 2 are thermostat wires, 2 are going to uh, the circ pumps or the circ pump or a different type of a control system to tell the system that the valve is open. This valve doesn't open, it won't activate the end switch. Okay, now on most boilers, you'll have what they call an aquastatic control. In other words, something that's got to control the water temperature in the boiler itself. Like most boilers will have them built into the boiler. Some will require the aquastat, which is we'll just call it a thermostat in a sense. It's a water thermostat. Will require it to be in another spot to provide a safety as a high limit, for example, just in case the one inside the boiler system starts to act up. At least this one here is going to sense the water temperature, and if it gets to a certain point, it's going to shut the boiler off. It's going to say, you know what, your water's too hot, got to shut off, right? So that'll activate. Here you've got a pressure or this is just a temperature gauge. It's telling you what your incoming water is, and the things that you want to note is that this gauge, temperature gauge, and the aquastat both have probes on them. So this thing's not going to do you any good if it's up here 12 inches and then there's a big piece of pipe in between, because it's not sensing the true temperature of the water that's flowing through the system. And neither will this work properly. Both of these the probes have to be put in the stream of water that is going to the boiler or going away from the boiler, depends which side it's on. Most of these systems are on the supply side, which is the hottest water temperature, right? So that you got to make sure that these are close. Not much else to say. Again, just make sure the thing's working. There's not corrosion around here. Uh, some of these are very easy to replace because they'll be put in what they call a well, an aquastat or a thermostat well. In other words, this portion has got the probe on it. It's threaded in. And if you want to replace this, all you have to do is undo a screw. This whole thing will pop out without water coming out of it because this is a sealed unit, same as that. They're very handy. You don't have to drain anything to change these, right? You just have to undo the screw, pull that out, put a new one in, rewire it. This one here, you just undo the screw, pull it out, put a new one in. There you go. Bob's your uncle. Okay. We talked about the makeup water already. So this here is a Bell and Gossett pressure reducing valve, very common on systems. It does not have a preventer, anything to prevent backflow through it. So generally you will have to see another check valve or something on this system. And a lot of times it is just a swing check. They don't get too, a lot of times they don't get too elaborate with exactly what type of a backflow preventer they put in. On the bottom of these and this are a nut. And what that is for is when a boiler technician comes in and does a service on boilers, it's much more elaborate and complicated than doing a furnace because there's a lot of parts there that you have to take care of. And one of the things you want to do is you want to take these nuts out that here, and inside there's a screen, and that screen is basically there to prevent any particles that might be in the water, rust, pieces of metal or whatever, sand, if you can get that in water systems, if they've been working on water mains outside, you get sand in water systems from affecting the pressure reducing system, because this is a series of springs and diaphragms and stuff, right? Very dependent on that. So these here are basically you take them out and you clean them. They're just screens. You clean them so that in case you get because they're going to get dirty, so that they don't plug up or deteriorate to the fact where they actually cause more problems than they're worth. So that's what those things are there for. Again, not much more to say about that. Okay, I talk a little bit more about makeup water. Now, not all systems now are using just this or this to fill up water systems like hydronic water systems. Almost all the new ones that we're putting in nowadays are using what they call a glycol feeder or a water feeder, right? Reason why we'll talk about glycol in a minute is the fact that uh, instead of having water come straight from the water system into the boiler, the water system, the potable water system will feed water into this tank and it'll shut off at a certain level. And that way, if there is a call for water from the boiler due to pressure loss or whatever, this will actually pump water the into the hydronic system itself. And the reason why these are being put in is because more and more people are now starting to put glycol into their into mixing glycol with the water in hydronic systems. A, because it uh, it's a preventative measure in case the building doesn't loses its heat. Number two is the fact that a lot of these systems are put in the slab, so sometimes slabs are in areas where it's more of a preventative measure. I honestly at first I was not advocate of putting glycol in a system because to be honest with you, glycol say a 50-50 mix between glycol and water has actually got poorer heat transfer than water itself. So you get a little less heat transfer when you're dealing with a glycol mix of water than you do with just straight water. But then again, if you do want to shut your system down, uh, you can do that without worrying about having ruptures or frozen pipes in areas where you're not going to drain it. And you're definitely not going to drain water in a slab unless you get an air compressor and start blowing all the lines out. And you might as well just not go south because you'll be spending most of your time doing that. All right. So these glycol systems are pretty common. Most of them you'll run into will be new. They shouldn't need a whole lot of uh, they shouldn't be prone to too many problems at this point. And the expansion tank for this system is built right in. You can see here it's got a, a system, a glycol system, or a condensate system coming out, and it's tied in with the boiler, which is probably a tankless boiler, and it's tied into a neutralizer right here we were talking about earlier. You probably won't run into these fixture or these safeties on a regularly or a normally installed boiler, but if you have run into a building where your boiler is in an elevated level, for example, say your boiler is in a mechanical room upstairs, but you have heating rads and stuff in the basement, then what happens is you need some kind of a safety that will tell you that the boiler doesn't have any water in it, right? Because if say something happens and one of your rads break or start leaking so badly that the water actually bails out of the system, you're uh, what's going to tell the boiler that there's no water in it? Regular systems, because the boiler is at the lowest place, you don't need a low water cutoff. But if your boiler is elevated on another level above the lowest point of where your water would run into, um, you need what they call low water cutoff. In other words, some kind of a device that'll tell you there's not enough water in the boiler, you better not fire it up, because if you do, it's going to just like melt, right? So there's two types of low water cutoffs, and they're always situated right at the boiler. And this is a float type. In other words, there's a little float in here, so that if the water level drops below this level right here, that will shut the boiler off. It will send a signal through this. It's like a switch saying no water, no go. Kills everything, kills all your power, right? So this level here on commercial boilers, these things are always set right beside the boiler, and this level pretty much corresponds with around the top of the boiler itself, right? Just so that if the water um, does drop below that level before the top of the boiler itself, it'll shut the boiler down. They're never low down, because that won't do any good. So they've always got to be above above the recommended water limit in a boiler. This type here is an immersion type low water cutoff. This would screw into the piping right beside the boiler, and that senses water in the system. And if it doesn't sense it, again, it sends a message to the boiler saying no water, no go. So these are a little more elaborate because they have lights that tell you, yeah, that's good. Ooh, that's not good. Oh, you want to test it? Okay, I'll test it. You test that, you make sure, yeah, it's working. The boiler shuts off, right? Yeah, they are still common. Or I'm sorry, they're becoming more and more common in residential situations where you have an elevated boiler. Okay. Flow switch. This is, again, you don't run into this as much on residential boiler systems, but they're definitely incorporated on tankless hot water heaters and tankless boilers or combination units. Pretty well all of that is all the flow switch devices are incorporated in the tankless and combination boiler units, the ones that hang on the wall. They're incorporated in the boiler itself, so you don't have to put an external one in. But in some cases, you may run across a flow switch that is in the piping, and that what that does is just determines that the circulation system is working. In other words, the pump is operating, and it is maintaining a flow through the boiler system. So this here, again, like the aquastats and the thermostats, has to be in a position where where it is in direct contact with the flow of water. So on the bottom of this point here, there's a little stainless steel paddle that goes on, and there's an assortment of paddles that you get when you buy these. This is a McDonnell and Miller flow switch, very common, always on commercial. Any boiler over 250,000 BTUs requires a flow switch, but you don't deal with that in residential. So you put this little stainless steel panel on, make sure it's the right size so it fits it in, and just so it's inside the piping, so that when the water flows, it just moves. Oops, sorry. Where am I here? Oh, where did I go? So it just moves this paddle just a little bit, and it'll close a contact up here, which tells the rest of the system, yes, we've got flow in boilers. The boiler is operating as normal. If the circuit pump shuts down, if it breaks down or something happens, the power to it is interrupted. This will just go down to the straight position, which means no flow, and it will not allow the boiler to fire up. And that's as straightforward as that gets. I showed you briefly stack dampers. This you will run into in a lot of boilers well, some of them are still in existence, that are considered a class 1 category 1 boiler, but have a bit of a higher efficiency rating. And the reason why is because at one time they said, okay, you're not going to make a boiler that doesn't have at least 81 or 82% efficiency, because most boilers are running at anywhere between 75 and and 80%, and that's when they come out of the factory. As they got older and got more dirty, the efficiencies were down. I've tested boilers that were only running at like 68%, 65% efficiency. But we'll go, that's a whole different story. And that's basically because the inside of the boiler is now starting to coat up with stuff similar to, and that acts as an insulation. So you're not getting a good heat transfer. That's reflected by very high temperature stack temperatures. And that's a thing that you check to see what your stack temperature is. How hot is the flue gases coming out of this boiler? And if they start running up around 350 to 400 degrees, that means there's way too much heat going up this chimney. It's not transferring. The boiler is starting to plug up with, the inside of the boiler is starting to plug up with minerals and stuff, and you can flush them out, things like that. Anyway,
There's a couple of questions, Vern. Do
yeah.
boilers utilize anodes, and can you have stack dampers on boilers with a standing pilot?
I'm going to say no. I've never run into a boiler that had an anode in it, because just basically because of the design of the heat transfer, the heat the exchanger itself. Most of them don't have. They're not like a big tank, like a hot water tank is, where you can stick the anode in. And like I said, again, because you have a lot of water running through it. Here's the one nice thing about having a closed system in a boiler is the fact that once this boiler is filled with water, right? That water, now the oxygen in that water now starts to be absorbed by the rest of the system. So what happens is eventually there's no oxygen in the water at all. If there's no oxygen in the water, it's not going to corrode anything, because that's what you need for corrosion. You need oxygen, right? So they don't put anodes in boilers. And I don't think I've ever run into an anode in any tankless units, because again, they're made out of materials that are highly adverse to corrosion. Generally stainless steel, right? Stainless steel, so it's not going to corrode that much due to minerals in the water, not like a steel tank. And the vent dampers, yes, these vent dampers will be found on boilers that have standing pilots still, because at that time, the standing pilot, they may have manufactured a boiler that had a standing pilot and added these stack dampers on. Now, here's the reasoning behind the purpose of the stack damper, right? So what happens is that when the boiler shuts or turns on, there's a damper that goes right across the pipe. In other words, it closes it down, right? Big steel round damper inside. That damper opens up, so it just goes into like a butterfly position. And once it's open, there's a little switch in here that clicks, sends the signal down to the boiler saying, okay, I'm on, proceed, right? Now, when the boiler shuts off again, this stack damper closes. So guess what? We're going to save X amount of percentage of energy, because now we don't have all this heat that's coming from the build of the water, or the heat that's built up in the boiler. Even after it shuts off, it's going to sit there. So it's not going up the chimney through the natural draft, right? So we can save ourselves 2% energy. And that was the reasoning behind it. And you'll actually run into these in some furnaces too. Pneumatic Olson had a system with a stack damper. A lot of these stack dampers just can't quit. They because they're in a place where there's a lot of heat, and the heat's even transferred to this area here. So these things would fail prematurely. They might last 3 or 4 years. So rather than replace them, what people did was just basically wire them open and then bypass the switch so that this no longer opens and closes, right? So that's a stack damper. You will run into that if it's still in operation. You'll hear it. It'll go. The first thing that'll happen is you'll hear a click, and you'll hear a wee. This will open. You'll hear another click, and that'll initiate the heat sequence on the boiler. Electric boilers you will run into in quite a few places that may not have natural gas, or in places where it's not feasible to put a natural gas or a fuel-fired boiler in. Sometimes you'll run into that. Electric boilers are fine, expensive because you know the price of electricity, but one of the things about these is all they are really is they're just like, if you took the covers off of this, all you'll see is a whole bank of immersion elements, similar to what you have in electric hot water tanks, right? But you'll have a series of them, and so they'll be banked. You'll have like, depending on the size, say if it's a 10 kilowatt boiler, for example, which would be a normal size to supply a regular sized house with hot water, 10 kilowatts of heat. It may have 4 different banks in it, and which means there could be 10 or 12 elements, right? Each bank would be what they call a stage. So we'll use 12 kilowatts because it'll make it easier for me to do the math. So if it was 12 kilowatts and it had 3 stages, that means each of these stages would be 4 kilowatts, right? So it might have two 2,000 watt elements in it. So when there's a call for heat, bang, instead of all of this coming on at once, one stage would come on, and that would start the heat, right? You'd have like 4 kilowatts of heat starting up at the boiler system. Then after a number of seconds, they have what they call sequencers. After a certain period of time, the next stage comes on, right? As long as there's a call for heat, the next stage comes on. So now you've got 8 kilowatts of heat. And then finally, after a certain point, your last stage comes on. Now you've got the thing running at full capacity, 12 kilowatts of heat. So this thing's heating away. This is like a hot water heater in a smaller space, and so you really have to have water going through this. This is where you'll find flow switches for sure, no matter where they're situated, because there's so little water in here. You may only have this may only have a capacity of 5 gallons to 8 gallons of water in it, right? So if you had 12 kilowatts of power heating up that, it's not going to take long to make that water boil and then eventually turn into steam if you don't have water flowing through it. The reason why you stage this is if all this came on at once in one big bang, just think what it's going to do, what kind of havoc it raises on your electrical system, right? You need a breaker that's going to have to handle that power, because as soon as things go on, you get that surge, right? Yeah, would normally run at say 780 amps, for example. When it first comes on, if it all came on at once, it would spike up to maybe 120. You get those spikes, that means that 100 amp breaker may trip by accident, right? So that's the thinking behind that. And that goes in part parcel with electric furnaces too. Electric furnaces are staged, so they have elements. They have what they call element banks, and those elements will come on at certain times. Your first element might be 2,000 watts. Then your next element, another 2,000. It's quite common for most furnaces to have 4 banks of elements in it. So in other words, all these will come on at different times, provided there's still a call for heat, right? You will run into also heat exchangers. Now, these are really popular in systems that are incorporating hot water with and taking the hot water from the boiler and using that water to heat up other things. This could be going to a slab heat unit. This could be going to a hot water tank to preheat the hot water going into a domestic hot water tank, because these are sealed, like you see here. This here would be, say, coming from the boiler. This water that goes through here goes through the plate systems, but it's not mixed with this water coming here. They're like like an HRV coil. The air coil's coming in. You've got air going through one way, and you got air coming out another, but they're not mixing together. Their heat's being transferred through a medium, a plate, right? And they actually work quite good. It's amazing. You can get a small plate that can really give you a lot of water. So these systems you may find that then and they get used for putting in for preheating water going to a hot water tank. If you had a big enough system, they will not probably. You would need a fairly big heat transfer plate to provide hot water to the house without a storage tank and without an alternate means of heating your hot water. You will also find these going to radiant heat systems in cases on the older systems where they didn't want to tie in domestic hot or the hot water from a boiler going into a heating pipe in the floor for certain reasons, then you would find that there. So this is a heat exchanger, right? If the boiler is operating, you can pretty much tell if this is working. If whatever is this is if there's hot if this is heating up also. These pipes heat up. That's telling you got hot water going through here. It's transferring. Not much goes wrong with them. They're made out of stainless and they seem to work forever. Is there anything else I wanted to talk to there? No. Okay. The system piping. Now, it may not be uncommon for you to walk into a mechanical room and it'll look like this because you're seeing more and more of this stuff going on these days. And people are spending a lot of money on the initial costs of systems in their house that's going to provide them with a lifetime of comfort, I guess you could say. Also, the fact that uh, if if you have a house like this, obviously resale value is going to be is going to be much more attractive, and resale is going to be attractive when you see setups like this, other than some of the other ones that we've seen earlier, right? They look complicated, and they are. Okay, so don't be too frightened because uh, there's a lot of things that you have to look. Every system might be different. There's a lot of things that you have to look at, but basically they all have the same type of components, right? Has the expansion tank. This is actually the boiler that's being used. This boiler is a combination unit, which because I can see four pipes coming in. Two of them are going to domestic hot water, which actually, believe it or not, this unit has one of these inside of it, and that's how it's providing domestic hot water through transfer that without mixing with the boiler water. This is the boiler water feeds right here. Um, so of course the boiler water is going to have the same thing. You've got pumps. These are sensors that you're going to run into. It's not like things that I would expect a person to be to 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 be very knowledgeable about, but you definitely want to have the basics on it. You want to know that, okay, so this system here is going to this. This got to be the, uh, the hot water tank in a sense. So basically, this is the water tank, the hot water. So this works off of an indirect hot water system. So there's a coil in here also. I can see the piping is going from here, comes in here. So this water is circulating through here, and you've got hot and cold water coming in, probably at this point and out that point. And so you have a hot water tank without needing a means of a backup, without needing a gas hot water heater or another electric hot water tank. This thing is self-sustaining. They're very nice, very nice, very efficient, but very expensive to put in. So those are things you're going to want to see. Even though this is such a nice system, I see a pressure relief valve here with a violation right there. there's your outlet from the relief valve. What happens if that relief valve goes on and you're standing here? That thing's going to spray all over and scald you. This valve still has to go down to floor level, right? So even in an elaborate system like this, you still may find an infraction, right? Here's your circ pumps. This has got a pressure tank, so we know that this building is on a rural water system, and I'm going to assume it's somebody's cottage, because only cottage people who build $3 million cottages will be able to afford this sort of setup. These here are all your slab pipe heating system, your radiant pipes. These are your pipes going into the slab. You've got a return manifold and a supply manifold. So you've got two manifolds. So this valve or this manifold here would go, the water would go down here and probably come back here, right? There, the way it's all tied in. So you've got water flowing through each system. This isn't a real good picture, but right here are your thermostatic valve controls. So on this setup, instead of having one of those zone valves that we looked at, those big bulky things, these are actually incorporated in the system itself. And these are actually the thermostat controls. Again, they can have the same type of wiring configuration that will send a switch or a signal to another component that says, yeah, there's a call for heat, activate me, right? So these are this, I'm going to probably assume are is an opener system, because those are the type of zone valves. They call them telstats that are used. Quick note about heat emission units, or the way to get rid of your heat that is in a hot water heating system. And the old, one of the big old style ones are your baseboards, right? These are commonplace for houses that have been built right from the 60s until even today. You know, they may look a little better now, but the same thing. What they have is a heat a finned tube unit going through, and as the water goes through there, you're depending on convection or the air, because warm air rises, right? So your cooler air comes in the bottom, and then it goes through these fins and it comes out the top. And these are little baffles here on the top. You can open and close them, sort of controls the amount of heat that comes out of that in this case. And here's a picture of something that you might run into somebody's basement. They've tied in one of these fin units to provide a little bit of heating in an area that might be cooler than normal. Looks like this could be part of a crawl space that doesn't get much heat. They're not real efficient. They will be better than nothing at all. Those are just things that you may come across. So those are your convection, your baseboard fin heaters. We don't have to talk about cast iron radiators, because you know what they look like. And yes, they are still on some systems, but most of those would be going things that went back to the pre-60s, when men were men, and you could actually carry one of those up to the upper floor on your back. Fan coil units. This is another thing that you may run into. This one here is tied in conjunction. There is a furnace here, but this is being powered by water, hot water. This part here, portion here, would be, for example, if you wanted to heat a garage, right? And this is in a mechanical room, but you can't run your furnace ductwork into a garage if it's serving the rest of the house. It cannot be in the same system. You know what I mean? It's because, for example, what happens in garages? Cars start. What do you get in garages? You get carbon monoxide. You get products of your whatever comes out your tailpipe of that car can be in the garage. And yeah, it can happen, eh? Even if the doors are open, you're still going to get a buildup. Well, could you imagine if you had ductwork going in there and that gas seeped through the ductwork into your house? That's a no-no. So a lot of times what they'll do is they'll put a separate air handler in, which will put some air or heated air into the garage itself. So what you use is a coil. So there's hot water. It's basically like an air conditioner, only it's the other way around. You got hot water going through a coil. That air is blows through the coil, and then is transferred to the duct into the garage. We're going to call it the garage, just for sake of clarity. And there you got hot water. This here would be coming from a boiler, or in some cases they may have used it. Now let's just say a boiler. Okay, there's other cases. That's something you may run into, or you may have a boiler that will have multiple air handlers, where you'll have an air handler in a house that will give you hot water and also provide you with air conditioning later. Because one of the problems with hot water heating is, how do you air condition a house with hot water heating when you don't have any ductwork? You can't cool water off to cool the house off, because that doesn't work. Trust me. What happens is your water starts to your cold water goes to a point where it hits the dew point and it starts to condense, so you get water dripping from anything that has cold water through it, right? Okay.
It's
The indirect
12 o'clock, Vern, so we'll take that half-hour break.
Okay, yeah, and then we'll just start on inspection process. All right.
Sure, you betcha. Yep. So we'll see you guys in half an hour. And again, if you have any questions in the meantime, do put them in the chat and we'll address them when we come back.
Okay, great. We're gonna try to get through this relatively quickly, relatively smoothly, and I'd like to just let you know that we're very open to questions, because generally, if you have a question, you're not the only one that has the same question. That it's just a matter of, that's just the way it is. So if you have questions, send them to let Alex know or whatever, and we'll carry on with how everything how with the best. We'll give you the best knowledge that we can. That's all we can say, right? All right. Are we all good here, Alex?
Let's give them 2 more minutes just in case we got some stragglers.
Oh, the stragglers. Always with the stragglers, eh? Oh, well.
In about a minute, you'll be good to go. Like I said, we are recording these in case someone does miss the first little bit here, but in about a minute, you'll be good.
Oh, yeah. Good. Well, I don't expect I'll see it on TikTok.
Nope.
Nope. Anyway, we're in for a warm weekend now. Things have warmed up here nicely. That's a good sign, because I intend on getting outside tomorrow for a bit. My son has his 2 daughters for the weekend, so generally when that happens, we'll get together and go tobogganing or something. They're 7 years old twins, handful, let me tell you.
You can go ahead and start, Vern.
All right, so we're going to deal with some notes on inspections. A lot of this stuff we've already covered, so we're going to go through this fairly quickly. And now we're talking about the appliance itself here. Again, we're going to look for any type of abnormalities, scorched surfaces, wiring, anything like that. Definitely want to take a note of. We're going to talk more about venting and stuff very shortly. So we've already discussed most of the parts of a boiler and a furnace, so I don't think we have to elaborate on here. Again, like I said, if you do have questions, please feel free to ask. This is the time to do it. We're going to talk briefly about oil furnaces, because I know that you will run into this in some rural areas, and there's some different things that you have to deal with when it comes to dealing with oil. And I don't expect that you're going to be as well versed on this as you are in natural gas and gas burning appliances, but give you the calls and notes on it, what you should be looking for and stuff like that. when you open up a furnace, an oil furnace, it has usually the same thing. They have an upper compartment and the lower compartment. Lower compartment is generally where the blower is on most of the upright furnaces. So the filter would come in, the return air and the filter rack would come in the side. You still got the warm air plenum up top and going out to the ductwork system. But when you open it up, you're going to see something a little different than you would in a gas furnace. And this unit here is called the burner. That is a burner gun. Generally, they're made by Backhead or Arrow or whatever. The only thing you can really do with anything like this is if you fire it up, there'll be a little inspection port right here, and I'll give you a chance to see if it is indeed flamed up, or if it is burning, and you won't be able to tell much about the flame itself because this is all going on in a closed situation. And again, the thing that you may want to watch when you're dealing with an oil furnace is when it first fires up. If do you get this poof, like a smell or a puff of smoke coming out of the barometric damper, which we'll talk about in a minute. Things like that. Does it sound like it fired properly? Usually they're fairly quiet. They're noisier than gas, but they're not gonna have these explosive sounds coming from them. Not normally. You'll see little spots that are stainless steel caps. Those are clean out ports. We're not touching them. Has a limit switch, things like that. And then the flue pipe, the chimney pipe, will generally come out in this area, and that's usually or almost always you'll find it'll be a black metal piping, single wall, and that's a very thick stovepipe type piping. And that there, all you wanted to do with that is to make sure that it looks secure, like the joints are all put together properly and screwed, and that there's no signs of corrosion on that, because these will show you a lot of corrosion if the flue gas temperatures or if there's some problems with the way the operation of the furnace itself. So like I said, it has a barometric draft damper, and this here is a picture of the inside of, if you took the flapper off, which you can, but you're not going to. I'll tell you that right now. But you can always open it up enough just to look inside, and if you see a lot of this in there, then you know that furnace has been burning dirty, because this is creosote. This is flammable, by the way. This is the stuff that causes chimney fires, causes all kinds of things, because this gets to a certain temperature. It's like coal. It'll ignite, and then it's gonna go. It's gonna burn, right? And like I said, in chimney fires, this is the biggest cause of creosote's built up, and it's finally got to the point where it's ignited. And this stuff, once it starts burning, it is very difficult to put out. Any excessive soot has to be noted. And also, just as a side note, when you're looking at this barometric damper, I know that's not a good picture of it, but it's got a flapper on it, and it's got a little weight, so it usually is sitting about like that. And then when it fires up, it'll open up, because what it's doing is it's actually bringing air from the inside of the room, mixing with the products of combustion from the furnace and going up the chimney. Basically the same principle as what a draft hood does on a Category 1 furnace, right? So you can just make note of when the furnace is operating, is this damper moving freely, like it's not just stuck in one position, because that's an indication of a problem. If it is stuck, then it needs to be either replaced, or maybe there's a lot of dirt in there and it's keeping it from operating properly. So that's one thing you would notice. Some of the oil-fired equipment, instead of using a chimney, they use a power venter. Again, another term that is sort of loosely used in the trade, but this venter is what it's for. Is it specifically takes out the gases instead of using a chimney and going up to the roof, the flue gases from the furnace go into what they call a power venter or a turbulent ejector, sidewall ejector, they call them, some of them. And it just forces the air or the flue gases out, and it'll come out outside on the outside of the building. If you see a square box on the outside of building, this is all stainless steel, has a little square damper, and then there's a space around here like that. That would tell you that the working components are all on the inside. In other words, the motor and all that stuff is all sitting inside the building, which would be very close to the furnace or oil boiler itself, right? Because oil boilers can also be put into this. That is that's just something to take note of. And the way that these are made is that if this fan doesn't work, it also has an air proofing switch in it. If this is not providing adequate airflow for the proper ventilation, it will not let the oil-fired piece of equipment ignite. It will not let it run. You may run into one like this. That means this is usually the motor and everything's on the outside. These are very finicky because when you get really cold temperatures, they have a habit of freezing up. Not so much the motor, but because of all the frost conditions, there's certain things in here that are supposed to be sensing the air. These freeze up. This, to me, these are problems. There's a couple of different manufacturers. Field is one of them. Had all kinds of problems with these type of units. They're not they're definitely not the high tech, reliable source of equipment that you really could use. But if you don't put a chimney in, you don't have any choices. Because you have an oil-fired equipment, you're going to need some type of a storage system for your fuel, right? We'll go through this relatively quickly, just so you're aware of it when you run into it. And basically, you have an oil storage tank. Most systems are a one-pipe system, which means your oil, the oil coming from your tank goes to the burner via one piece of pipe, which we'll talk a little bit more about in the next slide. Any of the piping that you see has to be supported properly and protected from physical damage. A lot of systems, this one is showing a tank inside of a house or inside of a building, could be in the basement. A lot of older systems, a lot of people put the oil tanks in the basements. Most of the time on any houses that are relatively new, oil tanks outside, because insurance companies do not want to see an oil tank inside of a house. There are some advantages to having the tank in the house, and if you have the room. One is the fact that your oil, the oil in your tank will be at room temperature, so it is a little bit more efficient than oil that's sitting outside when it's -20. The other thing too is that you're not looking at an ugly oil tank beside your house. But then again, that's life, right? Some people build little things around it so you don't see it. Okay. So here's a typical design. This is in an older house again, I can tell, of oil tank inside the basement. And you'll have two pipes coming up and they'll go outside. One pipe is the fill pipe, which is the bigger one. The other pipe is what they call a vent pipe. These pipes, if you see them, have to be metal. They've got to be made out of black iron or steel. They can't be plastic, they can't be copper, or anything else. They have to be metal. And they have to have threaded joints. Okay. One of the things that you may run into, or you will see also, is on a tank, and this isn't a real good picture because it's small. Right here at the center of the tank, there's a little clear plastic cylinder coming up, sort of like a cover, sticks up about 4 inches or so. That's your tank gauge. That actually tells you what the level of fuel is inside the tank, because otherwise you don't really know exactly what the level is. If you run into this, and you will run into this on oil tanks, whether they're in a house or outside, you want to make sure that it's not broken or that the plastic hasn't been taken off, because that will affect, you can get water going into the tank, and water and oil do not mix, right? So that's something that you want to see that is in place. And that's kind of all the accessories that you're going to see at that point. Uh, the storage tanks themselves, a lot of some of the older ones are still single wall tanks. That means they only have they're steel, and that's it, one wall, just like a big barrel, right? These are now becoming obsolete because most insurance companies or uh, oil companies will not deliver oil to a person who has a single wall tank, just because they're prone to leakage. We'll go on a little bit more about that. So there are a number of companies that make double wall tanks. This is what you'll usually see. And what that basically is that if there is a leakage in the existing tank, it's like a single wall tank stuck inside of another wall, inside of another tank. So if there is any type of leakage that occurs in this tank, it'll be collected in here instead of running on the ground, right? Or in your basement. Very nasty stuff happens when you lose oil in either spot. Trust me, it's terrible. And you may run into an oil tank that's installed horizontally. That is approved, provided all these that it was made that way from the factory, and that you have all the necessary ports on top to be able to monitor the fuel level and fill it and be able to vent the tank. All right, so you'll have on the tank the stub outs that come out. The larger one, the one that's about 2.5 inches in diameter, it's 2-inch pipe, will have a fill cap. Now, it could be a locking cap, but it has to be screwed on, and it has to be able to close, because you don't want any, and a lot of people lock it, depends what kind of neighborhood you live in, but you don't want to have any contaminants going into the system through the fuel tank, or through the fuel fill port, the cap. This here on the pipe beside it, which would be about 6 inches away from this tank, or this fill cap, is the vent cap. This is a smaller diameter pipe, and it'll have a cap on it, but it doesn't screw on, because the purpose of it is to vent any buildup of pressure or whatever gases that are in the oil in the tank itself, to give it a place to safely vent, into atmosphere. You shouldn't usually get any odors out of it. So rather than threading it on, it's just placed on, and then it's locked into place with the thumb screw, right? And this vent pipe, though it's not shown here, is generally extends up and above the level of the fill tank. Now, here's the other important part about this little setup, because on all oil tanks, you need some kind of a mechanism installed so that the person who's delivering fuel knows how much fuel is going into the tank, right? I mean, they can look at their meter on the truck or whatever, but that's not going to tell them how much fuel was in the tank to start with. So what they do is they put in a vent whistle, which is this item right here. That screws into the tank, so that vent pipe that I was talking about earlier comes out of there. It's got a vent cap on it. And what happens is while the tank is being filled, a certain amount of air is being displaced out of the tank, because you're putting liquid in the tank. You got to get rid of the air in it. So it's coming out the vent cap, out through the vent piping. So it goes through this tube, and it actually whistles. It makes a whistling sound like that. And as the air is getting closer to the level of this tube will stick down to about 6 inches into the tank. As it's getting closer to the level of the tube, the air is starting to increase as it comes out, so the whistle actually gets higher pitched. And then when it eventually hits that level, it's going to stop altogether. So that's when the delivery person knows, okay, that tank is just about full, right? Because you can't trust these gauges all the time. Yeah, half of them are broke. It may be broken. It may not work at all. Anyway, so that's important. This needs a vent whistle, needs a gauge. You got to have a top on top of it. Outside of the tank, if it's inside the house, there'll be a filter right in the right where it comes off the bottom of the tank, because all out ports on the oil tanks come out the bottom now. And this basically is just a felt filter cartridge inside, and the oil goes through in through the filter and back out. Just keeps the oil, any of the contaminants, because you're going to get stuff that collects on the bottom of the tank from getting into the oil piping, and then to the burner, the burner itself. Because if you get dirt in that, it'll clog up the burner nozzle. They're very, very small in diameter, so it doesn't take much. So it's really important to note this, whether you see it inside the house. If the tank is outside, some installations will have the oil filter outside. Some of them will have the oil filter inside, because inside it's nice, easier to service, easier to get at, right? Either way, you need some type of a valve on it so you can shut the oil off, so you can change this. This filter has to be changed from time to time. Check this area. This is usually where, if you get any type of leakage at all, it's around a filter, a valve, or a joint, right? So again, that's one of the things you want to keep an eye on. If you have any concerns regarding the oil part of this your heating inspection, make a recommendation that they have a licensed contractor assess the equipment. That's all I can say, because it is a special license to do this. Not all not all plumbing and heating companies even have oil burner mechanics, right? I mean, if they don't do the work, most oil burner mechanic is basically a separate trade all itself. It's like either you're a gas fitter, and then you can be an oil fitter. I have an oil ticket. I got that back in like the early 80s, when things were a little easier to get back then. And I have done oil work, and it's not one of my favorite things. So this is the oil heating. There'll be a tag on the tank itself somewhere. You may have to do a little searching on the single wall tanks that are, or the double wall tanks even, that stand up. They're generally on one side or the other, usually the side away from where the fill valve goes out. There'll be a tag, and that tag is important, because if that tag's not there, there is no way of telling the age of the tank, or any of the particulars. Is it an approved tank? So that's one thing you want to look at. Here's the good news about oil. The fact is that if this system isn't up to snuff, the oil tank, etc., oil companies will not deliver oil to that tank. Period. They cannot. It's just against the law. So if this tank has been regularly filled by Esso Oil or Shell or Blue Wave or whatever they call themselves, then you know pretty well that the tank itself meets the standards. Doesn't mean everything inside does, but the tank does, right? So that might be one thing you'll want to follow up is, and usually the mortgage a mortgage company will ask for heating bills, right? They want to know how much it costs to heat the house. So the only way you gauge that is by how much fuel has been delivered to it. So if they get fuel bills from Esso, you know that your certificate, the equipment's been certified. You're okay with that. If the guy's been putting oil in himself because he has an uncertified tank, that is a very big cause of concern, and it does happen, believe it or not. So just make sure you have notes of any of the any oil equipment, because some people just don't know what they're getting themselves into when they get into a situation like that when you have oil fired equipment. We're going to move on to clearance to combustibles. This is going to be pretty well. This is pretty well standard, whether it's propane, natural gas, or oil. Well, let's not say oil, okay? Because oil is a whole different matter. We're just going to stick with gas and propane. They follow the same venting rules and requirements. So we have talked about clearance to combustibles. This is a very important part of your inspection. Try to see as much as you can as far as how the venting goes from a furnace, especially your category 1 furnaces, because obviously they're going to use a chimney of some type. Sometimes you may have a category 4 furnace, but you still have a natural draft gas hot water heater, right? So the gas hot water heater is still got to be, is still going to, has to still follow the same rules as a category 1 unit, which means it's going to have a chimney of some type. Clearances are important, right? So you may want to take a look and see, you may come across a label like this. This is a B vent, which means it's double wall. B vent is a double wall. It has a steel outside jacket and usually a stainless steel inside jacket, right? So there's a space in between these two walls, probably about half an inch. And that basically what it does is that the gases that go up on the inner tube, as you want to call it, are going to have a chance to be cooled a little bit because of the air gap. So if you have 250-degree temperature flue gases going up the inner part of this, the outer part of the B vent will be warm, but it won't be even close to 250 degrees. Usually it might get up to 100, maybe it'll be warm to touch, right? Not super hot though. So that's a B vent. This is the type of venting that, the only type of venting that's approved to go into concealed spots up through your your house, up through the attic and into out the roof is a B vent. You can't use C vent. No, I'll explain that in a second. So anyway, the clearances to combustibles are also pertain to the appliance itself, because any furnace or boiler, hot water heater, etc., that is gas fired has to have a plate on it that tells you what the clearances are to a combustible surface, right? And that can be on the data plate. Sometimes they're on a separate plate too. But as a rule of thumb, many furnace manufacturers require a minimum service of 24 inches of clearance from any top, side, or bottom where service could be necessary. Actually, more if you have to access a blower, you need to have at least 36 inches in front of the furnace. You have to have enough room to be able to get down there and pull things out if you have to, right? So that's one of the things. If you have a furnace that's installed and it's only like 18 or 20 inches away from a wall from the side that you're accessing it from, that's not going to meet the code standards. So you have to make a note of that. On the sides, some furnaces are rated to be 10 or 12 inches away from a combustible material on the sides. The top, you don't recommend anything combustible above a furnace. You're going to have, that area is going to be taken up with ductwork and your venting anyway. All right. Now that's with that. When we start going to the venting part of it, which means the flue gases for your category 1 type furnaces, 1 inch clearance is your rule of thumb for most B vent connectors. That's a double wall type. You need 1 inch clearance from any type of a combustible, which includes where it goes through the floor, because they have to have a special floor plate that goes on before it goes like from your basement to the next floor. So that's got to be cut away. There's got to be enough room there away from the plywood or whatever you have for flooring that it'll be the clearance is maintained. So you got 1 inch clearance. That's a rule of thumb from any combustible for your double wall vent, B vent. If you have a C vent, which is the aluminum piping that comes right off the hot water heater or a furnace and then runs over and connects to a base T, those are single wall. You definitely need 6 inches at the very least for clearances for a clearance against away from any combustible. All right. If you see an instance where you have a C vent or a single wall vent running towards to the B vent base T, and it's running close to say a floor joist or maybe a beam, a wooden beam, because you run into those often, and it's not within 6 inches, but somebody's put a little aluminum plate there. That doesn't really qualify as as appropriate to make up for not having a clearance. You want to make a note of that. All right. It's just that a lot of old places got grandfathered in that way. So those are things you want to know. You want to make sure that your clearances are good. In most areas, the venting is going to be behind walls. You're not going to see anything that's in a chase going up from your basement up into your attic. There's not that many things that you can do about that. But if part of your inspection is to poke your head up through the attic, you definitely want to take a look at if you have a B vent going through for a chimney, you want to take a look and see where that B vent is. And in most cases, you'll see a pipe like this. It's called insulation shield. That'll be mounted. That'll be on the base of the floor, or the floor of the attic, I guess you want to say. Again, the clearances will be made inside to keep the B vent from going near anything combustible where it goes through the ceiling of the level below. And the reason why you have a space like that is, and up this high, it's usually up about 18 inches or so, is that if when you insulate, then you don't have any insulation products going right up against the B vent, right? Just basically a safety thing. Most insulation products are not very flammable, and it would take a whole lot for them to burn. Usually by the time they start on fire, you got more problems than that. But all the same, you can get the blown insulation, stuff like that would go up against it. You don't want to have that happen. So if you see insulation, and there's a picture I think coming up, yeah, right here, for example, you got a real mess here, right? You got insulation, you got stuff coming up. This is all up against. This is going through another level. Looks like there's insulation there. This is not maintaining any type of proper clearance at all. And I have no idea why they have insulation up there, because I'm thinking it's going through the roof. But somebody's probably thinking, well, maybe we'll put insulation there because we're getting lots of melting going on up on top, and we're getting ice building up on our roof from our venting. That's not the way to do it, right? So those are things you want to know. Any type of obstructions, anything. Here's a piece of PEX pipe that's been run along a B vent, and yes, it's not going to. It probably won't catch fire, but it definitely is a code infraction. You don't want to take any chances like that. So you have to make a note that you have a piece of PEX pipe running right up against the B vent itself. And you can see here, actually, this is an example. Here's your C vent, your aluminum coming from your hot water heater, I would assume, because it looks like it's 4-inch, and it ties into a factory type T made by the same company that makes the chimney, and it ties into there, and then it's handled from there. So this would be a base key. This type of chimney is made by Echo. I can just tell by that little decal there. So C vent, okay. Generally, you want to use a proper vent connector to go from C vent to B vent. This is for all gas appliances, or a factory type T like this that is made specifically for this aluminum pipe to go into the B vent. All right. More into venting. This is important. When a chimney passes through the roof, there is specific clause in the gas code as to how it terminates, as they call it, the chimney termination or the vent termination, how it terminates, because outside forces can cause problems that you may not realize when you're inside of a house. and one of them is air movement, right? If you get wind coming across from that's coming across from this direction, when it hits the peak of the roof, there's going to be some turbulence, right? I mean, it's hitting an obstruction. So when you get this turbulence, you get a spinning action going on like that. And when that happens, if you have an appliance that's running at the time, and and it's, you've got steam or water vapor, you know it when it's coming out because you can see the smoke or the steam or whatever you want to call it coming out. Well, you get that occurrence if this chimney cap or your termination is too low at that point. What's going to happen is this air swirling around will affect the performance of the way that this is drafting out. Remember, this is natural draft. You don't have anything about, you're depending on nature to provide the venting for this to get outside, right? So that's why this picture here actually shows a vent that is too low. They have specific rules on the heights, right? So this pipes on as a rule of thumb should be not less than 3 feet where they come out. So from the high point, so from this point here to the chimney cap should be at least 3 feet. Looking at this, I would judge this to be not more than 18 inches. All right. So it has to be at least 3 feet up from the high point. One of the things you're going to look at when you're outside, you're going to check. Has it got a chimney? Okay, what height is it at? Is it 3 feet minimum? Yes. All right, that's one thing. But it also has to be 2 feet higher than any portion of the building within a horizontal distance of 10 feet. So if this was 3 feet high, and yet if you look from this point to this point here, if you drew an imaginary horizontal line from the peak of the roof to where the chimney cap comes, and you see that it's still it's 3 feet higher than this, but it's only at the same level as this, and we're not more than 10 feet away. That means this thing's still too low. This thing's got to go up another 2 feet. So it should be sitting right up here, right? Those are the things that you want to observe, right? Again, if you have a chance, you take a picture of it. Really, the only way to get a good look is if you have a ladder and you can actually, you don't have to get up on a roof, but at least from that point, you have a better idea what your horizontal view is. But after a while, you get the hang of it. You'll know pretty well. Oh yeah, that chimney looks low, man. If you see a lot of corrosion up here, and there's a lot of rust, that's another indication that your flue gases are cooling off too much, so you're getting condensation building up here instead of it just finally drifting off into the air. You're getting too much water vapor condensing at this point, and it's rusting the chimney cap, which also means it's going to be rusting the inside of your B vent, right? This would be another situation that you might run into where your chimney has to come up alongside of a horizontal wall. Again, it has to be 2 feet higher than anything at the highest point horizontal within 10 feet. Okay, these are important things to remember. You might want to have a little notebook when you do your inspections just to remember it all. I'm sure you will.
You can go back one slide, Vern. I'll just clarify
Yeah.
guys something. So clause B 814.4 from 149, that's the natural gas and propane installation code. That first highlighted section, 3 feet, that's for a chimney, as it says there. So there is a difference between a chimney and a vent. So your vent is your B vent. That's what you're seeing in that bottom image. And that is the 2 foot tent. That's the having to protrude through the roof line 2 feet higher. The 3 foot rule, that is for a chimney. So that's a masonry chimney, or again, a factory built chimney like we spoke about with Chris a few days ago. So that's a distinction, right? Your vent, that's your B vent there, only needs to be 2 feet. But if it's a chimney, a masonry chimney, then it has to be 3 feet. Again, if it's a factory built chimney as well, for a wood burning appliance, that needs to be 3 feet as well. But again, that's a wet thing you guys don't need to worry about.
Oh, so you're talking about this point here?
Correct. Yeah, that's for a chimney. So a masonry
Right.
chimney or a factory built chimney for a wood burning appliance. And then, yeah, the second point, that's for your vent. That's your B vent.
Right. But on the same, talking the same point, you still have to be 2 feet higher than any point
Absolutely.
10 feet of this, right?
Absolutely. You bet.
Yeah, so this still is too low.
Absolutely.
If
Yeah,
you
you
had a
bet.
really low slope roof, yeah, this wouldn't have to extend that far up. Okay, yeah, I, I can understand that. You don't want them too high, but you want them to be sufficient length that you're not going to be affected by the backdrafting of wind blowing through the over top of the roof. Um, the way that the way that the chimneys or the B vents are supported uh, is a matter of concern also, because if you don't have proper supports to hold the chimney or the B vent, I'll call it chimney, all right, uh, up, then what is actually holding this in place, right? So most manufacturers make a start box, it's called. I don't have a picture of it, too bad, but it's basically a metal box that will fit in between two joist spaces, provides the clearance from combustibles, and a section of B vent chimney will sit in that box and protrude down, so you can still put a key on the bottom, and it's well supported because this box is nailed or screwed in to properly in between the joists, or you might have a wooden box that was put in like 2x4 2x6s to support it. So you have to make sure it's well supported. If there's any indications that it isn't, make a note of that.
There's a question, Vern. Distance from other vents or chimneys. So I think that's a bit of a loaded question. It really depends on the type of vent. So if we're talking, a masonry chimney, wood burning appliances, that's a wet thing. I believe, and correct me if I'm wrong, Vern, but exhaust for your B vent, I don't think there is a requirement because they are exhaust. Now, if you're talking a special system, special venting system like your 636, IPEX generally, they will have their specific recommendations, right? And you can actually download their manuals from their site, because it really depends on if it's a sidewall termination or roof termination. And again, it really does also depend on the manufacturer as well. But by all means, Vern, if you want to speak to that, you can.
Yeah, exactly. Well, if you're talking about B vent chimneys coming through a roof, I don't usually see them spaced more than or less than 2 feet apart. Though, like for example, if you have a duplex and you've got your systems are reversed on each side, so you have a furnace room on this side of the duplex and a furnace room on this side of the duplex, two chimneys coming up. You generally will come up about 4 feet, maybe 5 feet apart at the roof level. I'm not quite certain what the code is on distances between B vent chimneys extending through a roof, but when you're dealing with a B vent chimney and any other type of device that may have air either coming in or going out other than another B vent chimney, you got to be very careful on what you're looking at. If you have, for example, a roof jack for a bathroom exhaust fan, there's probably a clearance. Uh, there's a minimum clearance that's required between the two, and if it's and definitely if there's any type of air intake, you want to have there's specific dimensions that will discuss the clearances between an air intake and an exhaust, right? And I actually have a slide on that in a minute. Can be a bit confusing. I'm gonna be honest with you. One of the most confusing parts of the gas fitting trade, and one of the hardest parts for uh, people who are training to become gas fitters to get a real grip on, is the venting issues. The venting is just it is a combination of like, okay, if this happens, you got to do this. If that happens, you have to do that. If you have a power vented hot water tank in the same room as a natural draft furnace, this has got to happen. So there's a lot of scenarios. It's very confusing. The only thing I can say is that we just want to look at the conditions, right? We're not as a home inspector, you may not know if that is exactly the way it should be, but if you see conditions that sort of ring an alarm bell to you, make a note of it. And if you need to have somebody follow that up that is an expert in that particular field, because like I said, venting is a very difficult subject for people, for gas fitters to actually get a grip on. Matter of fact, in the exams that are taken, I used to sit on the apprenticeship board, and we used to find out the results. Uh, Probably 80% of all the incorrect answers that were written on when a gas fitter takes his test regarded venting. Direct vent is also another type of venting. This is when your combustion air is exhausted out through a power venter. We've talked about the mid-efficient furnaces. We've talked about power vented hot water heaters. So they will go out. Generally, they go out a side wall, but they have been known to extend up through a roof also. So there is some different things that you may have to run into when you do have uh, a plastic, we'll say plastic venting going up through a roof. There's some issues that may be that occur because of that. But anyway, we'll look at the clearance thing in a bit. Again, when you're doing your inspection on the vents, you want to make sure that nothing's discolored, that all the joints are secured, that the appropriate materials being used. And I can tell just by looking at this, it's got that little orange and black tag. I know that this material is system 636 material, because that's clearly identified on every fitting and on the piping. That's approved. This is a piece of ABS pipe coming down. I think that's just acting as a combustion air, because it will not be tied into anything in this area here. All right, it's not tied into the hot water heaters, and it's not tied into a furnace. So the BH venting, as it's called in the manual, is a term that's used to identify the special venting materials that are required now on all high efficient equipment, all high efficient appliances, and it falls under the system 636. This is something that has come out now in the last about 10 years. Before that, we were using all kinds of different materials, but we have now settled on all the manufacturers and the gas companies and all the powers to be have settled that, okay, this is going to do it. We're working with this, and we're going to stick to it. So when you see the 36 or 636 venting, again, all you're doing is looking for improper installation techniques more than anything else. And most of the time, when you look at the venting system, you will see a little purple streak, maybe with gray on it. And that is because all this piping here that you put in is a special PVC plastic. PVC plastics have to be joined with a special glue. We talked about that yesterday in plumbing, and it has to be primed. So the primer is always colored purple, basically, so you know that it's been primed. So you put this primer on the outside of the pipe and the inside of the pipe, and then it's a gray glue that's used on the 636 PVC. Then you put that on, you put your joints together, and that's going to hold it, right? So you want to just make sure that you see these indications of glued joints. This is relatively neat. You can get some that are really sloppy, but what the heck, what can I say, right? The other thing you want to make sure of for sure with these is that they're supported properly. You have to have some kind of pipe support, so you don't want this flopping around or being susceptible to somebody banging or hitting it and maybe possibly cracking a fitting or causing other problems in the furnace itself if it's close by or where it goes out the wall. So that's important. Make sure supports are in there. Now we talked earlier about having a one pipe. Regarding two pipe systems on direct furnaces, some installations may only have the exhaust pipe going to the outdoor, doors, and the intake is left to draw from conditioned air. That was done back in like over 15 years ago, where you had to have your exhaust go outside, which is appropriate, but the air intake was, you didn't have to have it go outside. So of course contractors will do the path of least resistance and say, okay, well, we don't need an air intake. Why would I bother drilling another hole and cutting it on the outside? So we'll just pull the air in from here. The important thing is to know, and we talked about that earlier, that it should be extended up and away from the furnace area itself, and that you still have a good air source where that air can be drawn, where that can draw air from, right? Definitely, all new installations have both pipes going to the outside. Uh, Here's a little picture of the vent termination clearances that that are required. And again, like I said, there's a lot of different things here. You got to be so far away from the corner of a house. You have to be so far away from anything that opens, any windows, anything like that. This here, my uh, my suggestion would be to see if you can get yourself a good clear diagram of exactly what is supposed to be required on these terminations. Keep it with you and be able to understand it. For example, if this is an electrical meter, you can't have, oh, that's not an electrical meter, that's looks like a side shot exhaust vent. An electrical meter, you can't have any exhaust uh, venting coming out underneath it or close or within a certain distance horizontally or below it, right? Or above it. There's a lot of different things. It would take an hour just to go through all that itself. Some of the things you might want to do is note if A, for sure, is it in a place that would cause a hazard if there's ice accumulation? For example, if it came out outside of a building and you had an outside stairway going up to the second level, say it was a rental up top, and it came out and it was discharging where the stairs are, that's a problem, because that's gonna ice up in the wintertime, no doubt about it. So that's a hazardous condition, right? That is not where it's supposed to go. If you shouldn't have it more than or less than 7 feet above a paved sidewalk, I'm sorry, or driveway located on public property. Okay, if it comes out on your sidewalk here, then that's your sidewalk. But if it's public, which I doubt it would be, because you're not going to build that close to public property anyway, that's just one of the things you want to make a note of, where all that exhaust air, the products of combustion and the vapor, the water, and that is going to accumulate. Again, above any type of a regulator, which includes a gas meter or a propane second stage regulator. You don't want that above a regulator or within 3 feet horizontal from it. It says here less than 1 foot above grade. In most cases, you're going to find this. It should be up higher, possibly 2 feet if possible. It depends, of course, on the depth of where your main floor is. If it's ground level, then you're going to be dealing with something a little different, right? And you may end up with what they call a snorkel, where the pipe comes out and then it goes up and then it elbows out again. Because if the piping's too low to the ground, what's going to happen when you get a pile of snow? It's going to plug up, right? You're going to have snow building up there, and that is not going to work, because as soon as that plugs up, that furnace isn't going to operate, or the appliance at all. You can't have it near any type of a window or door, or non-mechanical air supply, or combustion air inlet. In other words, where you're going to run into this is also with HRVs, right? Your HRV is going to have an air intake. It's going to have an exhaust. So you have to make sure that it's within it's away from the it's within tolerances of how far or how close it can be to either of those setups. So
I'll maybe make a quick note on that diagram. So we obviously try to do the best to teach you guys all the things you commonly come across, but of course, there's no way that we could cover all the nuances that you may see, all the different fittings and components. But as you guys are doing your inspections, get into the habit, if there is an installation manual, just flip through it a few times. Obviously, the more times you guys check out these installation manuals, you're going to notice that there's a lot of commonalities, common requirements. Again, you guys are not required to know any of these codes that we post, but I think they're very not, they're good information to have should you find any issues, and you can say, well, this is the clause, this is the deficiency, you recommend this be rectified. And of course, a lot of inspectors, they do a lot of research after inspections, right? If they don't know about a system. So just sort of kind of get used to looking up things that you may not know, because that just makes you a much better inspector down the road.
exactly, and you will find after a while that most manufacturers of furnaces and gas hot water heaters, their specifications are very close together, like as far as the type of material that's used, the type of venting that's, how it's installed and stuff like that. Those they become very consistent. A good site to go to if you have a chance is to the Lennox site, and you can access a lot of their library on without being a member, and you can download like their installation manuals. And I would suggest you download a manual for a couple different types of high efficient furnaces and stuff like that. They'll probably be, anywhere between 60 pages long, whatever. But there'll be certain parts in it that will give you that information, the vent termination requirements and what they want. And you will find over time those requirements will probably be the same as a carrier unit or a Goodman or something, right? Matter of fact, just as a quick note, a lot of the furnaces that are made are only made by 2 or 3 or 4 different companies. They just have different names. Carrier, for example, is the same as Bryant, is the same as Night and Day, and is the same as another one. And Lennox also have a kind of a name in the States called Goodman, stuff like that. And you'll find that it's a marketing thing, right? They're all identical units. It's like a GM, a Chevy, and a Buick, and an Oldsmobile. They're all basically the same, except they have some different bells and whistles. Combustion air, again, we talked about that earlier. I don't think we have to cover that very much, but again, this definitely is something you want to note in your report, the presence or the absence of combustion air. A lot of combustion air that comes into a room that's serves a category 1 appliance is generally an round insulated uh, duct. It's flexible. It usually has an inner core of either aluminum or fiberglass, kind of a flexible fiberglass plastic. It's not exactly as like cheap dryer vent, but it's a little better grade than that. But it's insulated, usually around 6 to 8 inches in diameter. That's inside diameter, so this will be probably 8 inches if it's 6, or 10 inches if it's 8 inch, and that generally supplies enough combustion air into the room itself to provide proper fuel air mixtures at the furnace, right? Now, when you're dealing with category 4, that's a little different matter, because of course category 4 is self-contained per se. It has air coming in, it has air going out. It's not relying on any air from in the building to provide proper combustion. This little interesting thing here, I've seen this on a couple diagrams, not that common, but I've seen it. It's a kind of a barometric damper that when there's when the furnace requires air or is a call for heat, some of these actually have a little electric motor similar to those dampers, the vent dampers that were on those furnaces we talked about before lunch. That will open, and then it allows air to go up or to come out from here into the building, so that basically you don't have cold air spilling in here all the time when the furnace isn't operating. Now, another thing that you may run into is some people will run this down and they'll put a little trap in it and they'll run it back up again, maybe to about 18 inches above the floor, in the hopes of thinking that the heat will the trap will prevent air from just flowing freely into the room, right, from the outside. What's basically happened is over time we've made our homes uh, so well insulated and sealed that we don't have any ways of bringing air into the house other than combustion air ducts or an HRV system, right? So in other words, we've built a really nice house and then we've had to cut a 6-inch hole in it just so air can go back and forth, right? That's basically all. If it's plugged off, make a note of that, because a lot of homeowners get all worried about cold air coming in, heaven forbid, and they'll block it off with a piece of insulation. That's a no-no. That thing is there for a purpose. If you got cold air spilling in all the time, that's an indication that you've got a pretty negative pressure in the house, right? When that happens and you have an HRV, you probably have an HRV that's not working, because an HRV will maintain pressures in the house where you won't get that constant spill of air. I think we've gone through the inspection process here for this. We've been talking about it. Oh, here's an interesting little note, just in case you do run into this. In a dwelling unit, the appliance cannot be connected to a flue serving a solid fueled appliance. In other words, if you have a gas hot water heater or furnace, it cannot be put into the same chimney that serves a fireplace or a wood burning stove, anything that's solid fueled, right? It should, and it can't be put in anything that's oil fired either. So oil fired and wood fired appliances and gas fired appliances cannot, the venting cannot be mixed in that. Don't run into that very often, but once in a while it happens. Some people think a chimney's a chimney. Well, you can't mix the two. Okay, so that's something to keep in mind of. Requirement for carbon monoxide detectors, we've talked about that. Again, if you have a problem with something that you see, make a note on the report, and it should be followed up by having further inspections done by a qualified person. So now we're going to talk about some of the ways that the fuel gets from point A to the furnace or the gas hot water tank. So most natural gas systems, you're going to have black iron steel pipe coming from the gas meter outside through the wall and into the basement area to the mechanical room. Now, in a perfect world, your gas fitter or your gas meter is relatively close to where your mechanical room is, and that your mechanical room is also close to the outside wall. That doesn't always happen, but it doesn't really matter, because once the piping comes into the house, it pretty well can be run anywhere, provided that it's been all tested. So it's quite common to find gas piping that's been covered up with threaded fittings that have been that are covered you can't get at. That can happen a lot, especially when people have, bought a house and decided to renovate the basement, so they're gonna cover the gas pipe up with gyprock. So that can happen. It's not the best, but at least at that point you can do that. The only thing that you really have to worry about when you're dealing with black iron piping is where it comes into the house. If it goes through a concrete wall, that pipe has to be sleeved. In other words, you can't have the pipe going through a hole in the wall without some type of protection between the concrete itself and the black, the steel piping, right? So generally it'll be taped with a special polyethylene tape. It's called polycon tape. It'll be taped that way, or a sleeve has been put in. It could be a plastic sleeve, and then the pipe goes through it, and it's so it's isolated from the concrete, right? Often they'll take RTV silicone, or sometimes even a lot of times that foam spray, right? And they'll spray it in between the pipe and the sleeve if there's a gap, because there, you might have 1.5-inch pipe and a 1-inch pipe going through, so you got a gap. That's okay, you can do that. It's not going to hurt the piping, right? But you have to make sure that's in there, because if that's not, sooner or later that's going to have to be replaced. And if the new homeowner gets the tag saying the gas pipe between your meter and inside your house has to be replaced, well, they're going to have to foot the bill on that, right? So that's something you want to note. Of course, any type of corrosion on the piping itself, any type of things where the pipe looks like it's been bent or somebody has pulled it over so it's not straight, or doesn't look like it should have been when the way it was installed. Those things you want to take take note of. And I find that most violations of steel pipe installations, because this is relatively standard to put in, always has been ever since they started putting gas in houses in the 60s. So a lot of things haven't changed too much as far as the way that goes. The fact that it's bonded, we talked about that earlier. But I find that most of the time, if I run into problems with gas pipe, and if somebody says, well, I want to get this up to code, okay, well, looks like for one thing, maybe we should put some more pipe supports in, because this thing's only hanging off of a strap about that's 10 feet away from here, right, sort of thing. So there is a code to that states how far supports are, and your typical gas pipe installation on steel would probably be about a 1-inch pipe. So you want to have a support about every 6 feet for that type of a purpose. You want to make sure your support's not going to react with your steel. So you're not going to put a copper strap on a black iron steel pipe. They have strap iron and different materials that you can use to properly hang that. That's one thing. Corrosion, again, is another point. Usually if there's been something dripping on the pipe, or if you're in a high humidity area, you may get corrosion on the pipe. If you're in a high humidity, if the area is that humid that it's causing problems with the corrosion on your black iron steel pipe, then you probably are going to have more problems than just a black iron steel pipe, because that corrosion, that humidity is going to reflect on your appliances, the construction materials, the whole works, right? So that's another thing you want to keep an eye on. And then the other thing is that people, for some reason, think that it's a great place to hang their clothes and their hockey equipment and all this other stuff. Or it's not a hanger bar, right? You're not hanging anything off your steel, your gas piping. This here is an example of somebody doing a soak test on the bottom of, what do you call this? Somebody answer me.
Looks like a drip leg.
Yeah, dirt pocket, drip leg. Yeah. So basically, this always comes in where a gas the gas pipe is coming down from a horizontal position, say at the ceiling level, dropping down towards the appliance, or maybe there'll be a T up above here with a shut off valve. This here is what they call a drip pocket. And for the life of me, I can see the point, but I don't know if I've ever seen anybody realize what goes in there, because I've never found anything in it. But apparently, if there's any contaminants in the gas piping system itself, that they will have a chance to collect in this dirt pocket, right? Again, I've taken all kinds of these apart, and I've never found anything in them, but it's there, and I don't care. That's fine. It's pretty. So they've used soak test a soap, they've done a leak test on it using one of those detectors, that leak detectors, like I talked about before. Masters leak detector is great. And if you see something like this, what this here is an indication of a problem. You see all these little bubbles here? That means you've got a gas leak, all right? And it takes very, very little leakage to make bubbles up. The thing is, you got to make sure you have, all you have to do with those leak detector ones is just put it on and it'll bubble itself. If you use soap and water, you got to have to make sure you got the right mixture. And again, if you have an electronic leak detector, all you do is you just run your thing and it'll pick a leak like this up. You have to be careful. If you smell gas when you're doing work and you have the leak detector, I would definitely do a leak test on any of the exposed piping that you can find. Good chance you're not going to find it here. The 90% of all the leaks that I detect on existing piping systems either come from the gas cock, the shut-off valve, or from a union, right? That's where I normally would, that would be my first look. I'm looking for a gas leak there and there because that's where they usually come from. Gas shut-off valves are a little bit different than water valves and stuff like that. So they use what they call a wedge system to turn on and off. So sometimes when you shut off a gas valve, which is only a quarter turn, and you do some service and then you turn it back on again, well, that you may get a little bit of gas that will start to leak out around where you shut it off and on the back side. And that's very common. So I always used to tell my guys, before you leave, you make sure you soap test your valve and your union, because I had one guy leave a union not tightened up, and the person came home and they called the gas company because they could smell gas, and there were some repercussions about that. So needless to say, he didn't no longer did any gas work for me. He was a good plumber, but anyway.
There's a question from Jim. So thoughts on why venting manifolds legal? So you can see them for B vent and BH vent as long as it's it's a manufactured certified component. I see no issues with it. Thoughts on that, Vern?
Okay, exactly what does he mean by a piping manifold?
A Y venting manifold. I would guess when you
Oh,
have
a saddle Y going onto a pipe? Yeah. You can that is approved, provided that appliance and the furnace work together on that. You have to be very careful because for example, if you have a mid-efficient furnace which uses a power venter and it goes to the chimney pipe, you cannot tie a Y saddle into that and vent your natural draft gas heater into that, because now you're dealing with a power vented vent, which could possibly, when that comes on, could possibly go up into the C vent going towards the chimney. But if there's an obstruction in the chimney, it would back up through the Y saddle and come out and spill out on top of the hot water tank, right? So that's not allowed when you can't tie into the same pipe going to the chimney. You can, however, get a double T for that purpose, to be able to tie your power vented furnace boiler that uses a C vent into the bottom portion of that, and the top portion would be dedicated to the vent pipe going to the hot water tank. So yeah, the white saddles were prominent on when both the appliance and the hot water tank were both natural draft type furnaces. Okay, Kat. Hope that answers it. Okay, well, we'll move on to now the other type of product that is relatively commonly used in gas piping. That wasn't me. Is copper tubing, right? Where you're going to run into copper gas lines will be in a lot of larger homes, for example, will have, say, gas-fired equipment pretty much remote from the mechanical room. Say you have a gas fireplace in your master bedroom on the top floor, which is just about as far away from the mechanical room as you can get. Now, rather than running black steel pipe all the way up to that point, you do have an option, and you can run uh, copper, which is a lot easier to be able to snake through joist spaces and stuff like that to get to that point. So you can use copper pipe for that, but there's a number of rules that have to apply to this. And one of them is the fact that this copper can't be put in a place where it can be damaged. In other words, if you're running it through joist spaces, for example, you would have to be a certain height above the bottom and below the top, so that if somebody drove a nail into the joist, the bottom of the joist, you wouldn't puncture the gas pipe, right? And so there's some tricks on that. It's still a better way of doing it than trying to run steel. All the all the fittings that are associated with the gas piping are a special fitting. They're not like the plumbing fittings. They're not a solder type. They're not a compression type. Not for this. They're what they call a flare type. So this tubing is put together. You need a special tool that flares the copper out, and then you put a nut on, and you see here the adapters itself have a built-in flare, so that when you tighten it up, that copper here compresses on the flare face, and it provides a leak-proof seal. This fitting here would be used if you were going back to a threaded fitting, like for steel. Say, for example, you run your pipe to the gas fireplace, but you've got to tie into that fireplace. So you may put a nipple and a gas valve and whatever, uh, another nipple or whatever on the fireplace gas valve underneath, but attach that to the copper piping with a threaded adapter, right? When you have an adapter like this, you don't need a union, because you still have a point to be able to take that piping apart. So that's just something. There's an ability. It acts as a union also. So that's something you're going to run into. Another place that you will run into these, and I run into it the first time back. Actually, it was in the 80s. I didn't do any plumbing or any heating when I lived out in British Columbia. I just did strictly plumbing. But I know that a lot of buildings, what they were incorporating was a what they call a two-pipe gas system, or I'm sorry, a 2-pound gas system. And you may find this fairly popular in Calgary, also in Edmonton, because it was the same type of market. It's still relatively popular, where they can run a higher pressure gas to an appliance, so you don't have to have big piping. And then what would have to happen then was, once it got to that point, you'd have to have a special regulator, similar to the second stage regulator on a propane system, installed to knock the pressure back down to what the appliance is rated for, right? So they would have copper running through there. A lot of times this will run to a gas fireplace, like even in a living room, because like I said, it's easier to run. Now, in some cases, it'll be run underground, and if it does go underground, it has to have a yellow protective uh, covering that's factory made. There's no ifs, ands, and buts about that. So here's your typical joint that's tying into a gas appliance. That's your T. Under here would be your drip pocket, and there's your flare joint fitting in your copper pipe. The other thing you want to note is that any of this copper pipe that is installed has to be identified clearly. That's very important, because it will have either a yellow coating. Some people will install this completely even above ground and through the systems, or it'll have labels and mark clearly gas or propane. Reason being, you might have some silly plumber that goes in there thinking it's a water line and cut into it. It's not a good. You don't want to get these things mixed up. So you want to make sure that it's clearly marked and that you see these markings about every 3 or 4 feet. So there's no guesswork. If you don't see it, you make a note of it. This corrugated stainless steel tubing has now become very popular because it basically replaces a lot of the work that's being that is taken when that you would run into when you're running steel piping. You don't need the threading equipment. You don't need to carry big lengths of pipe, stuff like that. So since this has been approved for the installation, it's become more and more popular. I know that the company I do some consulting with, they use it quite often wherever you can. It's more expensive, but labor wise, it takes a third of the time to do installs, but it has to be installed properly. Again, this stuff is not indestructible. You have to make sure it's put in so that it's there so that there's no physical damage. There's no chance of somebody putting a nail into it. Has to be supported properly. You don't want to see any kinks in it because basically all it is like it's just basically an aluminum coil of piping that's coated with a neoprene type jacket, basically to prevent corrosion. So that's one of the things. The other thing is too that they use a special connector, and you need a special type of tool in order to make these two joints work, because this has to be peeled back, has to have a ring that goes around, and that ring goes and locks into the corrugated steel. I really don't like the connection methods yet, but I'm sure that over time they will improve. This is where you would have your leak right here. So that is another thing that you'd want to check if you want to just test that for leaks. Again, here's your gas valve I was talking about. These are the points here, this side and this side is where the leakage occurs. It's only because you close it and you've opened it, and sometimes there's that little seal here uh, is compromised, and you may get a little bit of leakage there. Okay. We're going to talk about flex connectors. Again, a very common item that you'll find on gas equipments. We don't want to confuse this with this stuff, even though it is basically the same. It's that these are self-contained units. You buy them with the connectors on and everything. You don't cut these to fit. You don't use special tools and special connectors. You buy them this way. Certain lengths, you need an 18-inch, you get an 18-inch. You need a 24-inch by half, you get a 24-inch by half. So this is all good. It's approved, but there are some rules that have to be followed when these are used. It can't go through a wall or a floor, a ceiling or a partition, and it has to be and it shall be connected either to this type of piping on one end, or steel, of course, and it has to be attached to the appliance on the other, right? More likely, you're going to attach this to black iron pipe. This would be attached to the appliance. More often than not, certain jurisdictions don't want you to run this piece of pipe through the furnace cabinet. So you may have a piece of black iron steel come out of the furnace, and then you have this connect between here and maybe the pipe going up to the gas valve, right? So if you see this going through the cabinet of the furnace, basically from the outside of the furnace to the inside of the furnace where the gas valve is, you want to make a note of that because that's illegal. Remember I mentioned that story about the lightning strike and the rupture? This is exactly on what it happened on this type of tubing. There was a little hole right there. And the only reason why I saw it was there was a burn mark on the side of the furnace on the outside. So yeah, they're handy, and they're very well used in most cases now to connect your appliances. Plastic.
I'll make a note on the flexible pipe there too, Bert. So as Bert mentioned, right, a lot of times manufacturers of furnaces, even water heaters, may prohibit the use of these flex lines. Again, if there's a manual, do take a look, because some are okay with CSST going through the upper cabinet of the say furnace, but other manufacturers may prohibit any use of flexible gas piping. They'll state clearly if it has to be rigid.
Yeah, exactly. In the furnace cabinet itself. There, yeah, that is, if that's what you mean, right?
Yeah,
You
you
can have
betcha.
a flexible connector connecting to that furnace, as long as it's outside of the furnace, connecting to an appropriate um, uh, assembly of black iron pipe coming out of the cabinet itself, right? You can actually have that. They're really often used on unit heaters, stuff that has any type of vibration, because they're not they'll absorb any of the vibrations that you get from things like that. If you have a ceiling hung unit heater, things like that. So there's good purpose for them. A lot of gas hot water tanks have them on from coming up from the gas valve, because if you have to change hot water tank, it's a real easy. You don't have to try to uh, replace the steel piping with a hot water tank that has a 1 inch difference between the height of the gas valve from the old one to the new one, because your options then are to now have to hard pipe it with a different size steel piece of pipe, right? Plastic tubing. You're not going to run into this inside of homes at all, but you may run into this if you have a house that has a garage in the back or beside it, somehow remote from the house, that has a gas appliance in it, because a lot of garages now have little unit heaters, or might have a space heater, whatever, might even have a hot water tank that heats the floor through radiant heat. So rather than running a dedicated gas line from from the utility, which means you need another meter, you would tie this in downstream from the meter. You get a special kit called a meter kit that you would tie this into. The pipe would go back down through the ground where the meter is at the house, run underground, and come back up through the ground to an appropriate place on the side of the building where your furnace may be. It could be a pool heater, if your pool is remote, stuff like that. Barbecue, no, not much. Barbecues don't usually. They might. They could. I guess I've never put a plastic line in for a barbecue. The whole thing is that these are. This is a special type of piping. You need special materials for the risers to come up through the ground, and really you can't really see much of what's going on other than what you see above ground. My best my best advice is to make note that the house has a underground service, gas service, leading from the meter area to the garage, and then you go in the garage, you do your inspections of the gas appliance like you would normally with in the house, right? If it's got a hot water tank, you do all the same things that you would do there, because it is a gas appliance, right? All right, any questions on that? Hopefully not. We'll do a quick talk about dirt pockets, which is the sediment trap. No, we don't. We don't have to talk about that talk. We talked about it. We've talked about leak testing, and again, it doesn't hurt to do that. You're not really looking for trouble, but like I said, if you do smell gas, a little whiff, and it doesn't take much. Some people are much more sensitive to others. I have to tell you that I actually cannot smell natural gas anymore. For some reason, I'm totally desensitized from it, whether it's because I smoke or because of other things. I can't smell natural gas, and I can't smell ABS glue either. Weird. Gas fireplaces. Oh my goodness. Can these be a mess? A lot of homes have gas fireplaces in it, and it's a great way to have um, supplemental heat, your ambience with a glass of wine, et cetera, et cetera. So they're very popular. They have been for years. Uh, well replaced from the old wood fireplaces because they're clean burning and stuff like that. So now it's very difficult to do an inspection on these unless you're willing to start really getting into it, tearing things apart, because most of the stuff you're going to run into is behind the sealed glass. Generally underneath, you can't see it in this one, but there's a little panel that sits down here. You can open that up, and that will reveal your gas valve, your blower if you have one, your electrical connections. Those things should be accessible so that you can, and if you really want to get down and dirty, you can get down there. Some of the panels come off, they're just on a hinge. You might undo a screw, pull them down. There is where you will find your data plate for the fireplace. Which it's a gas burning appliance. It still has the same type of data plate that other appliances does. It'll tell you your make, model, serial number, your BTU ratings, clearances, stuff like that. Because certain fireplaces will have certain clearances involved, especially when you're dealing with what they call inserts, which means this is a gas fireplace that was put in where a wood fireplace used to be. So a lot of times they'll use the existing chimney, the wood chimney. They'll put a special liner down called Z-Flex, run that down, hook it into the furnace, and then you slide the whole thing in, and you put this nice little trim around it. They're quite nice. You can't tell what's going on behind there, but but the indications are that if there is a problem with the fireplace, number one is you may see sooting on the fireplace. And when I say sooting, that may also be like a white discoloration, a lot of times down around the lower area. That's just a indication that, some of the gases have been condensing on the glass itself, and it leaves a residue, right? So you might see that. If you see soot, for sure, that's a problem. Now, when you fire it up, then and you start and you see any type of the flame structures can differ in these because in one way they're supposed to look like a fireplace, so you should have some type of nice glowing amber or flames coming up, so they're actually made to look like they're not burning properly, right? Because you don't want blue flames coming up, you just want nice orange flames coming up. But if you start, if you see sooting, that means you're either having a problem with the air mixture for this, and it's actually creating a little bit too much. It's getting uh, too less air, and it's causing it to soot up, or you're having a problem with the venting. So sooting is a real problem. A lot of the times you'll have blowers that may not operate; they just break down. They're a mechanical device, just like a blower, a motor, and everything else. And especially on furnaces or fireplaces that are over and above 10 or 15, 12 years old, a lot of times the blowers don't operate right. Another thing to note is how are they operated? Some people just have a switch, they turn it on, the flame comes on, period, right? There may be adjustments for it underneath on how to adjust the height of your flame, stuff like that. Those are things you'll find down in the kick plate. Some of them are tied into thermostats, so they actually will come on if there's a call for heat, especially in areas where you may have the room may be cooler than others. You have a lot of outdoor or exterior windows and stuff, a patio window where you get heat loss. It may come on by itself. It may have certain special devices. You might even be able to turn it on with your phone. That's coming in very more popular all the time. My best uh, call on this would be basically do your due diligence, get as much information as you can. Here's a copy of the data plate. If you're looking in it, here is your blower wheel. You've got all kinds of mechanisms here You don't really want to know how hard it is to work on these things. These are terrible units to work on. Everything's tight and jammed together. It's nasty. If when you do fire it up, uh, a lot of the time, the blower motor, the blower itself, is controlled by a thermal disc. Remember, we talked about those thermal discs. So it has to reach a certain temperature inside the fire compartment for the blower to come on. So, and that usually takes a few minutes to get up to temperature. It may take up to 5 minutes for it to get up to the temperature required for the blower to come on. Uh, a good indication before you even fire it up, if you're in this area, you get your hand in there, just get your finger and give it a quick spin on the vein. See if this is turning freely. If it's not turning, that means it's seized up and probably it will not work. And the bad thing news about it is that if you still got electrical current going to that, that means this motor is heating up, right? So you're going to want to definitely make a note of that. Let the homeowner know if they don't already. You know, you got power going to that. You got to figure that out, right? Some of these fireplaces don't even have power going to them. If they don't have a blower, which in many cases it's optional, they'll only have they may operate off what they call a power pile system, which means any of the electrical requirements that are needed to turn this fireplace on and off are actually generated underneath by what they call a pilot generator, very similar to a thermocouple. You got flame, it creates a current, and the gas valve is turned on and off because you're getting a current from this pilot generator to the valve. Now, these are generally controlled by a thermostat, but you need a special thermostat for this. You can't use a 24-volt thermostat on a poor power pile generator unit. It's a special power pile generator, right? You can, if you do a 24-volt thermostat, it may operate, but it'll give you trouble. So those are things to note. If you don't have a blower motor, you don't have any electrical going to it. No need to worry about that. So that's another thing to take note of.
We'll take a break here,
Now, let's
Vernis.
take a break. We'll get into
Yeah, you betcha.
I
So,
think we're going to be good on time today.
yeah, you betcha. So, yeah, guys, we'll take about 10, 12 minutes or so. We'll come back at quarter past. And again, if you have any questions in the meantime, by all means, put them into the chat and we'll definitely address them when we come back.
Okay. I have to take a break also. I'll put my little happy face. So we're going to talk about some add-ons that you will run into as far as the ventilation systems or heat HVAC go in residential buildings, and we'll start with humidifiers. Now, one of the reasons why a house may need humidification is that in the wintertime, your air is very dry. So if your house is subjected to a lot of incoming air from the outside that is dry, it's going to have a tendency to dry up the air in your house, which makes your life uncomfortable. You get a lot of static electricity charges, you know, like from walking on the carpeting. You have your nose feels like it's dried up every morning when you wake up, stuff like that. Humidification isn't quite as important as it was back in the older days, only because most of the houses that are built now, again, are sealed and they have a controlled amount of ventilation that is dealt with using an HRV, which means you shouldn't have a whole lot of dry inside air coming in, drying out the house a lot. But you're still going to run into these, right? So as far as humidifiers go, you are going to run into them, especially in older houses. There's a couple different types, and one of the most common types would be like the drum type humidifier, which are really not that good. I would call them junk. A lot of times you'll see them. They'll be mounted on the warm air plenum of the furnace, and it'll have a name. Like General was a very common manufacturer of these drum type units, and it'll have usually a clear window similar to this, and it'll give you a pic. You'll see inside, and you'll see the drum, and there's a reservoir. This one's a newer type of model. It'll have a reservoir. It'll have water tube of water pipe coming to it, like usually an 1/8" tube. This one looks like, oh, that's part of the air conditioning. Yeah, this one would have a tube. Has a little motor on it that turns the humidifier, and is generally controlled either by a humidistat, or generally it just comes on when the furnace operates too, like the older style. So as soon as the blower motor would come on, this would be tied in wiring wise with that, so that this drum would turn. Now, quite often, these systems get neglected. Nobody cleans them. The reservoirs get full of scale. There's a little, so the drums get full of scale. So everything just scales up, and then the purpose now becomes, they just don't work. The floats, there's a little float in here that would regulate the level of the water in this reservoir. You need a reservoir to keep this drum damp, right? Well, they scale up because of very susceptible to scaling conditions. Worst conditions you'll run into is in the humidifier. So people just end up shutting them off, and they just sit there, right? So if you run into an older humidifier in a house, there's a good chance it doesn't operate. If you want to check, you can just take this cover off. It's pretty easy. Take a look. Is there water in the reservoir? Okay, if there is the valve on? You'd have to go search it. You'll probably run into one of those cheapo saddle valves. If you do, don't touch it. It's just going to start leaking on you, give you trouble. You'll note, and if the condition of the drum wheel itself, the felt or the sponge type part, is in good order, and it probably works, right? You'll verify that by turning on the furnace on the older part, right? It'll start turning. But like I said, I would say 80% of the time they are non-functional. So you just make a note saying that has a humidifier, it's non-functional, and that's about all you can do, right? This is another older type of furnace or a humidifier that uses, I'm going to try to remember the term on this. It's, well, instead of a drum, Alex, do you remember?
Yeah, it's like a flow through cascading type of humidifier pad.
Yeah, exactly. It's a humidifier pad. So basically, this is a big square. It's like a mesh, and it's got this media inside, and water will flow through here, and air will go through this, providing humidification into the return air or into the supply air ductwork. A couple of the bad things that happen when you run into these is if they malfunction, they have a tendency to flow over, which means the water out of that might be coming out of here, and it may not run all down in here, but inside the furnace itself, which will drip right on top of the furnace heat exchanger. That's a bad thing. They're not, like I said, they had a place in older homes, and they still do in an older home, but a lot of times you're going to have to upgrade this whole system, and they have better products available that don't cost an arm and a leg to put in. And actually now they are mostly put in on the return air side, so that if you do get any flooding, at least it's not dripping into the furnace, right? Not damaging that. Interestingly enough, here's a picture. Here's that barometric damper I was talking about that we deal with on oil. So this whole system here looks like it. This is interesting because you don't usually have a barometric damper on a gas appliance, and yet what I'm looking at here may not be an oil-fired chimney, and I'm going to assume it is.
Maybe I'll speak to that, Ryan. So that is likely just your seasonal damper, your louver. So A lot of people will isolate your humidifier bypass duct, what you see there in the summertime to prevent any sort of debris accumulation. Should there be, say, an evaporator coil for an AC unit? So a lot of times you'll have a winter and a summer indicator for these bypass ducts. And again, that's just to isolate the humidifier, that duct in the summertime when you don't need
Oh
humidification.
yeah, that's possible. It's hard to tell because it actually looks like it's tied into here somehow, and it would not be, right?
Probably just deceiving is all. Yeah, the image makes
Yeah,
it.
it is. It's deceiving. This piece of insul or foil type flex is either terminated at that point, and there's a space between here and the venting and whatever. Anyway, that's just interesting. I've never seen really a setup quite like that. I've seen situations where they will have a pipe like this going and tying into the return air, and at that point they may have a little damper that you can slide back and forth to isolate that. But this I've never seen. Interesting. Okay, we're going to talk now about heat recovery ventilators because I can't stress how important these are in to maintain a proper atmosphere in a new home, because the new homes, like we talked about, they've been built for quite a while now to be totally airtight, but because of that we start to compromise on other things that that happen when you live in an airtight structure. Number one is air quality. Your air quality will drop if you don't have a proper type of air exchange. And number two is you'll get a lot of humidity building up in a building that doesn't have proper air exchange again. Because how else do you get rid of humidity other than using a bathroom fan or a kitchen exhaust fan, which is still very common in a lot of the houses going back to even up to the mid 90s. But since that time, and in a lot of jurisdictions in Canada now, it is required to put in what I call an HRV, a heat recovery ventilator. And what that does is it'll take air from the outside, mix it with exhaust air from the inside, heat it up to a certain to at least get some heat off of that outgoing air to warm up the air coming in, and then distributing it back through the house, right? So you have this constant exchange of air going in the house, which in most normal cases about you need about 1/3 air change every hour in a house. So if you have a house that's got um, 10,000 cubic feet of air or of air's volume, you want to change about 3,000 of that an hour, which means you need something that's going to give you, what is that, 50 CFM? Let me do the math. 3,000 divided by 60, 50 CFM. It's not a lot of air, but it's enough to do what it's supposed to do, right? The problem with exhaust fans and that is that they're very nice, they're noisy, they have a place, but again, a lot of times bathroom fans break down, especially when they're older, and people just have a tendency of not replacing them or fixing them. They'll simply take the cover off, unplug it, because a lot of the fans are plugged in, at the, once you take the ceiling grill off, they'll have a little plug in there where they plug in, and then they're not used. So what happens then is your whenever you shower and all that humidity stays in that room, collects, and you start getting mold and all kinds of nasty things, building up along the ceiling. You'll have marks of mold and stuff like that. Kitchen exhaust fans usually are pretty good. Again, they're noisy, and some people just it depends on the habits. If you do a lot of cooking, you need to get rid of a lot of humidity. Believe it or not, if you run into a house that has a crawl space, for example, that hasn't been, doesn't have a concrete floor, it could be just dirt. If it hasn't been sealed with poly, because most of the time you should have a crawl space or whatever that's sealed with poly. You know, you put poly like you would up on the walls, a poly sheeting down. Sometimes you'll put dirt over top of that. You don't have that, you are going to get a tremendous amount of moisture entering your house just from that, from the ground. Even through concrete, you still get a certain amount of moisture coming into your house from that point. So you take that, combine that with the people that live in it, because what are the products of our breath? We breathe out a lot of water vapor, right? With our carbon dioxide, we're kind of like a very fancy high efficient furnace. So anyway, I want to talk about the HRVs because they are, I think, a very important part of the building package. And one of the points that I find when I go in to do in service work or inspections, one of the points that I find that is most usually shut off is the HRV for one reason or another, right? So so what you want to do when you're doing an inspection on a house with an HRV is, number one, you're gonna want to go outside. Again, this is part of your exterior inspections. You want to determine the location and the condition of what they call the air intake grills and the exhaust, right? So they should be clear and not obstructed. A lot of times they don't have dampers in them like you would a dryer vent, nothing like that. They'll have a hood. They'll be bigger than a dryer vent, obviously, because you're usually running out a 6-inch, 5 or 6-inch round pipe. So they'll be bigger. But on the inside, they'll have a screen. And we talked about the screen earlier regarding what happens if that screen, if you take the screen off because it's prone to freezing, right? Well, the screen has got a couple different features. One of them, it's not big. The holes aren't big enough to keep out bugs and flies and stuff, but they definitely will keep out squirrels and birds, right? Because you never know what you're going to get inside that HRV. Anything that is an open hole in the wall outside is an invitation for guests. So those are things you want to do. The other thing you want to make sure is that especially the air intake on the HRV is in a place where it's not going to draw in air that may be harmful. And I'm going to give you a quick example. I had a customer who had a problem with a system that was put in not by us. They kept their carbon monoxide detector kept going off in their house, and they couldn't figure out why, because they don't even have a gas appliance in there, right? What I determined was the carbon monoxide was actually being drawn in on the intake air of the HRV because the intake air was situated right beside where they parked the cars. So in colder weather, the guy would, the husband would start the car up, let it run for 10 minutes before he left. Well, that air was being drawn into the house, and it was very consistent. The carbon monoxide detector seemed to go off at times after the vehicle started. So that basically we relocated the air intake, and they never had any problems. But this could have escalated to a serious situation, right? So again, that air intake is bringing fresh air into your house. It's not going to a furnace where it's going back in again. It's going into your house. So you have to be very conscious of where that air is coming from, right? Something that you want to definitely take note of. When you do a visual inspection on your HRV, this is they're relatively easy to be able to inspect. They're generally hanging from a ceiling area, usually in the same room as your furnace and hot water heater, your mechanical room, maybe located in a laundry room, for example, stuff like that. But it should be accessible. And most HRVs are made so that they have two clips on top. They're like little I don't know what you want to call them, like suitcase clips. You just give them a little pull from the top, and they'll snap down, and then the whole panel will swing down like this. You can see the panel here on plastic hinges. If this panel gets in your way, all you have to do is lift the panel a little bit, give it a little bit of a wiggle to the right, and it'll actually pull it out of the hinges, or pull it out of the hinge part, because it's like a pin in there. And you can take the door right off, right? When you when you look at the inside of these exchangers, this is going to tell you a whole lot about what's been going on in that house before you ever got there. If it's full of bugs and cobwebs and dirt and stuff like that, you know that this unit hasn't been maintained properly, right? A good indication. You're going to see some pipes coming in. One is going to be the air intake, which would be, say, for let's see here, fresh air to home, fresh air out. So this is coming, the air is coming in at this point. They're actually marked. They're kind of confusing. The air comes in from outside, goes through this, cuts through the exchanger, as we want to, I might want to call it a core, and then this goes into your home. All right. This air that is coming out from the house goes out through there, goes through the exchanger. So this is where your little heat transfer takes place, and then it is exhausted out the house. These exhaust and air intakes on the outside are very common to find them side by side, but generally at least 4 feet apart, maybe even 5. It will depend on what the manufacturers specify. They need to be further apart, so you're not drawing air in from the same place you've been exhausting it from, right? So if they'll have little filters on the two sides here of what we call the core. These are basically the only thing that filters the products that are coming in to keep it from plugging up the core. So these filters usually will have, a little collection of bugs. You can tell if you've had a bad ladybug season by pulling that out, and that's where that is one of the parts you do when you service these things. Is you'll take this, you'll clean these up, you will actually pull this out. This core will come out if you just give it a straight pull. There's little nylon or plastic ridges that hold it into place here and here and here and here, and you just put it back in after. What most service guys do when they're servicing an HRV will be they'll pull this out, they'll pull the core out, they'll clean this. Usually you can just use a vacuum to clean that, they'll shake them out. And this here, it's nice to, if you got a little bit of compressed air, or if you have a vacuum that you can blow some of the air out, because you'll want to blow through here. It's little wee thin sections of it's like plates. It's like a plate exchanger that you want to make sure is clear. Usually you don't have too many problems with them. So that goes back in. Now the problems that arise with these things is that they also have, and it's not shown on this diagram, is they'll have another port, and that's actually this one right here. This is a bypass airport, or a bypass sort of system. So what happens is, guess what? When the air temperatures really start dropping down and you get a cold day like you had yesterday, then this thing's not going to be able to provide you with air all the time because it's just too cold. There's actually a thermistor or like a thermostat inside these, so that it says, oh, you know what, this air is too cold. You can't just go and blast minus 25°C air back into the house. So what'll happen is this damper here will open up, so it'll draw air from inside the house through the system, so it tempers down the amount of it warms up the temperature of the incoming air to a point where it's manageable. It's not going to make your house temperature drop. So when that opens up, this has a damper in it, and it'll shut down to a certain point. Usually, when it's really cold, you'll get it to shut down to probably they'll be only 10% open. So you'll be drawing only 10% fresh air in compared to the rest here. Now, once it gets to a warmer point, this will open up. These will modulate a bit more, so you'll have your air mix will change. If it gets too cold, the unit will just basically shut down. It's going to have to go in defrost mode. In other words, you're freezing up this whole unit, and you're going to cause nothing but trouble. You're going to have all kinds of icing problems and stuff, and that happens. So on the bottom of these is a pan, and on the pan there is a drain hole. Usually there's two, one for each side, because these are different separate air chambers, we could call it. So these drain pans will handle any of the condensation that occurs inside these units. And yes, you're going to get condensation because guess what? You're pulling the air that you're pulling out of the house is going to have humidity it's going to be high in humidity, basically because you're drawing air from areas that require the air to be drawn out of. You're not taking it out of the whole house. You're taking it out of areas like the kitchen area, the bathroom area, sometimes the laundry area. You're not taking it away from the living room. You don't really, because you're depending on the fresh air that comes in to come into those areas to replace the air that's being exhausted out. So you're going to get a natural air movement within the house by exhausting air from bathrooms and kitchens and replacing it with fresh air that's been pouring in to the uh, living rooms and the bedrooms. Um, there's different ways that this happens. Most of the newer systems now have dedicated ductwork, so they're not tied into the existing ducting system, so that all your fresh air goes into bedrooms and into the living room area, and your exhaust air is a dedicated ductwork that comes from your bathroom grill areas and your kitchen areas. Those grills will be easy to identify. They're basically just a sidewall grill, usually about 8 inches by 10 inches in size. They're generally white, and they just sit, or they're situated near the ceiling level of a bathroom, and so you don't see that. What you do have, and in the kitchen you'll have the same thing, except those grills most of the time will incorporate a little hinge on them, so you can open up the grill, and behind it there'll be a little filter that you can take out and clean, because you're going to get grease and other things building up on on that filter, because you're cooking right basically below it. So it's pulling up air that's got, you know, whatever you've been cooking for breakfast. If you're a bacon freak, you may have to clean that filter about once every 2 months. Anyway, that's the thing. The controls on them are a little tricky, because we'll just go to this page, because the controls are normally, I'm not going to go to that page yet. Now I am. That the controls are normally situated in areas. Okay, for example, right here, there's a control. That would be basically your main control for that HRV. So this here would be set, and you would have a setting for it, like for comfort. It'll have a humidity level setting. You may have it set at 45% humidity, because that's comfortable humidity, right? That's normal. So that if the humidity level goes up above that percentage, it's not going to turn on the unit, because the unit runs steady. The way they're made is they run continuously. But what it's going to do is it's going to up the speed of the unit. So in other words, it's going to pump in and pump out more air. It's going to pump, or push out more air and pump in more, because you want to get rid of that humidity, right? So that's one control that'll do that. And a lot of times, depending on the manufacturer, they're very clear as to what settings they're at. They'll cut in automatically. You can manually do it from there, and whatever. They're wild and wonderful things when everything's working good. You will also run into controls in your bathroom and in your kitchen. And these controls, usually in the bathroom, are situated by the vanity, by your counter or your basin along the wall. And it could be just a push button, which means that you just give it a push. And what that does is it'll cut the humidifier on to high, and or to a high speed, and that'll usually be timed. It'll run automatically for 20 minutes before it shuts off. You might get a crank, you might have a crank timer on them, so you just turn it on, crank it up, and turn it on for 20 minutes. Basically, the length of time it would take to take a shower, get out, and have that room, have the humidity out of that room exhausted, right? So you'll have it there. You'll also have it by the kitchen, generally located somewhere on the outside wall area. It might not be, it might be over here, depends. But that again too can be a push button, or it can be automatic if the humidity starts to build up, because people do forget to activate things. Okay, well, if you push the button, it'll do the same thing. Come on for 50 or for 20 minutes, and your exhaust, it won't have a hood like this. You'll have a grill, or you might have a hood, but it'll be tied in somewhere. I doubt if you have a hood like that. You could have a hood, and that hood would actually be a kitchen vent hood that would be recirculating. It's not venting to the outside, but rather it's pulling the steam and whatever cooking odors up, coming into the vent hood and exhausting back out through a carbon filter, right? Very common. But your exhaust vent for your HRV would generally be located above the kitchen cabinet in that usually 14, 16-inch space you have between here and the ceiling, right? Anyway, same thing. You have a push button on there if you want, and turn it on to high while you're cooking. If you forget, well, guess what? This thing here is still going to sense the humidity in the system. It doesn't necessarily mean, I'm sorry, this here is only going to sense that. But inside the unit itself, most of them have an independent humidity sensor, so that if the humidity does climb up to a certain amount, it'll automatically cut in by itself, right? Sounds complicated, and yes, in a way they are, the way they're put together and stuff. But the whole thing is, it's relatively simple procedures to operate, and you really have to depend on the fact that they are working. What happens a lot of times is that they have problems with one thing or another, or somebody's just saying, "Oh, you know what? I don't want all that cold air in my house. I'm just heating it up, blah blah blah." So they shut them off, unplug them, or whatever, right? And what usually occurs is, you see how this is plugged in here, very convenient to unplug, right? A lot of times there'll be a ceiling, a receptacle mounted on the ceiling that it's plugged into, and it gets unplugged. If you come in and you see it's unplugged, you know that they haven't been operating it. Don't know why yet, and it's kind of hard to determine, because now you got to plug it in and start going through some of the jump through some of the hoops to figure out why this thing should be working, but it's not, why they have it unplugged. I would say half the time they unplug it because somebody's saying, I don't want to heat up that outside air. The other half of the time it's because something's broken. And there's a lot of things that break on these, and that's the problem. If these dampers don't open and close properly, it's not going to work. If for some reason you have blowers like these here, and there'll be two separate blowers, if the motor in one of them or anything packs up or starts making noise, they're going to shut it off. There's a lot of reasons why they've been shut down. None of them good, because I'll be honest with you, if the person has an HRV that is going to require significant repairs, if it's a blower assembly or control problems, you know what? You're almost cheaper to buy a new one, because by the time you start doing repairs on an older unit, it's going to cost you about the same. Average price for a unit. Now this one here is basically a single core. It's probably probably good to up to about 80 CFM. It would run around $700 to $900, right, for that unit. All the other bells and whistles is what it costs money too. But you can take this out and install a new one probably within a good journey. A good tradesman should be able to do that whole thing within a couple hours by himself. They're not heavy, stuff like that. So that's one of the things that you may want to know. HRV is not working. You know, if you don't want to get into too much depth of it, then there's something that they can say, well, you know what, that HRV is probably going to need replacement, but it costs us, $1,200 to do. Okay, we're going to keep that in mind when we put an offer in, right? So that's one thing. You will also run into larger units that will have two of these, right? So what happens is that now instead of just passing through one coil or core, they pass through two. So the air would go through this like normal, then it would go into it back up through, and then it would go back down again. So you may run into HRVs that are two. Some of the really good HRV manufacturers that you might want to take note of are Life Breath. They make an excellent HRV product. Venmar make a good HRV product, and Van E. They're all very good products. And it's important that you have a product that you can readily access repair parts if they're small, right? If it's a damper motor, that might cost you $100. That's an easy change if you can get the part. What else? Oh, the other thing that's important is, of course, this here again goes to this is a condensate drain. So this somehow has to go somewhere that's going to get rid of the liquid. There is not a lot of condensate that comes out of these tubes. There'll usually be, this one's only got one because this is a single core, but quite often if they have two, or if they have two, they'll have two drips coming out. This isn't going to have the same qualities as a furnace. It's not going to have it as, it's not going to be high acid. It's going to be basically water. You're not going to want to drink it, but you're not going to worry about having to deal with neutralizers or anything else. And a lot of times these can be tied in with your condensate pump if it's close by and you have a furnace close by and you have a condensate pump on it. It can be tied into the same type of setup that you have going in. There's actually an additional port on the condensate pump itself that would accommodate another tube going into it. So you can put this in. But one thing you want to remember about these is normally when they come out, it will have a loop on them like that. It doesn't show it, but there'll be a loop, and then it goes down to a drain. And one of the reasons of that loop is the fact that they want to be able to maintain a little bit of water in that tube. So it's not just a straight tube going down to a drain. It's got a little loop in it, like a trap. And it does two things. In case this is tied in by somebody into the main sewer, you're not going to get sewer gas going back into it, which it should never be tied into the main sewer. It could be tied, it could go to a floor drain, but you have to maintain an air gap between so you don't have any chance. You got to make sure it doesn't have any chance of getting sewer gas back through into the unit, because guess what? It's going in here, it's going into your house, right? That and the fact that when this is on, this is pressurized. So there's always going to be a certain amount of pressurized air in here. And if you don't have some kind of a trap in here, then that air is just going to blow out all the time. It's blowing out. Again, if you don't get a lot of condensate coming out of here. Even if it ran to a pail, that wouldn't be a big concern, because you'd be lucky if you accumulated a gallon of water a week out of those things. When you're looking at the drain, you want to determine the fact that yes, the tubing looks good and it's not clogged, because there's not a lot of water flow or fluids flow through the tube. A lot of the time you'll get sediment building up, and you can usually tell because these are generally a clear vinyl tube coming out of them. And if they're discolored or they look really grody, like brown or black, then it probably doesn't have to be replaced, but it definitely has to be pulled apart, flushed out, and be put back in. That's basically all I can say about that. Um, let's take some questions on HRV before I move on to the last thing. Alex?
I think we've been feeling them, to be honest. I think we're good.
Great.
Yeah, we're just trying to wrap up by 3 here.
Okay, so we're going to just, last couple of slides is regarding air conditioners. Again, another specialized trade. So there's not many things that you can really check on air conditioning equipment. You'll know that say that it'll have a coil above the usually installed above the furnace in the plenum, and all you'll be able to see of that will be condensate drain coming out, which would be a white tubing, similar to the to what you see coming out of the furnace. That again has to go to some type of a drain situation. Again, sometimes they're not as susceptible to having that acid build up like you would in a furnace. So they may not have a neutralizer on them. And again, they can be tied in also to the condensate pump, which is what usually happens, is that they're tied in to the condensate pump. But the important thing is to remember about them is that they need some type of a trap on them also, because otherwise, when your furnace blower goes on, all you have is air coming strictly out of that unit, right? Now, some coils that are installed actually have a built-in condensate trap. Some of them come with a factory condensate trap that you can tie into that port on the outside of the duct. So it sort of takes care of that problem. You don't have to worry about making a little P trap out of your PVC pipe with a T on it. Um, those are things. A lot of times, you those will clog up, which is a problem. If that piping clogs up or whatever, then any of the condensation that occurs inside of the unit on the evaporator coil. I don't know if you have a picture of that in your module. I'm not sure. Just let me know if you do. Um, what'll happen is that moisture will overflow because there's a drain pan underneath the evaporator coil inside your furnace plenum. That moisture will start to flow over and it'll drip on your furnace. So it's important to make sure that the condensate drain is clear. One of the ways that you can probably do this without a great deal of problem is take that little special flower pot or flower watering pot you have that you use to pour water in the condensate pump. Take it and pour it onto the top. These will always have a T on top. So you pour it onto the top of the T so the water will flow straight through the T down the pipe, and it should come out that condensate. And if it goes into the condensate pump, it should flow into the pump, activate the pump the same way you would as if you were doing it from the pump itself, right? That's important. Those things will clog up fairly often. A big thing that you want to that a serviceman is supposed to check, but often is neglected, right? There's a device on the market that uses compressed air, just an aerosol can, has a little end on it that you can put over the T and give it a little shot. It'll blow some compressed air down, and it'll blow any of the sediment that might be collecting on the inside of the pipe out. The outside unit is called the air condenser. Now you get to see this a little bit more. It's a lot easier to see. And what you're going to want to look for is basically you're going to do a visual exam. I'm not sure if Alex recommends taking the electrical plate off to take a look at the electrical wiring inside. But what you need to know about these is they need to have a disconnect right here. They have to have a disconnect on the outside. In other words, some way of shutting the power off. Generally, it's not a switch because these are 240 volt units, so they won't be a switch. It could be a little weatherproof box that has a breaker in it. They can be a box that has what they have a like it's like a little it's like a breaker also, but instead of popping or switching the breaker on and off, you got to pull this little section down. This company called Cutler Hammer make them. They're very popular because they're cheap, but servicemen know how to use it. Just be careful if you do. And you want to just check the condition of that, that the wiring going to the unit is approved. Generally, it's a jacketed wire. It's not BX because it's outside, so it has to be coated. It'll be tech cable, coated wire. And if you look inside, I guess the only thing that you're really going to be able to see is if there's any wiring problems. And it's very hard to determine whether you have Freon leaks at this point because Freon, the refrigerant that's used now, doesn't leave too many traces behind if it has a slight leak. In the old days with the old type of refrigerant that's now not approved anymore, then you used to have little purple spots around that would determine a leak. The only way you'd be able to detect a leak, if there was one, is with an electronic leak detector that similar to what I have there. You want to check that. Now, as far as that goes, but what you do want to take a look at is on the outside, they'll have fins, right? You've got your fins. These fins are all aluminum. They'll be protected with metal, metal protection so that, you can't, you're not exactly open that. These fins are very important. It's important that they're in good condition. They're not flattened out they haven't been beat up by kids kicking soccer balls against it or hitting it with hockey pucks. Because if that happens, then you're not going to get the proper air flow through these, which significantly affects the operation of the air compressor themselves. So you want to check them. You want to make sure that they're not damaged, that they're not plugged up with grass, because people have a habit of mowing their lawn and blowing the grass on the air conditioner. Naughty. If it looks like it's weather beaten or there's been signs of corrosion on here, probably a good indication that that the owner wasn't covering these up in the wintertime. So they've been sitting there all winter with snow on them. This is where the fan is, this great big fan here. You want to check and make sure there's no problems with the fan. They're just basically aluminum blades on them. And when the condenser turns on, when you go and fire up the air conditioner inside, the first thing you're going to want to do, as part of the inspection, is you're going to come outside and you're going to wait. It usually takes a minute or two before this kicks in. It'll kick in, and all this should be running and in order. If it makes a noise like a grinding noise, definitely could be bearings going on the fan motor, which is right here. That's something to take note of. If it doesn't come on at all, definitely take note of that, because that means you're not getting any air conditioning. If it's not really your place, you're not to say whether this thing is cooling or not, but air conditioners, if they run and they don't cool, it's usually a indication that there is that this needs a charge, a refrigerant charge, right? So the service technician would come in. Most of the time, if a unit has lost most of its pressure, then it's going to be it's very important that they put a pressure test on it, usually with nitrogen, test it and then find out where the hell this leak is coming from, because you can't just keep dumping refrigerant in there all the time. This stuff costs $2 an ounce, and it's quite easy to put 36 ounces into a compressor if it's down low, right? So if it leaks out in a month, there you go. So any questions regarding air conditioning? You guys still with me, or have you all taken off?
We're here.
Ah, great. Okay. The last note that I want to say is that there's much to know about about the HVAC systems. Obviously, we've managed to cover as much as humanly possible in the time we've been given, and I want to emphasize to you the fact that you're going to have to take it upon yourself to further any of the knowledge that that you need to acquire in order to become proficient in doing inspections, specifically us in this area, because it can be a very confusing area. Most people, all they really worry about is the fact is my furnace either runs or it doesn't. My air conditioner either runs or it doesn't. Nothing in between, right? So those are things that you may want uh, to expand on. I'm going to give you a tip. If you have a plumbing or an HVAC wholesaler nearby, like Wolseley or I don't know who the big HVAC wholesalers are, refrigerant supply. I'm not sure if they even operate in Calgary anymore, but Wolseley's pretty prominent. Go into one of those. They have actually they have publications that come out monthly that have some really good information on it that aren't that are geared more or less to the serviceman and the contractors, but great tips that you pick up on from your own. Not only that, but they will also have information addresses for many manufacturers that they deal with. And because they're a Canadian product, you're dealing with products that you're going to find in Canada. You know, you don't have to like worry about going through the Japanese internet to find something that has never been made here and never been imported here, right? There's a lot of different things. A lot of homes have mini split systems in them, which we haven't dealt with. It's all on this, and that's like a heat cool unit that is self-contained in a sense. It has an inside air unit, and the outside is where your condenser is for cooling. You may have heat pumps. There's a lot of different things that you're going to run into, and all I can say is that carry on with it, and just keep lifelong learning is a must. I know I've been lifelong learning for years, and I keep forgetting most of the stuff that I've ever learned. And remember, don't believe everything you see on YouTube. So best of luck, and we'll hopefully have a chance to talk with you again someday. Thank you very much.
Thanks again, Vern. So once again, guys, thanks for everything. Again, if you have any questions for Vern or myself, by all means do send us an email. Again, we will be posting these recorded sessions here probably early next week. If you guys are able to provide some feedback forms, that would be great as well. Other than that, talk to you guys soon. We will be likely having the next session in April as well. So you guys have a good day.
Likely have me, did you say?
We'll be having the next session in April. Yeah, you betcha.
Oh, yeah. You never know who's going to run that one.
Exactly.
Uncle Buck may be sent down the road. Okay. Anything you want to talk about before we sign off?